Hello, Namaskara. I welcome you all to the Vedantu Karnataka. Nanu Nama Master Teacher Rithika Ma'am. So, am I audible and visible properly to everyone? Sariyag visible with audibility idena? Just check it and tell it in the chat box, everyone. Is it audible and visible properly to everyone? Yes. So today's topic is about some basic principles on its techniques. Okay. So in the first chapter of the first PUC idu. So first chapter of the PUC is little bit of basics. ಜಾಸ್ತಿ ಇದರ ಸ್ವಲ್ಪ ಬೇಸಿಕ್ಸ್ ಇದೆ. ಆಮೇಲೆ ಸ್ವಲ್ಪ ಡೀಟೇಲ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಮಾಡಿದ್ದಾರೆ ಇದರಲ್ಲಿ. ಲೈಕ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ವೆರಿ ವೆಲ್. ಅಂದ್ರೆ ಈ ಉಳಿದಿದ್ದೆಲ್ಲ ಕೆಮಿಸ್ಟ್ರಿ ನಿಮ್ ಚಾಪ್ಟರ್ಸ್ ಏನಿದೆ ಅಲ್ಲ ಅವೆಲ್ಲ ಈಸಿಯಾಗಿ ಆಗುತ್ತೆ ನಿಮಗೆ, ಆಯ್ತಾ? ಸೊ ಲೆಟ್ಸ್ ಲರ್ನ್ ಇಟ್ ಇನ್ ಡೀಟೇಲ್ ಸೋ ದಟ್ ಇಟ್ ವಿಲ್ ಬಿ ವೆರಿ ಮಚ್ ಯೂಸ್ಫುಲ್ ಫಾರ್ ಯು ಪೀಪಲ್, ಆಯ್ತಾ? ಸೊ ಏನ್ ಡೀಟೇಲ್ ಅಂತ ಮ್ಯಾಮ್ ಹೇಳ್ತಿದ್ದಾರೆ ಅಂದ್ರೆ, ನಾನು ಸ್ವಲ್ಪ ನಿಮಗೆ NCERT ತರನು ಕಲಿಸ್ತಿದ್ದೇನೆ. ವೈ? ಬಿಕಾಸ್ NCERT ಬುಕ್ ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ನಿಮಗೆ ಕ್ಲಾಸಸ್ಗೆ, ಲೈಕ್ ನೀಟ್ಸ್ ಅಂಡ್ KCET. ಓಕೆ, ಸೊ ಇವತ್ತು ಅದನ್ನ ಫಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋಣ so that it will be easy for you to understand the concept very well. Okay, so let's start. So each chapter in the hi everyone, hi. Yes. Okay, 1 second guys. Okay, so each chapter in the ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಬೀಳ್ಬೋದು ಅನ್ನೋದು ಫಸ್ಟ್ ಹೇಳ್ತೇನೆ ನಿಮಗೆ. Then afterwards you will have an idea like what you people want to learn it. Okay, so idu actually we are going to take a NEET class today. Today's is the class of NEET. So NEET nalli ee chapter inda almost okay 2 to 3 questions ana keltare, aita? 2 to 3 questions ana keltare. So ee 2 to 3 questions dinda almost 2 to 3 questions inda ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಬೀಳ್ಬೋದು ಅನ್ನೋದು ಹೇಳ್ತೇನೆ ನಿಮಗೆ. 8 to 10 marks will be there in your 720 marks. Okay, 720 marks in the 8 to 10 marks irutte. Clear? Yes, I'm not audible properly, I guess. Mic hakolod marbitte nodi. Give me 1 second guys. Yes, now I'm audible properly. Audible then iga ಸ್ವಲ್ಪ ಮೈಕ್ ಇಶ್ಯೂ ಆಗುತ್ತೆ ನೋಡಿ. Yes, done. I'm audible now properly to everyone. Hope so. So in case ಏನಾದರೂ ಪ್ರಾಬ್ಲಮ್ audibility ಇದ್ರಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಇದ್ರೆ ಹೇಳಿ, ಆಯ್ತಾ? ಸೊ ಈ ಸಮ್ ಬೇಸಿಕ್ ಪ್ರಿನ್ಸಿಪಲ್ಸ್ ದಿಂದ ಆಲ್ಮೋಸ್ಟ್ 2 to 3 ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ. 8 to 10 ಮಾರ್ಕ್ಸ್ ನೀಟ್ ನಲ್ಲಿ ಬರುತ್ತೆ, ಆಯ್ತಾ? ಸೊ ನಾನು ಯಾಕೆ ಫಸ್ಟ್ ನೀಟ್ ಫಸ್ಟ್ ಇಯರ್ ಚಾಪ್ಟರ್ಸ್ ಅನ್ನ ಮುಗಿಸ್ತಿದ್ದೇನೆ ಅಂದ್ರೆ, ಸೊ ದಟ್ ಇಟ್ ವಿಲ್ ಬಿ ಈಸಿ ಫಾರ್ ಯು ಪೀಪಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ವೆರಿ ವೆಲ್. ಓಕೆ, ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ವೆರಿ ವೆಲ್. ಸೊ ಒಂದು ಸ್ವಲ್ಪ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆದ್ರೆ ಕಾನ್ಸೆಪ್ಟ್ ನಿಮಗೆ ಐಡಿಯಾ ಗೊತ್ತಾಗುತ್ತಲ್ಲ ಯಾವ ತರ ಆಕ್ಚುಲಿ ನೀವು ಓದ್ಬೇಕು ಅನ್ನೋದು, ರೈಟ್? ಸೊ ಇವತ್ತು ನಿಮಗೆ ಎಲ್ಲ ಅದನ್ನ ಮುಗಿಸೋಣ ಚಾಪ್ಟರ್ಸ್ ಡೀಟೇಲ್ ಆಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಆಮೇಲೆ ವಿ ವಿಲ್ ಡೂ ದ ಸೆಪರೇಟ್ ಸೆಷನ್ ಆಲ್ಸೋ ಫಾರ್ ದ ಸಪ್ರೇಟ್ ನೀಟ್ PYQs ನಲ್ಲಿನೇ ಸಪ್ರೇಟು. ಸೊ ಅದನ್ನ ಕುಂತು ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ಬಿಕಾಸ್ ಇಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಫಸ್ಟ್ ನೀವು ಥೇರಿ ಕುಂತು ಓದಿದ್ರೆ ಥೇರಿ ಅಷ್ಟೇ ಆಗಲ್ಲ. ಸೊ ಥೇರಿ ಅಷ್ಟೇ ಮಾಡ್ತೇನೆ ಅಂದ್ರೆ ಅದು ಆಗಲ್ಲ. ಸೊ ಇಟ್ ಶುಡ್ ಬಿ ಲೈಕ್ ಹೌ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ಕಾನ್ಸಂಟ್ರೇಟ್ ಆನ್ ದ ಥೇರಿ ಆಲ್ಸೋ. ಯು ನೀಡ್ ಟು ಕಾನ್ಸಂಟ್ರೇಟ್ ಆನ್ ದ PYQs ಆಲ್ಸೋ. ಸೊ ಎಷ್ಟು ಥಿಯರಿ ಪರ್ಫೆಕ್ಟ್ ಆಗುತ್ತೆ PYQs ಮಾಡಲಿಕ್ಕೆ ಅಷ್ಟೇ ನಿಮಗೆ ಈಸಿ ಆಗೋದು. ಸೊ ಅದನ್ನ ನೀವು ನೆನಪಿಟ್ಕೋಬೇಕು. ಫಸ್ಟ್ ಮೇನ್ ಥಿಂಗ್ ಅಂದ್ರೆ ಅದೇ ನೆನಪಿಟ್ಕೊಳ್ಳೋದು, ಆಯ್ತಾ? ಸೊ ಅಂಡ್ ಸೆಕೆಂಡ್ಲಿ ವಾಟ್ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ಡೂ ಸೆಕೆಂಡ್ಲಿ ಇಸ್ ಅಬೌಟ್ ಸಾಲ್ವಿಂಗ್ ದ ಕ್ವಶನ್ಸ್ ಇನ್ ಅ ಕರೆಕ್ಟ್ ಟೈಮ್. ಸೊ ಕರೆಕ್ಟ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಆಫ್ ದ ಟೈಮ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ನೀವು ಕ್ವಶನ್ಸ್ ಅಂತೂ ಸಾಲ್ವ್ ಮಾಡ್ತೇನೆ ಅಂತ ಕುಂತು ಬಿಡ್ತೀರಾ, ಬಟ್ ಒನ್ ಮಿಸ್ಟೇಕ್ ಏನು ಮಾಡ್ತೀರಂದ್ರೆ, ಸೊ ಟೈಮಿಂಗ್ ನೋಡ್ಕೊಳ್ಳಲ್ಲ. ನಮ್ಮ ಮ್ಯಾಮ್ನ ಎಲ್ಲ ಕ್ವಶನ್ ಸಾಲ್ವ್ ಮಾಡಿದೆ, ಫುಲ್ 720 ಮಾರ್ಕ್ಸ್ ಎಲ್ಲ ಕಂಪ್ಲೀಟ್ಲಿ ಮುಗಿಸ್ಬಿಟ್ಟಿದೆ ಚಾಪ್ಟರ್ದು. ಓಕೆ, ಅಗ್ರಿ, ಯು ಪೀಪಲ್ ಆರ್ ಡೂಯಿಂಗ್, ವಿ ಆರ್ ಹ್ಯಾಪಿ. ಬಟ್ ಒನ್ ಪ್ರಾಬ್ಲಮ್ ಏನು ಮಾಡ್ತಿದ್ದಾರೆ ಅಂದರೆ ಟೈಮಿಂಗ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಮಾಡ್ಕೋತಿಲ್ಲ ನೀವು, ಆಯ್ತಾ? ಸೊ ಯು ನೋ ವಿ ಹ್ಯಾವ್ ಅ ನೆಗೆಟಿವ್ ಮಾರ್ಕ್ಸ್ ಹಿಯರ್. ನೀಟ್ ಎಕ್ಸಾಮ್ನಲ್ಲಿ ನೆಗೆಟಿವ್ ಮಾರ್ಕ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಈ ನೆಗೆಟಿವ್ ಮಾರ್ಕ್ಸಿಂದ ನೀವು ಹಿಂದೆ ಉಳಿಬಹುದು. ಒಂದು ಪ್ರಾಬ್ಲಮು ಒಂದು 10-15 ನಿಮಿಷ ಇಟ್ಕೊಂಡು ಕುಂತ್ಬಿಟ್ರೆ, ಈಗ ಯಾವುದಾದ್ರೂ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಗೊತ್ತಿದೆ ಅಪ್ಪ, ಶಾರ್ಟ್ ಗೊತ್ತಿದೆ, ಆ ಪ್ರಾಬ್ಲಮ್ ಎಲ್ಲ ಬಿಟ್ಬಿಟ್ರೆ, so that is what the problem will be faced by many of the students with that itself. So you need to make sure that time management should be there, and ಯಾವ short questions ಇದೆಯಲ್ಲ ಆ short questions ಅನ್ನ ಫಸ್ಟ್ ಮುಗಿಸ್ಬಿಡೋದು. ಅಂದ್ರೆ ಮುಗಿಸಿದ ತಕ್ಷಣ ಯಾವ್ಯಾವ ನಿಮಗೆ ಡೌಟ್ಫುಲ್ ಇದೆ ಅಲ್ಲ, ಬಟ್ ಆಲ್ಸೋ ಐ ವಾಂಟ್ ಟು ಅಟೆಂಪ್ಟ್ ಇಟ್ ಮೈಟ್ ಬಿ ಕರೆಕ್ಟ್ ಅಂತ ಇದೆ ಅಲ್ಲ, ಆ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಅಟೆಂಪ್ಟ್ ಮಾಡಬೇಕು. ಈ ತರ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ, ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಅದು ಈಸಿ ಆಗುತ್ತೆ, ನಿಮ್ಗೆ ಐಡಿಯಾ ಗೊತ್ತಾಗುತ್ತೆ ಯಾವ ತರ ಮಾರ್ಕ್ಸ್ ಬೀಳ್ಬಹುದು ನಿಮಗೆ ಅನ್ನೋದು, ತಿಳಿತಾ? ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ಐ ವಾಂಟೆಡ್ ಟು ಗಿವ್ ಸಮ್ ನಾಲೆಜ್ ಫಾರ್ ದ ನೀಟ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಹೂ ಆರ್ ಸೀಯಿಂಗ್ ಇಟ್. ಕ್ಲಿಯರ್? Yes, hi everyone. Hi. Okay, let's start the chapter right now. I have given some brief details about the chapter right now. So, ee chapter nalli detail explanation ಮಾಡ್ಕೋಬೇಕು because ಎಲ್ಲ basic concepts ಎಲ್ಲ ಇದೆ ಇದರಲ್ಲಿ, so that it will be useful for the upcoming also. Okay, and main thing, if anyone students are seeing for the purpose of boards or for the KCET or JE also, it will be useful short. Why? Because I'm going to teach in detail about the theory more, so it will be really be useful to you students also. So ಯಾರಾದರೂ ಬೇರೆ ಕ್ಲಾಸಸ್ ನೋಡ್ತಿದ್ರೆ, it can be useful to you people separately also. You can watch it out for your extra knowledge. Clear? So let's start the chapter now. First is about the general introduction. Let us check it out. What is the general introduction ಅಂದ್ರೆ ಏನೇನು ಓದಬಹುದು ನೀವು ಈ ಚಾಪ್ಟರ್ ಇಂದ, ಆಯ್ತಾ? ಸೊ ಲೈಕ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್, ಒಂದು ನಿಮಿಷ. Yes. Organic compounds are essential for life, found in DNA, proteins, blood, muscles and skin. So this organic compounds are present in our whole body actually. So ಈಗ ನನ್ನ ಕೂದಲ ನೀನು ಇದೆ, we are eating the proteins right now. ಏನಾದರೂ ಪನ್ನೀರ್ ತಿಂದ್ವಿ, ಚಿಕನ್ ತಿಂದ್ವಿ, ಮಟನ್ ತಿಂದ್ವಿ, ಅವೆಲ್ಲದರಲ್ಲಿನೂ ಪ್ರೋಟೀನ್ಸ್ ಇರುತ್ತೆ, ರೈಟ್? ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್ ಅಬೌಟ್ ದ DNA ನಲ್ಲೂ ಎಲ್ಲ ಟೈಪ್ಸ್ ಆಫ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಇರುತ್ತೆ. ಯಾವ ತರ ಇರುತ್ತೆ ನೀವು ಬಯಾಲಜಿನಲ್ಲಿ ಆಲ್ರೆಡಿ ಕಲ್ತಿರಬಹುದು ಅದನ್ನ, ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ ದೇ ಆರ್ ಯೂಸ್ಡ್ ಇನ್ ದ clothing, fuels, polymers, dyes and the medicines. Yes, they are used in all of the things. Even you're eating the food, in that also it has been used. Now also it's been used in everywhere. I'm speaking right now, the saliva is actually moving out in my mouth, right? There also the organic compounds are present. Okay, now organic chemistry begins in 200 years ago, around 1780. It has been actually been introduced, means 200 years ago ಅವ್ರಿಗೆ ಗೊತ್ತಾಯಿತು ಯಾವ ಥರ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಇದೆ ಮತ್ತು ಕೆಮಿಸ್ಟ್ರಿ ಹೇಗೆ ವರ್ಕ್ ಆಗುತ್ತೆ, ಹೌ ದ ಕೆಮಿಸ್ಟ್ರಿ ಇಸ್ ಬೀನ್ ಯೂಸ್ಡ್ ಇನ್ ಅ ಡೈಲಿ ಲೈಫ್. ದಿಸ್ ಆಲ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ವೇರ್ ಆ್ಯಕ್ಚುಲಿ ಡನ್ ಇನ್ ದ 200 years ago, ಆಯಿತಾ? ಸೊ 200 years ago ಅವರು ಇದನ್ನು ಡಿಸೈಡ್ ಮಾಡಿದ್ರು, ಹೇಗೆ ನಡೀತಿದೆ, ಏನು ಆಗ್ತಿದೆ ಅನ್ನೋದು ಇವರಿಗೆ ಗೊತ್ತಾಗಿದೆ. ನೆಕ್ಸ್ಟ್, ಅರ್ಲಿ ಕೆಮಿಸ್ಟ್ ಬಿಲೀವ್ಡ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಕೇಮ್ ಓನ್ಲಿ ಫ್ರಮ್ ದ ಲಿವಿಂಗ್ ಥಿಂಗ್ಸ್ ಡ್ಯೂ ಟು ದ ವೈಟಲ್ ಫೋರ್ಸ್ ಥಿಯರಿ, ಸೊ ಪ್ರಪೋಸ್ಡ್ ಬೈ ದ ಬೆರೆಜಿಲಿಯರ್ಸ್. ಸೊ ದಿಸ್ ಬೆರೆಜಿಲಿಯರ್ಸ್ ವಾಟ್ ದೇ ಡಿಡ್ ಇಸ್ ದೇ ಥಾಟ್ ಆಕ್ಚುಲಿ, ಓಕೆ, ದೇ ಥಾಟ್ ಇಟ್ ಲೈಕ್ ವಾಟ್. ಸೊ ಅರ್ಲಿ ಕೆಮಿಸ್ಟ್ ಏನು ಬಿಲೀವ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಲಿವಿಂಗ್ ಆರ್ಗ್ಯಾನಿಸಮ್ಸ್ ಯಾವ್ದಿದೆ ಅಲ್ಲ ಅದ್ರ ಪ್ರಕಾರನೇ ಅವ್ರು ಅಷ್ಟೇ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಅನ್ನ ಆಕ್ಚುಲಿ ಮಾಡ್ತಿದ್ದಾರೆ. ರಿಮೈನಿಂಗ್ ಪೀಪಲ್ ಆರ್ ನಾಟ್ ಡೂಯಿಂಗ್ ಎನಿಥಿಂಗ್ ಅಂತ ತಿಳ್ಕೊಂಡ್ರು. ಮೀನ್ಸ್ ನಾನ್ ಲಿವಿಂಗ್ ಥಿಂಗ್ಸ್ ಆರ್ ನಾಟ್ ಹ್ಯಾವಿಂಗ್ ಎನಿ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಇದೆ, ಬಟ್ ಲಿವಿಂಗ್ ಥಿಂಗ್ಸ್ ಯಾವ್ಯಾವ ಇದೆ ಅಲ್ಲ, ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ ವಿ ಪ್ಲಾಂಟ್ಸ್ ಅಂಡ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ಆರ್ ಲಿವಿಂಗ್ ಥಿಂಗ್ಸ್, ರೈಟ್? ಸೊ ಲಿವಿಂಗ್ ಥಿಂಗ್ಸ್ ಯಾರ್ಯಾರಿದೆ ಅಲ್ಲ ಅವಕ್ಕೆಲ್ಲ ಕೆಮಿಸ್ಟ್ರಿ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಇದೆ. Okay, non-living things ge organic compounds illa anta, it was a belief of the Berzelius. Okay, this scientist, means he proposed it in that way because of what? Because of the vital force. Okay, vital force andre niಮಗೆ already ಗೊತ್ತಿದೆ, right? Next, the theory was disproved in 1828. So it was disproved, means what? He told like no, it's not only in the living things, it's also in the non-living things also. Okay, now when F Wolfer synthesized the urea, that is NH2CONH2 from the ammonium cyanate, that is NH4CNO, that time he got to know that organic compounds are even beyond it. Okay, organic compounds are present not only in the living things, it's present in the non-living things also. It's not like if there is a non-living things then they don't have any organic compounds inside them. You know, it's like now, right now at least everyone got to know that each and every concept, each and everything is actually made up of what? Organic compounds itself, right? Next comes what? Later the Kolbe, that is 1845. We have learnt about the Kolbe already. This person has told about a Lewis dot structure for us. So many things he has told it. Okay. This Kolbe in 1845 made acetic acid, and the Berthelot, that is 1856, made methane, proving organic compounds can be made in the lab also. So organic compounds can be prepared in the laboratories also. So ಇದರಿಂದ ಕೆಮಿಸ್ಟ್ರಿದಲ್ಲಿ ಇಂಪ್ರೂವ್ಮೆಂಟ್ಸ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಯಿತು. ಓಕೆ, ಕೆಮಿಸ್ಟ್ರಿ ಯಾವ ಥರ ಇಂಪ್ರೂವ್ಮೆಂಟ್ಸ್ ಆಯಿತು? ಸೊ ಇವ್ರಿಗೆ ಗೊತ್ತಾಯ್ತು, ಈಗ ಏನಪ್ಪ ಗೊತ್ತಾಯಿತು, ಲೈಕ್ ಹೌ ಅಂಡ್ actually how we can prepare the things in the laboratories also, how we can prepare the things in the normal days also. That is very important to know, right? So ಈಗ ಮೊದಲು ನಮಗೆ ಗೊತ್ತಿರಲಿಲ್ಲ, ಆಕ್ಚುಲಿ ಸನ್ ಇದೇನೋ, ಮೂನ್ ಇದೇನೋ, ಇವೆಲ್ಲ ಇದೇನಿಲ್ಲ, ನಮಗೆ ಗೊತ್ತೇ ಇರಲಿಲ್ಲ. ಬಟ್ ನಾವು ವಿ ನೋ, ದ ಸೈಂಟಿಸ್ಟ್ ಹ್ಯಾವ್ ಕೆಪ್ಟ್ ದ ನೇಮ್ಸ್ ಫಾರ್ ಈಚ್ ಅಂಡ್ ಎವ್ರಿಥಿಂಗ್, ಸೊ ವಿ ನೋ ಇಟ್ ಅಂಡ್ ವಿ ವಿಲ್ ಫೀಲ್ ಇಟ್ ಆಸ್ ಅ ಸಿಲಿ ಥಿಂಗ್ಸ್ ರೈಟ್ ನಾವು. ಓಕೆ, ಬಟ್ ಸೈಂಟಿಸ್ಟ್ ಅಕಸ್ಮಾತ್ ಹೆಸರೇ ಇರ್ತಿರ್ಲಿಲ್ಲ ಅಂದ್ರೆ ನಮಗೆ ಗೊತ್ತು ಆಗ್ತಿರಲಿಲ್ಲ ಅದು, ರೈಟ್? ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಐ ವಾಂಟೆಡ್ ಟು ಎಕ್ಸ್ಪ್ಲೇನ್ ಯು ಪೀಪಲ್. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? Tetravalence of a carbon, shapes of organic compounds. So now next thing is, now they got to know all the compounds are there and all the stuff, but what are the shapes, how the shapes are present for them, and how it's been working there, that is also very important to know, right? That is also very important to know. Yes, I am audible and visible properly to everyone, right? Clear? So next we will start with the tetravalency of carbon shapes of organic compounds. Now the shapes of a carbon compounds is understanding the molecular structure helps predict the properties of the organic compounds. Like if you understand the molecular structure of the things, like molecular structure andre eno, so like molecular structure andre yavado on carbon ideyappa, carbon structure inde. Now in case carbon is getting bonded with something, then what is the structure of that? So this all things, if you get to know the molecular structure of those things, it will help to predict the properties of those. Means what is its character? Okay, ಈಗ ನೋಡಿ ನಾ ಇದೇನೆ, ಈಗ ವೇದಾಂತ ಟಿ ಶರ್ಟ್ ಹಾಕೊಂಡಿದ್ದೇನೆ, ನಾನು ಮಾಸ್ಟರ್ ಟೀಚರ್ ಇದ್ದೇನೆ, ರೈಟ್? ಸೊ ನಾವು ವೇದಾಂತ ಮಾಸ್ಟರ್ ಟೀಚರ್ ಈಗ ಯಾರಾದ್ರೂ ಒಬ್ರು ನೋಡಿದ್ರಪ್ಪ, ದೇ ವಿಲ್ ಪ್ರಿಡಿಕ್ಟ್ ಮೀ. ಓಕೆ, ದೇ ವಿಲ್ ಪ್ರಿಡಿಕ್ಟ್, ಓಕೆ ಶಿ ಇಸ್ ಅ ಟೀಚರ್, ಶಿ ವಿಲ್ ಟೀಚ್. ಸೊ ಅದಂತೂ ಗೊತ್ತಾಗುತ್ತೆ ಅವ್ರಿಗೆ, ರೈಟ್? ಮೀನ್ಸ್ ವಾಟ್ ದೇ ವಿಲ್ ಗೆಟ್ ಟು ನೋ ಮೈ ಕ್ಯಾರೆಕ್ಟರ್ ಬೈ ಸೀಯಿಂಗ್ ಮೀ. Right, they'll get to know the character by seeing me. Same that. So molecular structure ಗೊತ್ತಾದ್ರೆ ನಮಗೆ ಈಸಿ ಆಗುತ್ತೆ, organic compounds ಗೊತ್ತಾಗುತ್ತೆ, right? Properties ಗೊತ್ತಾಗುತ್ತೆ ಅದರದ್ದು. So that is what the important thing about knowing the shapes of them. Okay. Next, carbon is a tetravalent forms the 4 covalent bonds through hybridization of S and P orbitals. So there will be a hybridization. We have already known about the hybridization. I think in your lower classes you have learned it about the hybridization. In case who has already studied about the hybridization, then you know how the hybridization word is being used. Next, types of hybridization let us learn. First thing is about the sp3. So sp3 in methane, there is CH4, that is going to be how much? If it is sp3, then it is going to be the tetrahedral shape. If in case it is a sp2 hybridization, means what? There is a 1s and 2p orbitals will be present. 1s orbital and 2p orbitals will be present. That is in ethene, that is C2H4, that is going to be what? Planar shape. It is going to be what? Planar shape. Next comes the sp in ethyne, that is C2H2, that is going to be what? That is linear shape. That is going to be the linear shape. Clear? This much you people understand, it's more than enough to you to understand the concept of hybridization. Okay, in detail you learn it in your different chapters also about the hybridization, don't worry. Okay, next comes what? Characteristic features of pi bonds. What is the meaning of a pi bond and what is the meaning of an sigma bond? Okay, sigma bond andre enu matte pi bond andre enu simple ಆಗಿ ಹೇಳ್ಕೊಡ್ತೇನೆ ನೋಡಿ. So pi bond is like head to head overlap. Okay, not head to head, it's like a lateral overlap, or a lateral overlap andre enu hugging by standing and we are hugging it, like that we can tell it. Okay, ಮತ್ತೆ sigma bond andre ಏನಪ್ಪ? head to head, ಯಾವಾಗಲೂ ಫೈಟ್ ಮಾಡ್ಕೊಂತ ಇರುತ್ತೆ, head to head it will fight like this. Okay, so that is called as a sigma bond. Pi bond andre lateral hugging. Okay, so now pi bond forms by the sideways overlap of a parallel p orbitals on the adjacent atoms. Sideways, or it is also called as a lateral also, not a problem. Okay, lateral antanu ತಿಳ್ಕೋಬಹುದು. Next, for the proper overlap, atoms must be lie in the same plane. That is example in the H2. That is going to be the example in the CH2 double bond CH2. Means what? It should be aligned properly. Okay, ಈಗ ಯಾರಾದರೂ ಒಬ್ರು ಹಗ್ ಮಾಡ್ತಿದ್ದಾರೆ ಅಂದ್ರೆ ಒಬ್ಬನ ಮಲ್ಕೋತಾನೆ ಒಬ್ಬನ ನಿಂತು ಹಗ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರುತ್ತಾ? ಇಲ್ಲಲ್ಲ. So it should be aligned properly. We have a positions to align also, right? If you are hugging, we need to straight hug. Means if you are going to hug properly, then that is going to be a straight hug, like that. Okay, in this way we need to understand the concept properly. Clear? Next comes what? p orbitals are parallel and perpendicular to the plane of the molecule. The p orbitals are parallel. It is going to be the parallel and the perpendicular to the plane of the molecule. Next, the rotation of C double bond is restricted because there is no free rotation. There is no free rotation. It means what? It is not allowed to freely rotate itself and go somewhere else. ಮೀನ್ಸ್ ಒಂದು ರಿಸ್ಟ್ರಿಕ್ಷನ್ಸ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಹೋಗಬಾರ್ದಪ್ಪ. ಈಗ ರೋಡ್ ಮೇಲೆ ಹೇಳಿರ್ತಾರಲ್ಲ, ಇದು ಒನ್ ವೇ ಇದೆ, ವಿ ಶುಡ್ ನಾಟ್ ಗೋ. ಬಟ್ ಬೆಂಗಳೂರಲ್ಲಿ ಯಾರು ಕೇಳಲ್ಲ, ದೇ ವಿಲ್ ಗೋ ಎನಿವೇರ್ ದೇ ಆರ್, ವೆರೆವರ್ ದೇ ವಾಂಟ್ ಇಟ್. ಓಕೆ, ದಟ್ ಈಸ್ ಅ ಮಿಸ್ಟೇಕ್ ವಿಚ್ ವಿ ಡೂ ಇಟ್ ಆಕ್ಚುಲಿ. ನೆಕ್ಸ್ಟ್, ಬಟ್ ಇದ್ರಲ್ಲಿ ಆಗಲ್ಲ. ಈ ಕಡೆಯಿಂದ ಹೋಗೋದಿಲ್ಲ ಅಂದ್ರೆ ಈ ಕಡೆಯಿಂದ ಹೋಗೋದೇ ಇಲ್ಲ. ಬಿಕಾಸ್ ಈ ಕಡೆಯಿಂದ ಹೋಗ್ಬಿಡ್ತಂದ್ರೆ ದಟ್ ಇಸ್ ನಾಟ್ ಅ ಕಂಪೌಂಡ್ ಇಟ್ ಸೆಲ್ಫ್, ದಟ್ ಕಂಪೌಂಡ್ ಡಸಂಟ್ ಎಕ್ಸಿಸ್ಟ್ ಇಟ್ ಸೆಲ್ಫ್. ಆಯ್ತಾ? Next, electron cloud of a pi bond lies above and below the bonding plane. So whatever the electron cloud of pi bond is there, it will lie above and below the bonding plane. Above and below the bonding plane. Okay. Next, pi electrons are more exposed, more reactive. Hence, pi bonds form the reactive centers in multiple bond compounds. So it will form a multiple bond compounds also. Clear with the pi bond? Next example also they have given for the problems also. You can concentrate here. That is CH double bond C single bond CH double bond CH single bond CH3. Here the pi are how many? 10. 4 are our CC bonds. 6 are CH bonds. And pi is going to be how much? 3. Clear? So in this way you need to solve the problems also. You can go through these problems also. These problems are also important. Clear? ಪ್ರಾಬ್ಲಮ್ಸ್ ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ, ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ನೋಡ್ಕೋಬಹುದು ಯಾವ ತರ ಬಾಂಡ್ಸ್ ಇದೆ ಅನ್ನೋದು. ಐ ಟೋಲ್ಡ್ ಯು ಪೀಪಲ್ ಹೌ ದ ಹೆಡ್ ಟು ಹೆಡ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಇಸ್ ಕಾಲ್ಡ್ as sigma bonding, and the lateral way, or it is also called as what? Lateral way, or it is also called as a sideways. So ಎರಡರದ್ದು pi bonds ಅಂತ ಕರೀತಾರೆ. ಆಯ್ತಾ? Next comes one problem which is there in your NCERT book itself, so that you will have an idea about the concept. So I am trying to solve these problems also. Okay. So first problem is what? They have told how many alpha and pi bonds are present in each of the following molecules. First option they have given is that HC double bond, one second guys. Okay. HC double bond, in case ಕಾಂತಿಲ್ಲ ಅಂದ್ರೆ ಇನ್ನೊಂದ್ಸಲ ಬರಿತಿದ್ದೇನೆ ಕ್ವಶನ್ ಅನ್ನ. CCH double bond CH3. Okay, CH double bond CCH double bond CH3. So this is the question they have given. They asked us to find out the pi and sigma bonds and pi bonds. Okay, ಇದರಲ್ಲಿ sigma bonds ಎಷ್ಟಿದೆ ಮತ್ತೆ pi bonds ಎಷ್ಟಿದೆ ಅನ್ನೋದು ಹೇಳಿದ್ದಾರೆ. ಆಯ್ತಾ? pi is also question mark to us and sigma is also question mark to us. Clear? ಉಲ್ಟಾ ಬಿಲ್ಟಾ ಹೇಳಿದೆ. Okay, so ಏನ್ ಬರುತ್ತಿಲ್ಲ ಆನ್ಸರ್. ಫಸ್ಟ್ we are going to see that sigma bond whichever is there, CC bonds are how many? Okay, CC bonds ಎಷ್ಟಿದೆ ನಮಗೆ? 4 ಇದೆ. Right, CC bonds ಎಷ್ಟಿದೆ ನಮಗೆ? 4 ಇದೆ. You can check it out. 1 2 3 4. Okay, done. 4 ಇದೆ. Done. Next comes what we are going to see about. Next is CH bond. Okay, ಈಗ CH ಎಷ್ಟಿದೆ? CH ಎಷ್ಟಿದೆ ನಮ್ಮ ಕಡೆ? 6 ಇದೆ. CH is 6. How much? Check it out. 1 2 3 4 5 and 6. Double bond ಇದೆ ಅಲ್ಲ, ಇದಕ್ಕೆ 6. Okay. Next comes what? We are going to know pi bonds are done. CH bonds are now C double bond. Double bond ಎಷ್ಟಿದೆ? C double bond C. Okay. C double bond C ದಲ್ಲಿ almost 1 it is there. Okay. Almost 1 ಇದೆ. I'll write it as 1. Next comes C double bond C. That is going to also be 2 2 2. Clear? That is C. ಇಲ್ಲಿ pi ಇದೆ 1. ಆಮೇಲೆ pi C. That is going to be double bond. How much is there? C is equal to 2:1. So now total ಎಷ್ಟಾಗುತ್ತೆ ಅನ್ನೋದು ಬರಿಬೇಕು ನೀವು. ಆಯ್ತಾ? ಸೊ how much it will be total? Now you people got to know CC bond ಅಂತೂ 4 ಇದೆ, ಮತ್ತೆ CH bond ಅನ್ನು 6 ಇದೆ. Then alpha CC bonds. Yes, alpha CC bonds are also how much? C double bond C bonds are also 1. Then pi it is. I'm so sorry. It's a pi. Is wrong ಆಯ್ತು ಇಲ್ಲಿ. 6 ಇದೆ. Pi bonds ಎಷ್ಟಿದೆ? Our eraser is little bit. ಒಂದು ನಿಮಿಷ ನಿಲ್ಲಿ guys. Okay. See pi ಇದೆಲ್ಲ, pi CC ಎಷ್ಟಿದೆಪ್ಪ? Double bond ಇದೆಲ್ಲ ಅದಕ್ಕೆ 1. Done. So now pi C double bond C is going to be how much? 2 itself. This much you people need to understand. Clear? Pi C double bond C ಆಯ್ತು, ಮತ್ತೆ pi single bond C ಇರಬೇಕು. That is also going to be 1. This is 2 actually. Okay. This is going to be the 2. In this way you just need to substitute. Means what? You people need to check it out whether a sigma is going to be what? You people got to know already. It is going to be head to head. ಆಯ್ತಾ? ಸೊ ಪಾಯ್ ಅಂದ್ರೆ ಏನು? ಪಾಯ್ ಅಂದ್ರೆ ಏನು ತಿಳ್ಕೊಬೇಕು ನೀವು? ಪಾಯ್ ಮೀನ್ಸ್ ವಾಟ್? ಸಾರಿ ಗೈಸ್, glitch. Okay. Pi andre enappa? Pi means you need to think like it is a lateral overlapping, or in case side overlapping, sideway overlapping. Okay, sideway overlapping. Idannಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಈಸಿ ಆಗಿಬಿಡುತ್ತೆ, ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ ಚಾಪ್ಟರ್. ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. Done? Clear? Next problem, let us check it out. Problem number 8.2, same they have told what is the type of a hybridization of each carbon in the following compounds, that is CH3Cl, second option they have given CH3 2CO and CH3CN. So they have asked about the hybrid, means what is actually the type of hybridization. What is actually the type of hybridization? One second guys. So idako mouse ಅವಾಗಿಂದ ಅಲ್ಲಿ ಇಲ್ಲಿ ಜಿಗಿತಿದೆ, ನನಗನ್ನಿಸ್ತದೆ ಏನೋ ಭೂತ್ ಬಂದಿದೆ ಅದರಲ್ಲಿ. ಆಯಿತು. ಸೊ ದಿಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ವಾಟ್ ದೇ ಹ್ಯಾವ್ ಆಸ್ಕ್ಡ್ ಅಬೌಟ್ ದ ಹೈಬ್ರಿಡೈಸೇಷನ್. ಡೈರೆಕ್ಟ್ಲಿ ಯು ಕ್ಯಾನ್ ರೈಟ್ ದ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಕಾನ್ಸೆಪ್ಟ್. ಕ್ಲಿಯರ್? ಸೊ ದಿಸ್ ಇಸ್ ಸಮ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ವಿಚ್ ಯು ಪೀಪಲ್ ಕ್ಯಾನ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ಪ್ರಾಪರ್ಲಿ and try to answer the questions according to what sigma and the pi bonds, according to the sigma and the pi bonds. Clear everyone? Yes, let's move to the next part, that is going to be what? That is complete condensed and board line structural formulas. So this is very important, like complete and the condensed and the board line structural formulas means where which symbols is used and how it is being used, that you need to have an idea. Now ಈಗ lower classes ನಲ್ಲಿ ಕಲ್ತಿರ್ತಾರೆ ಯಾವ ತರ ಕಾರ್ಬನ್ ಅಂದ್ರೆ ಸಿ ಅಪ್ಪ. ಸೊ ಸಿ ಮತ್ತೆ ಎಚ್ ನಡುವೆ ಒಂದು ಬಾಂಡ್ ಇರುತ್ತೆ, ಬಾಂಡ್ ಸ್ಟ್ರಕ್ಚರ್ ಏನು, ಹೇಗೆ ಬರಿಬೇಕು ನಾವು, ಮತ್ತೆ ಕಂಪೌಂಡ್ಸ್ ಹೇಗೆ ಬರಿಬೇಕು, ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಹೇಗೆ ಬರಿಬೇಕು ಅನ್ನೋದು ನಿಮಗೆ ಗೊತ್ತಿದೆ, ರೈಟ್? ಸೊ now we are going to learn it that only, like in a more details are there that you have not learned it, that we are going to learn it today. Okay, that we are going to learn it. Am I audible, visible properly? No? Yes. Okay, let's start. So first is organic compounds can be shown in the different structural representation, that is going to be the Lewis dashed condensed and double bond line formulas. Like Lewis structure show all the electrons has dots. Okay, Lewis structure ನಲ್ಲಿ ಏನು ಯಾವ ತರ ತೋರಿಸುತ್ತೆ, like example ತಗೋಬಹುದು ನಾವು. ಯಾವ ತರ example ತಗೋಬಹುದು? So like example, I will take it as lithium. Lithium outermost shell, valence shell is how much? 1 is there. 1 is there, right? Outermost shell, it is having 1. This is valence electron, okay? That is going to be the valence electron. Done. Next, now replace the shared pair with the dashes. So how it has been done? The dash structure replaces the shared pairs with the dashes, means it is getting shared. So now you think that lithium is, this electron is being given to chlorine, you think, okay, this is a chlorine, so it needs electrons, so in this way it will give it. Clear? This is how you can understand it easily. Clear? Now single dash means what? Single bond is there. Double dash means double bond is there, and triple bond means double bond will be there. Okay, single andre eno? Single andre hingirutte, double bond andre hingirutte, triple bond andre ee tara bariyಬಹುದು. Next comes lone pairs, heteroatoms, that is oxygen, nitrogen, sulfur, halogens may or may not be the shown. It might not be shown also. Clear? Next examples we can take it as ethane, that is going to be the single bonds itself. Ethene, that is also going to be the double bond here, so in between there will be a double bond present. Ethyne, there also it will be present at either triple bond. So like that only few examples they have given. This is the detailed structures which is called as what? Complete structural formulas. Clear? So this is the complete structural formulas. You can just observe here in ethene which is present in ethene. Ethanol ನೋಡಿ ಇಲ್ಲಿ ಸಿಂಗಲ್ ಬಾಂಡ್ಸ್ ಇದೆ ಅಲ್ಲ, ದಿಸ್ ಆಲ್ ಸಿಂಗಲ್ ಬಾಂಡ್ಸ್ ಗೈಸ್. ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ನಡು ಸಿಂಗಲ್ ಬಾಂಡ್ ಇದೆ, ರೈಟ್? ಈಥೀನ್, ಇದು ಈಥೇನ್ ಆಯ್ತು, ಇದು ಈಥೀನು. ಇಲ್ಲಿ ಎರಡು ಕಾರ್ಬನ್ ನಡುವೆ ಡಬಲ್ ಬಾಂಡ್ ಇದೆ, ರೈಟ್? ಡಬಲ್ ಬಾಂಡ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಬಿಟ್ವೀನ್ ಟೂ ಕಾರ್ಬನ್ಸ್. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ಈಥೈನ್. ಇನ್ ಈಥೈನ್ ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್? ದೇರ್ ಇಸ್ ಅ ಟ್ರಿಬಲ್ ಬಾಂಡ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ಸೈಡ್ ಇಟ್, ರೈಟ್? ಸೊ ನಾವ್ ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ದ ಮಿಥೆನಾಲ್. ಮಿಥೆನಾಲ್ ಮೇಲೆ ಸೇಮ್ ನೀವು ಚೆಕ್ ಮಾಡ್ಕೋಬಹುದು how much it's present. Actually single bonds are most probably everywhere. single bonds, or we can draw the structure in this way also they are telling us. Clear? These are all methanols. Simple examples. Previously in Kaltidvala, this simple examples they have given it in the structure form. Okay. Ivella structures no bada important too. Structures are also very important. They might ask the questions on this also. So easy ansutte. You people are feeling it like easy, but ma'am, iಷ್ಟು ಈಸಿ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರಾ? ಇಷ್ಟು ಈಸಿ ಕ್ವಶನ್ಸ್ ನಲ್ಲಿ ನೀವು ತಪ್ಪು ಮಾಡಿ ಬರೋದು. ಸೊ ಮೇಕ್ ಶ್ಯೂರ್ ಯು ಪೀಪಲ್ ವಿಲ್ ನಾಟ್ ಲೀವ್ ದ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ವಿಚ್ ಆರ್ ಈಸಿ ಟು ಯು. ಓಕೆ, ಯಾವ್ದು ಈಸಿ ಅನಿಸ್ತದೆ ಅಲ್ಲ ಆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ನ ಬಿಡಬೇಡಿ, ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? Condensed and bond line structural formulas like simplifies the complete structure by omitting bond dashes, and repeated groups are shown using the subscripts. Like example, ethane is going to be CH3 like this. So next comes the ethene. That is going to be what? Carbon-carbon double bonds are happening. Don't write any time in this way. CH2 double bond CH2 anta bari bedi. So this hydrogen is not getting bonded with carbon. It's getting bonded with carbon-carbon. Carbon-carbon double bond ಆಗ್ತಿದೆ. Not the hydrogen and carbon is getting bonded. Okay. So this is a wrong thing to write. You need to write it in this way. Clear? Ethyl, that is also a CH. See here, this carbon triple bond is happening in between them. Right? So methanol also it's happening CH3OH. So in this way you need to understand like how we uses the things. L double bond is ಮಾಡಬೇಕು, ಯಾವ ತರ triple bonds ಅನ್ನು ಯೂಸ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ಈ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ಕಲ್ತ್ರಿ ನೀವು, ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ಬಾಂಡ್ ಲೈನ್ ಸ್ಟ್ರಕ್ಚರಲ್ ಫಾರ್ಮುಲಾ ಲೈಕ್ ಯೂಸಸ್ ಜಿಗ್ಜಾಗ್ ಲೈನ್ಸ್ ಟು ರಿಪ್ರೆಸೆಂಟ್ ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಬಾಂಡ್ಸ್. ಓಕೆ, ಕಾರ್ಬನ್ ಕಾರ್ಬನ್ ಬಾಂಡ್ಸ್ ನಲ್ಲಿ ಜಿಗ್ಜಾಗ್ ಯೂಸ್ ಅನ್ನ, ಜಿಗ್ಜಾಗ್ ಅಂದ್ರೆ ಲೈನ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ಕೋಬಹುದು, ಜಿಗ್ಜಾಗ್ ಲೈನ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ಕೋಬಹುದು. ಕಾರ್ಬನ್ ಅಂಡ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಆರ್ ನಾಟ್ ಶೋನ್ ಎಕ್ಸ್ಪೆಕ್ಟಿಯಲಿ and line ends methyl group. Like example CH3, like why it is before ಹೀಗದಕ್ಕೆ ಬರೀತಾರೆ? Why this has been used? This has been used to mention that it has got bonded with someone. It's getting bonded with someone. Clear? Next, line junction, that is carbon atoms with sufficient hydrogens will be present. Only the hetero atoms like oxygen, nitrogen, chloride are written explicitly, and this is the most simplified and commonly used from the organic chemistry. So these are very simple. I know you people are feeling it like bored, like ma'am bala simple concepts na kalstidere anta bore akkotirbodu, but this simple concepts many people will do the mistakes in those itself. So only I am telling you some basic concept is very easy. Some students will feel like it is very basic to understand the concept because arda antu ನೀವು ಕಲ್ತಿರ್ತೀರಾ ಆಲ್ರೆಡಿ. ಹೊಸಗಾಗಿ ಒಂದು ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಅನ್ಸುತ್ತೆ, ನಿಮಗೆ ಈಸಿ ಅನ್ಸುತ್ತೆ, ಬಟ್ ಇಟ್ಸ್ ಆಕ್ಚುಲಿ ಅ ಡಿಫಿಕಲ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್. ಓಕೆ, ಇದರಿಂದ ಕ್ವಶನ್ಸ್ ಯಾವ ತರ ಟ್ವಿಸ್ಟ್ ಮಾಡಿ ಕೇಳ್ತಾರಂದ್ರೆ ನಿಮಗೆ ಆಮೇಲೆ ಅನ್ಸುತ್ತೆ ಅಯ್ಯೋ ವೈ ಡಿಡ್ ಐ ಇಗ್ನೋರ್ ದಿಸ್ ಚಾಪ್ಟರ್. ಸೊ ದಿಸ್ ರಿಗ್ರೆಟ್ ಶುಡ್ ನಾಟ್ ಬಿ ದೇರ್. ಸೊ ಅದಕ್ಕೆ ಹೇಳೋದು ರಿಯಾಲಿಟಿ ಚೆಕ್ ಯಾವಾಗಲೂ ಮಾಡ್ಕೊಂತ ಇರಬೇಕು, ರೈಟ್? ಎವ್ರಿ ಒನ್ ನೀಡ್ ಟು ಡೂ ದ ರಿಯಾಲಿಟಿ ಚೆಕ್ ಪ್ರಾಪರ್ಲಿ ಸೊ ದಟ್ ಇಟ್ ವಿಲ್ ಹೆಲ್ಪ್ ಯು ಪೀಪಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್. ಓಕೆ, ಟು ಹೆಲ್ಪ್ ಯು ಪೀಪಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್ ವೆರಿ ವೆಲ್. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ yes. So this is just a few examples which we will discuss it just now here. Iden discuss madidvalla itarde examples idu. So CH3 CH2 CH CH2 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 CH3, how in the form of a zigzag form, how it's been connected, that's what we have given the simple examples. Next comes the terminal representation of methyl group, also how the methyl group termination, this is a structure actually, but how it's been done, there the carbon and hydrogens will be present, guys. This is a small structure, this has been in the form of a terminal representation. Terminal representation ಅಂದ್ರೆ ಏನು? ಸ್ವಲ್ಪ ಮಂದಿಗೆ ಇದಷ್ಟೇ ಡ್ರಾ ಮಾಡಿದ್ರೂ ತಿಳಿಯುತ್ತೆ. ಓಕೆ, ಇದನ್ನಷ್ಟೇ ಡ್ರಾ ಮಾಡಿದ್ರೂ ತಿಳಿಯುತ್ತೆ. ಇದೇನಪ್ಪ ಅಂತ ಕೇಳಿದ್ರೆ they will tell the answers also. This is methyl groups. Clear? This is what you people need to understand. Okay. Next, various ways to representing the 2-bromobutane are. So this is also, I'll tell you simple example also. Now if I draw you people this thing, ನೀವೇನಂತ ಕರೀತಾರ ಇದಕ್ಕೆ? ಬೆನ್ಸಿನ್ ಅಂತ ಕರೀತಾರ. ಡಿಡ್ ಐ ಆಡ್ ಎನಿಥಿಂಗ್ ದ ಥಿಂಗ್ಸ್ ಲೈಕ್ CH, ಕಾರ್ಬನ್ ಇದ್ದೇನಾ, ಹೈಡ್ರೋಜನ್ ಹಾಕಿದ್ದೇನಾ? ಏನೂ ಹಾಕಿಲ್ಲ ನಾನು. ಜಸ್ಟ್ ಐ ಹ್ಯಾವ್ ಡ್ರಾನ್ ಒನ್ ಸ್ಟ್ರಕ್ಚರ್ ಟು ಯು ಪೀಪಲ್. ವಾಟ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಥಿಂಕ್ ಲೈಕ್ ದಿಸ್ ಇಸ್ ಅ ಬೆನ್ಸಿನ್, ಐ ಅಗ್ರಿ, ದಿಸ್ ಇಸ್ ಅ ಬೆನ್ಸಿನ್, ಐ ಅಗ್ರಿ. ಬಟ್ ಹೇಗಪ್ಪ ಬೆನ್ಸಿನ್ ಇದೆ ಅದು? ಅದು ನಿಮಗೆ ಗೊತ್ತಿಲ್ಲಲ್ಲ. ಅದೇ ಹೇಳೋದು, ದಿಸ್ ಇಸ್ ಹೌ ದ ಟರ್ಮಿನಲ್ ಮೆಥಡಾಲಜಿ ವಿಲ್ tell. Clear? Next, in cyclic compounds, the bond line formulas may be given below. Here are the cyclopropane, how the things will be working out. See, here they have given hexane also is there. If you remove the chlorine, then it will be a benzene itself. So this is how the structures are. Okay, cyclopentane, pentane ide, adar so structure is pentane irodu. So idina ee taranu barkobohudu, right? This also can be written in this way. Clear? Understanding, know what I am trying to tell. So ಈಗ ನೀವು ಏನು ಬೇಸಿಕ್ ಇದನ್ನೆಲ್ಲ ಕಲ್ತಿದ್ದೀರಾ ನೀವು. These three things you have learnt it, but you don't know that how to draw. If they will tell this much only, if they do, you need to tell that it is cyclopropane. ಇದಕ್ಕೆ ಏನು ಕರಿಬಹುದು? Cyclopropane ಅಂತ ಕರಿಬಹುದು. Clear? So this is what you people need to understand it. Understood? Understood? Yes. So next comes what? Cyclopentane. In cyclopentane, what you need to understand is this is a pentane. Okay, pentane na hing tagad bitre. What if in case it is a Cl here added bit here, so illi Cl anta hakbohudu. Okay, like this you people can do it. But right now we are learning only about the cyclopentane, so it's beta. Okay, so this is how you can easily understand the concepts. Clear? So next comes what? That is problem 8.4, that is expand each of the following condensed formula into their complete structural formula. So they have given one structure, means what? They have given the name, we need to draw the structure of them. Okay, we need to draw the structure of them. You can concentrate. First problem is what they have given. I'll write it with a black pen. Black pen in the barilla. CH3, oh no, I think I should write it with the white one. White in the baribeku, 1 second. CH3, CH2, CO, CH2, CH3. Okay, they have given this question. Okay, they have told us to draw the structure of it. So how many carbons are there? 1, 2, 3, 4, 5. I have drawn 5 carbons here. Right? 1, 2, 3, 4, 5. Done. Next we have hydrogens are how many? For this carbon it has been hydrogens are 3. So I am drawing the hydrogens as a 3. 3 hydrogens are done. Next hydrogens are 2. I am drawing it hydrogens as 2. Next comes, it has a CO. CO ide. CO ide. Adakke il double bond CO anta agide because it is a lateral. Means lateral overlapping ಆಗ್ತಿದೆ. Carbon ಜೊತೆ hydrogens ಎರಡಿದೆ. Done. Next ಆಮೇಲೆ 3 hydrogens are present. See, so easy to draw it, right? This is how you people need to draw the structures for the things. Understanding? Understanding the concept very well? ಸೊ ಇದು ಬೇಸಿಕ್ಕು ಸ್ವಲ್ಪ ಮಂದಿಗೆ ಬೋರ್ ಆದ್ರೂ ಬೋರ್ ಮಾಡ್ಕೋಬೇಡಿ. ಎಷ್ಟು ಬೇಸಿಕ್ಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗುತ್ತೆ ಅಷ್ಟು ನಿಮಗೆ ಚಲೋ ಆಗುತ್ತೆ, ಆಯಿತಾ? ಅಷ್ಟು ನಿಮಗೆ ಚಲೋ ಆಗುತ್ತೆ. ಓಕೆ, ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ಎಸ್, ತಿಳಿತಿದ್ದೀರಾ? ಓಕೆ, ತಿಳಿತಾ ಇದು. ನೆಕ್ಸ್ಟ್, ಸೊ ಅದೇ ಥರ ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ. CH3, CH ಡಬಲ್ ಬಾಂಡ್ CH, CH2, 3 CH3. ಇದನ್ನು ನೀವು ನೋಡ್ಕೊಳ್ಳಿ. ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಗೈಸ್. ಓಕೆ, ಇದು ಭಾಳ ಇಂಪಾರ್ಟೆಂಟು. ಇದನ್ನು ಒಂದ್ಸಲ ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ. ಕ್ಲಿಯರಾ? ಅಂಡರ್ಸ್ಟೂಡ್? Understood? Yes, let's move to the next part now. So this is also few problems which they have given it. First one, expand each of the following bond line formulas to show all the atoms including the carbon and the hydrogen. Clear? So they have given the structures. Na helde alla ee tara structures kodtare. Exam nallinu ide tara structures kodbodu. They will tell you to draw it. Okay, they will tell you to draw the formulas, show the atoms including the carbon and hydrogen. Carbon ಮತ್ತೆ hydrogen ದು show ಮಾಡ್ಬೇಕು ನಾವು, ಆಯ್ತಾ? ಸೊ ಇಲ್ಲಿ ನೋಡ್ಕೋಬಹುದು ನೀವು, ಪೆಂಟೇನ್ ತರ ಇದೆ, ಇದು ಪೆಂಟೇನ್ ತರ ಇದೆ. We need to draw the hydrogens and carbons for them. We need to show the hydrogens and carbons for them. Clear? So how you are going to do it? This is how the things are going to be looking. So ಇದು actually structure, ಇದು ಹೇಗೆ ಆಗುತ್ತೆ ಅನ್ನೋದು ಬರ್ದಿದ್ದಾರೆ. Okay, this is how it has been actually been done. Okay, same ಅದೇ ತರ ಸೆಕೆಂಡ್ ಒನ್ ಇದೆ ಕಾರ್ಬನ್ದು. ಇದು ಸೆಕೆಂಡ್ ಒನ್ ಇದೆ ಕಾರ್ಬನ್ದು. 1 second guys. ಸೆಕೆಂಡ್ ಒನ್ ಇದೆ, ಇಲ್ಲಿನೂ ಸ್ಟ್ರಕ್ಚರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಅದೇ ತರ ನಾವು ಕಾರ್ಬನ್ಸ್ ಅನ್ನ ಹಾಕಬೇಕು. ಇಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ ಎಷ್ಟಿದೆ ಕಾರ್ಬನ್ಸ್ ಅದನ್ನ ನೋಡ್ಕೋಬೇಕು. 1 2 3 4 5 6 7 ಇದೆ ಅಂದ್ಮೇಲೆ ಇಲ್ಲಿನೂ 7 ಇರಬೇಕು. ಇಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ 8 ಇದೆ ಬಿಕಾಸ್ ದೇ ಹ್ಯಾವ್ ಸ್ಟಾರ್ಟೆಡ್ ಫ್ರಮ್ ಹಿಯರ್ ಇಟ್ ಸೆಲ್ಫ್. ಸೊ ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಎಲ್ಲದಕ್ಕೂ ಓವರ್ ಆಲ್ ಆಗಿ ಹೈಡ್ರೋಜನ್ಸ್ ಅನ್ನ ಹಾಕಬೇಕು, ಆಯ್ತಾ? ಸೇಮ್ ಅದೇ ತರ ಥರ್ಡ್ ಒನ್ ಮತ್ತೆ ಫೋರ್ತ್ ಒನ್ ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಯು ನೀಡ್ ಟು ಅಬ್ಸರ್ವ್ ಹೌ ದ ಸ್ಟ್ರಕ್ಚರ್ ಇಸ್ ಅಂಡ್ ದ ಬಾಂಡ್ಸ್ ಆರ್. ಅಕಾರ್ಡಿಂಗ್ ಟು ದಟ್ ಯು ನೀಡ್ ಟು ಡ್ರಾ ದ ಬಾಂಡ್ಸ್ ಆಲ್ಸೋ. ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಟ್ರಿಬಲ್ ಬಾಂಡ್ಸ್ ಇದೆ, ರೈಟ್? ಸೊ ಇಲ್ಲಿನೂ ಸೇಮ್ ಟ್ರಿಬಲ್ ಬಾಂಡ್ಸ್ ತೆಗಿಬೇಕು ಇನ್ ಬಿಟ್ವೀನ್ ದ ಕಾರ್ಬನ್. ಸೊ ಇನ್ CC ಬಾಂಡ್ಸ್ ನಲ್ಲಿ ಟ್ರಿಬಲ್ ಬಾಂಡ್ಸ್ ಇದೆ ಅಂದ್ರೆ ಟ್ರಿಬಲ್ ಬಾಂಡ್ಸ್ ನೀವು ತೆಗಿಲೇಬೇಕು. ಓಕೆ, ಇಫ್ ಯು ಪೀಪಲ್ ವಿಲ್ ರೈಟ್ ಇಟ್ ದೆನ್ ಓನ್ಲಿ ಇಟ್ ವಿಲ್ ಬಿ ಈಸಿ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? Three-dimensional representation of an organic molecules. So now 3D structure. Now you got to know the normal structures properly. Okay, ಈಗ normal structures ನಿಮಗೆ ಗೊತ್ತಾಯ್ತು. ಈಗ ನಾವು 3D structures ಅನ್ನ ಹೇಗೆ ಮಾಡ್ಕೋಬಹುದು ಅನ್ನೋದು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು, ಆಯ್ತಾ? ಸೊ 3D structures ಅಂದ್ರೆ ಏನು? ಇಟ್ ಕಾಂಟ್ ಬಿ ಡ್ರೂ ಪ್ರಾಪರ್ಲಿ. ಓಕೆ, ಡ್ರಾ ಮಾಡ್ಲಿಕ್ಕಂತೂ ಬರಲ್ಲ. ಓಕೆ, ಡ್ರಾ ಮಾಡ್ಲಿಕ್ಕಂತೂ ಬರಲ್ಲ, ಬಟ್ ಯು ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್ ಹೌ ಯು ಕ್ಯಾನ್ ಡೂ ಇಟ್. ಓಕೆ, ನಾವು 3D structures of organic molecules are shown on the paper using the Wurtz formulas. Like example, in the form of like ಈಗ ನೀವು 3D ಮೂವಿ ನೋಡ್ಲಿಕ್ಕೆ ಹೋಗ್ತೀರಾ, ರೈಟ್? 3D ಮೂವಿ ನೋಡ್ಲಿಕ್ಕೆ ಹೋದಾಗ ನೀವು ಏನು ಆಕ್ಚುಲಿ ಮಾಡ್ತೀರಾ? 3D ಅಲ್ಲಿ ಅಂದ್ರೆ ಏನೋ ಒಂಥರ ಮುಂದೆ ಬಂದಂಗೆ ಆಗುತ್ತೆ, ರೈಟ್? ಇಟ್ಸ್ ಲೈಕ್ ಆಲ್ ದ ಸೀನ್ಸ್ ವಿಚ್ ಆರ್ ಹ್ಯಾಪನಿಂಗ್ ದಟ್ ಇಸ್ ಕಮಿಂಗ್ ಫ್ರಂಟ್ ಆಫ್ ಯು. ಓಕೆ, ದಟ್ಸ್ ಕಮಿಂಗ್ ಫ್ರಂಟ್ ಆಫ್ ಯು ಅಂಡ್ ಯು ಆರ್ ಡೂಯಿಂಗ್ ಇಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ್ಯಾಟ್ ಇಟ್ ಸೆಲ್ಫ್. ಸೇಮ್ ಅದೇ ತರ ಹೌ ಇಟ್ಸ್ ಬೀನ್ ಡನ್ ಇಸ್ ಇನ್ 3D ಆಲ್ಸೋ. ದ ವಿಸಿಬಿಲಿಟಿ ವಿಲ್ ಬಿ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಅ 3D structure. Okay, now next comes what? Solid wedge, that is delta, and bond projecting out of the plane towards the observer, and dashed wedge or dashed line bond projecting away from the observer. Clear? Next, normal line dash bond lies in the plane of the paper. If the wedge direction is there, broad end of the wedge faces towards the viewer. Example, methane CH4, it is shown in the 3D with one bond towards one away and the two in the plane. Clear? So this is our 3D structure. Okay, ಇದೇನಿದೆ CH4 ಇದು 3D ಸ್ಟ್ರಕ್ಚರ್. ನೋಡಿ 3D ಸ್ಟ್ರಕ್ಚರ್ ಹೇಗಿರುತ್ತೆ ಅನ್ನೋದು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ಇಲ್ಲಿ. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ಮೂರು ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಏನಿದೆ ಅಲ್ಲ, ದಿಸ್ 3 ಸ್ಟ್ರಕ್ಚರ್ಸ್ ವಿಚ್ ಆರ್ ದೇರ್ ಹೈಡ್ರೋಜನ್ಸ್ ದಟ್ ಆರ್ ಆಕ್ಚುಲಿ ಇನ್ ದ ಫ್ರಂಟ್. ಓಕೆ, ಫ್ರಂಟ್ ವರ್ಜನ್ ನಲ್ಲಿ 3 ಹೈಡ್ರೋಜನ್ಸ್ ಇದೆ. ಓಕೆ, ಫ್ರಂಟ್ ವರ್ಜನ್ ನಲ್ಲಿ 3 ಹೈಡ್ರೋಜನ್ಸ್ ಇದೆ. ಈ ತರ ಹೈಡ್ರೋಜನ್ಸ್ 2 ಇದೆ, ಆಯ್ತಾ? 2 ಇದೆ. ಇನ್ನೂ ಒಂದು ಎಲ್ಲಿ ಬರುತ್ತೆ ಅಂದ್ರೆ ಈ ಕಡೆ ಲೆಫ್ಟ್ ಸೈಡ್ ಬರುತ್ತೆ, ಲೆಫ್ಟ್ ಸೈಡ್. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ಇಟ್ಸ್ ಬೀನ್ ಡ್ರಾನ್. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? ಇಟ್ ಇಸ್ ಅ ಸಾಲಿಡ್ ವೆಜ್. ಲೈಕ್ ಬಾಂಡ್ ಇಸ್ ಟುವರ್ಡ್ಸ್ ದ ಅಬ್ಸರ್ವರ್. ಟುವರ್ಡ್ಸ್ ದ ಅಬ್ಸರ್ವರ್ ಇಟ್ ಇಸ್. ಓಕೆ, ಇಟ್ಸ್ ಲೈಕ್ ಟುವರ್ಡ್ಸ್ ದ ಅಬ್ಸರ್ವರ್. ಒನ್ ಸೆಕೆಂಡ್ ಗೈಸ್, ಕಲರ್ ಫಿಲ್ಲಿಂಗ್ ಆಗ್ತಿದೆ ಈಗ. ಓಕೆ, ಕ್ಲಿಯರಾ? ಸೊ ಇಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ಸರಿಯಾಗಿ. ಇವು ಏನು ಹೈಡ್ರೋಜನ್ಸ್ ಇದೆ ಅಲ್ಲ, ದಿಸ್ ಬೋತ್ ಹೈಡ್ರೋಜನ್ಸ್ ಆರ್ ಬಾಂಡ್ಸ್ ಇನ್ ದ ಪ್ಲೇನ್ ಆಫ್ ದ ಪೇಪರ್. ಪ್ಲೇನ್ ಆಫ್ ದ ಪೇಪರ್ ನಲ್ಲಿ ನಾರ್ಮಲಿ ಹೈಡ್ರೋಜನ್ಸ್ ಅನ್ನ ತಕ್ಕೋಬಹುದು. ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಬರೋದೇನು? ಡ್ಯಾಶ್ಡ್ ವೆಜ್ ಇಸ್ ಬಾಂಡ್ ಅವೇ ಫ್ರಮ್ ದ ಅಬ್ಸರ್ವರ್. ಮೀನ್ಸ್ ಸ್ವಲ್ಪ ದೂರ ಇದೆ. ಅವೇ ಫ್ರಮ್ ದ ಅಬ್ಸರ್ವರ್ ಮೀನ್ಸ್ ಇಟ್ಸ್ ಬ್ಯಾಕ್ ಸೈಡ್. ಓಕೆ, ಬ್ಯಾಕ್ ಸೈಡ್ ಬಾಂಡಿಂಗ್ ಆಗ್ತಿದೆ. ಮೀನ್ಸ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ 3D ವಿ ಕಾಂಟ್ ಸಿ ಇಟ್ ಇನ್ ದ ಫ್ರಂಟ್. ಓಕೆ, ವಿ ಕಾಂಟ್ ಸಿ ಇಟ್ ಇನ್ ದ ಫ್ರಂಟ್. Next comes what? Solid wedge that is bond towards the observer. This is actually going to be where the bond is towards the observer. Clear? Towards the observer. So this is wedge and the dash representation of what? CH4. So ಇದು 3D structure. So 3D structures will be for everything. Okay, ಯಾವ ಕಂಪೌಂಡ್ಸ್ ಇದೆ, ಏನೇನಿದೆ ಅಲ್ಲ ಎಲ್ಲದಕ್ಕೂ 3D ಸ್ಟ್ರಕ್ಚರ್ ಇರುತ್ತೆ, ಆಯ್ತಾ? ಸೊ 3D ಸ್ಟ್ರಕ್ಚರ್ಸು ಇದೇನು ನಾವು ನಾರ್ಮಲ್ ಆಗಿ ಎಲ್ಲದಕ್ಕೂ ಇರಲ್ಲ ಅಂತ ಇಲ್ಲ. ಆಲ್ ದ ಕಂಪೌಂಡ್ಸ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಅ 3D ಸ್ಟ್ರಕ್ಚರ್ಸ್ that you people need to be clear of. Okay, next comes what? Next comes the classification of organic compounds. Classification of organic compounds. In that, organic compounds are classified based on the structures. It's completely based on the structures. Clear? Now, acyclic open chain, that is straight or branched chain. Example, ethane. So first one option is coming what? So first open chain is okay. Acyclic is actually a open chain. Cyclic andre already almost all the things will be closed chain. Okay, so acyclic andre open chain. That will be straight or branched chains will be present. Like example, ethane. Now examples illinu ide. I'll tell you people how. Okay, cyclic andre enappa closed chain. Cyclic means what? It's going to be the closed chain and the atoms from the rings it will be. Okay, atoms all will be in the form of a ring like structure. Okay, it will be in the form of ring like structure. Next, the homocyclic. In the cyclic nalline ಸ್ವಲ್ಪ ಎರಡು options ಬರುತ್ತೆ. First one is the homocyclic. Second comes the heterocyclic. Clear? So homocyclic ಅಂದ್ರೆ ಏನು? Only carbon atoms. Example, benzene can be written. Okay, only the homocyclic means what? We can give the example has carbon atoms. Like benzene ನಲ್ಲಿ 6 carbons ಇದೆ. So ಅದರ ತರ ನೀವು ಅಕಸ್ಮಾತ್ benzene ಸ್ಟ್ರಕ್ಚರ್ ತೆಗೆದ್ರೂ 6 carbons ಇದೆ ಅಂತ ಈಸಿಲಿ ನೀವು ಕಂಡುಹಿಡಿಬಹುದು, ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ heterocyclic, carbon plus other atoms like furane. Okay, furan. Next, each type of may be saturated like a single bonds or unsaturated like a double or a triple bonds, like how we have learned it. No, it is structures. Idರಲ್ಲಿ structures ಕಲ್ತಿದ್ದೇವಲ್ಲ already ನಾವು. ಇಲ್ಲಿ ನೋಡಿ, ಈ structure ಇದೆ, ಇಲ್ಲಿ ಒಂದೊಂದ್ಸಲ triple bond ಇದೆ, ಒಂದೊಂದ್ಸಲ single bond ಇದೆ. It's not like we need to be always be a triple bond or always it will be a second double bond itself. Clear? One second, guys. Okay, ತಿಳಿತಾ ಇಲ್ಲಿ ತನಕ ಎಲ್ಲರಿಗೂ? Okay, last is what? Yes, double bond and triple bond. Next comes organic compounds, that is going to be, means what are the types in a easy way. This is a flow chart, it is called as. Okay, flow chart is understand ಮಾಡ್ಕೊಂಡ್ರೆ ಇನ್ನಟ್ ಈಸಿ ಆಗುತ್ತೆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗು. ಅದಕ್ಕೆ ಹೇಳೋದು, ಯಾವಾಗ ಏನಾದರೂ ಕುಂತು ಓದ್ತಿದ್ರೆ ಮೇಕ್ ಅ ಪ್ಲಾನ್. ಓಕೆ, ಯಾವ ಥರ ನೋಟ್ಸ್ ಮಾಡಬೇಕು, ನಾವು ಒಂದ್ಸಲ ನೋಟ್ಸನ್ನು ನೋಡಿದರೆ ನಂಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಹೇಗಾಗಬೇಕು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನೋದು ಅದನ್ನು ನೋಡ್ಕೊಂತಿರಬೇಕು. ಇನ್ ಕೇಸ್ ನೀವು ಪೀಪಲ್ ವಿಲ್ ನಾಟ್ ಡೂ ಲೈಕ್ ದಿಸ್, ದ ಫ್ಲೋ ಚಾರ್ಟ್ಸ್ ಮಾಡಲಿಲ್ಲ, ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ಸ್ ಮಾಡಲಿಲ್ಲ, ಯಾವ್ದು ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಅದು ಅಂಡರ್ಲೈನ್ ಮಾಡಲಿಲ್ಲ, ಆ ಕಾನ್ಸೆಪ್ಟ್ಸನ್ನು ಹೈಲೈಟ್ ಮಾಡಲಿಲ್ಲ, ಏನಾಗುತ್ತೆ ಗೊತ್ತಾ, ಎಕ್ಸಾಮ್ ಟೈಮ್ನಲ್ಲಿ ಅಯ್ಯೋ ಇದನ್ನು ಓದೋದು ಎಲ್ಲ ಫುಲ್ ಕನ್ಫ್ಯೂಷನ್ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಮಿಸ್ಟೇಕ್ ವಿ ನೀಡ್ ಟು ಅವಾಯ್ಡ್ ಇಟ್. ಹೌ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅವಾಯ್ಡ್ ಇಟ್? ವೆನ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಡೂ ದ ಥಿಂಗ್ಸ್ ಎಟ್ ಅ ಕಾನ್ಸೆಪ್ಟ್ ವೈಸ್. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್, ಈಗ ಫ್ಲೋ ಚಾರ್ಟ್ ಇದ್ರ ಬಗ್ಗೆ ನಾ ಫ್ಲೋ ಚಾರ್ಟ್ ಮಾಡಿದೆಯಪ್ಪ. ಸೊ ಆರ್ಗ್ಯಾನಿಕ್ ನಲ್ಲಿ ಹೀಗೆ ನೋಡಿ, ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ನಲ್ಲಿ ಅಸೈಕ್ಲಿಕ್ ಆರ್ ಓಪನ್ ಚೈನ್ ಕಂಪೌಂಡ್ಸ್ ಇರುತ್ತೆ, ಆಮೇಲೆ ಸೈಕ್ಲಿಕ್ ಆರ್ ಕ್ಲೋಸ್ಡ್ ಚೈನ್ ಆಫ್ ಅ ರಿಂಗ್ ಕಂಪೌಂಡ್ಸ್ ಇರುತ್ತೆ. ನಾವು ನೆಕ್ಸ್ಟ್ ಇನ್ ದಿಸ್ ಸೈಕ್ಲಿಕ್ ಆರ್ ಕ್ಲೋಸ್ಡ್ ಚೈನ್ ಅಲ್ಲಿ 2 ಟೈಪ್ಸ್ ಇದೆ, ಅಲ್ಲಿ ಸೈಕ್ಲಿಕ್ ಒಂದು, ಅರೋಮ್ಯಾಟಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಒಂದು. ಸೊ ಇದೆಲ್ಲ ನಾನು ಈಗ ಫ್ಲೋ ಚಾರ್ಟ್ ನಲ್ಲಿ ನಿಮ್ಗೆ ಹೇಳಿದ್ರೆ ನಿಮ್ಗೆ ಈಸಿ ಆಗುತ್ತೆ ಎದ್ರಲ್ಲಿ ಏನೇನು ಟೈಪ್ಸ್ ಇದೆ ಅನ್ನೋದು. Right, so that's what I'm telling you. Flow chart is very very important. Flow chart ಅಲ್ಲಿ ಆ ಥರ ಅಕಸ್ಮಾತ್ ನೀವು ಓದ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ the concept understanding will be very easy to you. Okay, concept understanding easy ಆಗುತ್ತೆ. Next, organic compounds, that is acyclic or open chain compounds. So in this organic compounds only we have 2 things. ಒಂದು acyclic or open chain, ಇನ್ನು ಒಂದು cyclic or closed chain. Okay, cyclic or closed chain. ನಾವು ಈಗ cyclic ಮತ್ತೆ closed chain ಅಲ್ಲಿ 2 types ಇದೆ. ಯಾವ್ದಪ್ಪ 2 types? First alicyclic compounds ಒಂದು, ಇನ್ನು ಒಂದು aromatic compounds ಒಂದು. Okay, alicyclic ಒಂದು, ಇನ್ನು ಒಂದು aromatic compounds. Yes, understanding? Need to be very active in the chat box, everyone. Thumbs up ಹಾಬೇಕು, ಎಷ್ಟು ತಿಳಿತಾ ಏನು ಹೋಗುತ್ತಲ್ಲ, you need to put the thumbs up everywhere. Clear? Clear? Yes, so in this aromatic compounds we have 2 concepts, again 2 types ಇದೆ. Okay, benzonoid compounds ಒಂದು ಮತ್ತೆ non benzonoid compounds ಒಂದು. Clear? So aromatic compounds ನಲ್ಲಿ benzonoid ಒಂದಿದೆ, non benzonoid compounds ಬಂದಿದೆ. Next comes what? In alicyclic compounds we have 2 types again. First is homocyclic or carbocyclic compounds. One more is heterocyclic compounds or non aromatic. It's also a non aromatic compounds. Clear? Next comes the, in this means what? In the non benzonoid compounds ನಲ್ಲಿ heterocyclic aromatic compounds ಅಂತ ಇದೆ. Clear? Now we got to know what are the types of them, right? So ಎದರಲ್ಲಿ ಏನೇನಿದೆ, ಯಾವ ತರ ನಾವು ಕಲಿತಿದ್ದೇವೆ ಅನ್ನೋದು ನಿಮಗೊಂದು ಐಡಿಯಾ ಗೊತ್ತಾಯ್ತು. ಈಗ ಎತ್ತರಿಂದ ಗೊತ್ತಾಯ್ತು, ಫ್ಲೋ ಚಾರ್ಟ್ ಇಂದ ಗೊತ್ತಾಯ್ತು. ಸೊ ಅದಕ್ಕೆ ಹೇಳೋದು ಫ್ಲೋ ಚಾರ್ಟ್ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಫ್ಲೋ ಚಾರ್ಟ್ ಇಂದ ಹೋದ್ರೆ ನಿಮಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಈಸಿ ಇರುತ್ತೆ. ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಲೆಟ್ಸ್ ಲರ್ನ್ ದಿಸ್ ಆಲ್ ಡೀಟೇಲ್ಸ್ ಇನ್ ವೆರಿ ಮಚ್ ಡೀಟೇಲ್ ವೇ. ಓಕೆ, ಇದನ್ನೆಲ್ಲ ನಾವು ಈಗ ಡೀಟೇಲ್ ಆಗಿ ಕಲಿಯೋಣ. ಡನ್? ಎಸ್, sorry, yes, acyclic or open chain compounds. First one is what? Acyclic, or it is also called as a open chain compounds. So in this what we are going to do is, these compounds are also called as aliphatic compounds and consist of straight or branched chain compounds. For example, see compounds alla enidella, they all are aliphatic compounds. They all are called as what? Aliphatic compounds, and that consist of a straight or branched chain also. Okay, straight ಇರಬಹುದು, branched chain ಇರಬಹುದು. Okay, like example. Okay, like example, ಈಥೇನ್. ಈ ಹೇಗೆ ಬರಿಬೇಕಪ್ಪ ಈಥೇನನ್ನ ಈ ತರ ಬರ್ದ್ವಿ, CH3 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 ಅಂತ. This actually ethane, it is a straight chain. Okay, this is actually a straight chain. Now how can you write the branched? Say isobutane is there. This how can you write it? How you have written it? So in a branched from, here one more is there, acetal halide, there is one more here, acetic acid. So branched andre enu, ಇಲ್ಲಿ ಏನು ಮೇಲ್ಗಡೆ ಡಬಲ್ ಬಾಂಡ್ ಓ ಇದೆ, ಸಿಂಗಲ್ ಬಾಂಡ್ CH3 ಇದೆ, ಅವಕ್ಕೆಲ್ಲ ಬ್ರಾಂಚ್ಡ್ ಅಂತ ಕರೀತಾರೆ. ಮೀನ್ಸ್ ವಾಟ್, ಒಂದೇನೋ ಟ್ರೀ ಇದೆ, ಆ ಗಿಡಕ್ಕೆ ಬ್ರಾಂಚಸ್ ಇರುತ್ತಲ್ಲ, ಒಂದೊಂದು ಗಿಡಕ್ಕೆ ಬ್ರಾಂಚಸ್ ಇರಲ್ಲ, ಒಂದೊಂದು ಗಿಡಕ್ಕೆ ಬ್ರಾಂಚಸ್ ಇರುತ್ತೆ. ಸೊ ಬ್ರಾಂಚಸ್ ಇರೋ ಟ್ರೀ ಯಾವ ಎಕ್ಸಾಂಪಲ್ ತಗೋಬಹುದು? ಮ್ಯಾಂಗೋ ಟ್ರೀ ಅಂಡ್ ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್. ದಟ್ ಟ್ರೀಸ್ ವಿ ಕ್ಯಾನ್ ಟೆಲ್ ಇಟ್ ಹ್ಯಾಸ್ ಅ ಬ್ರಾಂಚ್ ಟ್ರೀಸ್. ಡನ್. ಸೊ ನಾರ್ಮಲ್ ಟ್ರೀ ಅಂದರೆ ಯಾವುದು? ಈಗ ಎಕ್ಸಾಂಪಲ್ ಕೋಕೋನಟ್ ತಗೊಳ್ಳಿ. ಓಕೆ, ಕೋಕೋನಟ್ ಟ್ರೀ ಏನಿದೆ ಅಲ್ಲ, ಅದು ತೆಂಗಿನಕಾಯಿ ಗಿಡ ಫುಲ್ ಒದ್ದೇ ಇರುತ್ತೆ, ಅದಕ್ಕೆ ಏನು ಬ್ರಾಂಚಸ್ ಇರಲ್ಲ. ಸೊ ಬ್ರಾಂಚಸ್ ಏನೂ ಇರಲ್ಲ, ಜಸ್ಟ್ ಸ್ಟ್ರೇಟ್ ಆಗಿರುತ್ತೆ. ಅವಕ್ಕೆಲ್ಲ ಎಕ್ಸಾಂಪಲ್ ಏನು ತಗೋಬಹುದು? ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಕಂಪೌಂಡ್ಸ್ ಅಂತ ಕರಿಬಹುದು. ಆಯ್ತಾ? ಎಸ್, ಸ್ಟ್ರೇಟ್ ಚೈನ್ ಕಂಪೌಂಡ್ಸ್ ಅಂತ ಕರಿಬಹುದು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? ಸೈಕ್ಲಿಕ್ ಆರ್ ಕ್ಲೋಸ್ಡ್ ಚೈನ್ ಆರ್ ಅ ರಿಂಗ್ ಕಂಪೌಂಡ್ಸ್. ಓಕೆ, ಸೈಕ್ಲಿಕ್ ಮತ್ತೆ ಕ್ಲೋಸ್ಡ್ ಚೈನ್ ಅಂದ್ರೆ ಏನು? ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ ಬೆನ್ಸಿನ್ ರಿಂಗ್ ತಗೊಳ್ಳಿ. ಓಕೆ, ಬೆನ್ಸಿನ್ ರಿಂಗ್ ಇದೆ, ಕ್ಲೋಸ್ಡ್ ಫಾರ್ಮ್ ನಲ್ಲಿ ಇದೆ, ರೈಟ್? ಕ್ಲೋಸ್ಡ್ ಫಾರ್ಮ್ ಅಂದ್ರೆ ಏನು? ಯಾವುದು ಎಲಿಮೆಂಟ್ಸ್ ಏನಿರುತ್ತಲ್ಲ ಅಲ್ಲ ಕ್ಲೋಸ್ಡ್ ಫಾರ್ಮ್ ನಲ್ಲಿ ಬಿಲೀವ್ ಆಗಿರುತ್ತೆ. ಇಟ್ಸ್ ನಾಟ್ ಹ್ಯಾವಿಂಗ್ ಎನಿ ಬ್ರಾಂಚಸ್ ದರ್, ಇಟ್ಸ್ ನಾಟ್ ಹ್ಯಾವಿಂಗ್ ಎನಿ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಬ್ರಾಂಚಸ್, ಚೈನ್ ಬ್ರಾಂಚಸ್ ಇರಲ್ಲ. ಸೊ ಸ್ಟ್ರೇಟ್ ಚೈನು ಇರಲ್ಲ ಮತ್ತೆ ಬ್ರಾಂಚಸ್ ಇರಲ್ಲ. ಅವಕ್ಕೆಲ್ಲ ಏನ ಕರೀತಾರೆ? ಸೈಕ್ಲಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, ಸೈಕ್ಲಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಆರ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ as ವಾಟ್? ರಿಂಗ್ ಕಂಪೌಂಡ್ಸ್ ಆಲ್ಸೋ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ಅಲಿಸೈಕ್ಲಿಕ್ ಕಂಪೌಂಡ್ಸ್. ಅದರಲ್ಲಿ ಫಸ್ಟ್ ಒನ್ ಇರೋದು ಅಲಿಸೈಕ್ಲಿಕ್. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ದ aromatic compounds. ಓಕೆ, ಲೆಟ್ us learn first the alicyclic compounds. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಎವ್ರಿವನ್? ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗ್ತಿದೆನಾ ಎಲ್ಲರಿಗೂ ಸರಿಯಾಗಿ? ಎಸ್, ಲೆಟ್ಸ್ ಟ್ರೈ ಇಟ್ ಔಟ್ ನೌ. ಸಿ ಇಟ್. So this alicyclic, that is also called as aliphatic cyclic, that compounds contain carbon atoms which is being joined in the form of what? Ring. Okay, na ಹೇಳ್ದಲ್ಲ ring structure ನಲ್ಲಿ ಇರುತ್ತೆ. ಲೈಕ್ ನಾವು ಯಾಕೆ ಬೆನ್ಸಿನ್ಗೆ ರಿಂಗ್ ಅಂತ ಕರೀತೀವಿ? ಬೆನ್ಸಿನ್ ರಿಂಗ್ ಇದೆ ಮ್ಯಾಮ್, ಸೊ ಬೆನ್ಸಿನ್ ರಿಂಗ್ ತೆಗಿರಪ್ಪ. ಸೊ ಎದಕ್ಕೆ ಹೇಳ್ತಾರೆ ಅದನ್ನ ಬೆನ್ಸಿನ್ ರಿಂಗ್ ತೆಗೀರಿ ಅಂದ್ರೆ, ಇಟ್ಸ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಅ ರಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್. ಇಟ್ಸ್ ಮೀನ್ಸ್ ವಾಟ್? ಇಟ್ ಇಸ್ ಬೀನ್ ಕ್ಲೋಸ್ಡ್ ಫಾರ್ಮ್. ಇಟ್ಸ್ ನಾಟ್ ಬೀನ್ ಲೈಕ್ ಅ ಸ್ಟ್ರೇಟ್ ಚೈನ್. ಕೋಕೋನಟ್ ಟ್ರೀ ಥರ ಇಲ್ಲ ಇದು. ಸೊ ಕಂಪ್ಲೀಟ್ಲಿ ಕ್ಲೋಸ್ಡ್ ಚೈನ್ ಥರ ಇರುತ್ತೆ. ಆಯ್ತಾ? ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ ನಾವು ಲೋಟಸ್ ಅದು ನೋಡ್ತಿರ್ಬೇಕು. ಲೋಟಸ್ ಅದು ಒಂದು ಪೌಂಡ್ನಲ್ಲಿ ಗ್ರೋ ಆಗುತ್ತೆ, ರೈಟ್? 1 pound ಇಸ್ ದರ್. ಇನ್ ದಟ್ ಪೌಂಡ್ ಇನ್ಸೈಡ್ ದ ಕೋಕೋನಟ್, ಲೋಟಸ್ ವಿಲ್ ಬಿ ಗ್ರೋನ್, ರೈಟ್? ಸೊ ಆ ಲೋಟಸ್ಸು ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ನಲ್ಲಿ, ಮೀನ್ಸ್ ಒಂದು ರಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ನಲ್ಲಿ ಇಟ್ಸ್ ಬೀನ್ ಗ್ರೋಯಿಂಗ್. ಓಕೆ, ಒಂದು ರಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ನಲ್ಲಿ ಅದು ಗ್ರೋ ಆಗ್ತಿದೆ. ಅದೇ ಥರ ಹೇಳೋದು ನಿಮಗೆ, ಸೇಮ್ ಅದೇ ಥರ ಬೆನ್ಸಿನು ಅದರಲ್ಲಿ ಇಟ್ ಹ್ಯಾಸ್ ಒನ್ ಸ್ಪೇಸ್, ಇನ್ ದ್ಯಾಟ್ ಓನ್ಲಿ ಇನ್ಸೈಡ್ ಇಟ್ ಇಸ್ ಲೈಕ್ ಕ್ಲೋಸ್ಡ್ ಫಾರ್ಮ್. ಓಕೆ, ಸೊ ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್. ಸೈಕ್ಲೋಪ್ರೋಪೇನ್ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಸೈಕ್ಲೋಹೆಕ್ಸೇನ್ ಅಂತ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಸೈಕ್ಲೋಹೆಕ್ಸೀನ್. ಸೊ ದೀಸ್ ಆರ್ ದ ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ವಿಚ್ ವಿ ಕ್ಯಾನ್ ಗಿವ್ ಇಟ್ ಫಾರ್ ದ aliphatic compounds. Aliphatic compounds which are going to be what? There, it contains carbon atoms which is joined in the form of a ring. It's joined in the form of a ring. Carbon atoms irutte, avella in the form of a carbon nalline join agirutte. Clear? Next, sometimes atoms other than the carbon are also present in the ring. Sometimes, okay, sometimes bare carbon ಅಷ್ಟೇ ಇರಲ್ಲ. ನಾನೀಗ ಡೆಫಿನೇಷನ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋದು ಮುಂದೆ ಮ್ಯಾಮ್ ಬರೀ ನೀವು ಕಾರ್ಬನ್ ಐಟಮ್ಸ್ ಅಷ್ಟೇ ಹೇಳಿದ್ರಿ. ಬಟ್ sometimes exceptional ಇರುತ್ತೆ. Obviously it is not a D and F block elements, but also we will be having exceptionals here also. ಏನಪ್ಪ exceptional ಇದೆ ಇಲ್ಲಿ? Like sometimes atoms other than the carbon are also present. Okay, these are also present in the form of a ring itself. Okay, carbon ಬಿಟ್ಟು like hydrogen ಇರುತ್ತೆ, ಒಂದೊಂದ್ಸಲ ಕ್ಲೋರಿನ್ ಇರುತ್ತೆ, ಒಂದೊಂದ್ಸಲ ಬ್ರೋಮಿನ್ ಇರುತ್ತೆ. ಸೊ ಇದೇ ತರ ಎಕ್ಸಾಂಪಲ್ಸ್ ತಗೋಬಹುದು. ಆಯ್ತಾ? Now this tetrahydrofuran given below is a simple example for that compound, that is tetrahydrofuran. Okay, tetrahydrofuran. Clear? So this is how you people need to understand it. Next, this exhibits some of the properties similar to those of the aliphatic compounds. So similar to that of the aliphatic compounds. Clear? Now see, this is all I told you. Carbon ಇದೆ ಅಂತ. ಇಲ್ಲಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟೆ, ಆಕ್ಸಿಜನ್ ಅಂತ. ಮೀನ್ಸ್ tetrahydrofuran is also given as a simple example for the aliphatic. Clear? So ತಿಳ್ಕೋಬೇಡಿ ಮ್ಯಾಮ್ ಆಕ್ಸಿಜನ್ ಇಲ್ಲ ಅಂದ್ರೆ aliphatic ಇಲ್ಲ ಅಂತ ತಿಳ್ಕೋಬೇಡಿ. Some will be there, exceptional is there. So those are all also called as aliphatic itself, but they should be in the ring structure itself. Okay, ring structure ನಲ್ಲಿ ಇದೆ ಮತ್ತೆ ಆಕ್ಸಿಜನ್ ಹಾಕಿದ್ದಾರೆ. Okay, done ma'am, no problem, that is also aliphatic. ಥೀತಾ? ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್? ಎಸ್ ಮ್ಯಾಮ್. ಏನು ಮ್ಯಾಮ್ ನೀವು ಇದನ್ನೆಲ್ಲ 8 ಸಲ ಹೇಳ್ತಿದ್ದೀರಾ ಅಂತ ಹೇಳ್ತಿದ್ದೀರಾ? what to do, we should tell it. Okay, bala important idu. Next, aromatic compounds. Now aromatic compounds are the special types of compounds, and you will learn about these compounds in detail in the unit 9. First channel unit 9 kalibodudana. So this include the benzene and other related ring compounds, that is benzoate, like alicyclic compounds. Aromatic compounds may also have a heteroatom in the ring. Such compounds are called as heterocyclic aromatic compounds. So in case idrallenu heteroatom include idre avukella heterocyclic aromatic compounds anta kariyತಾರೆ. Hetero compounds akasmat add idre, addition idre adralli, they are also called as heterocyclic aromatic compounds. We need to mention it as aromatic compounds there. Okay, amele some of these examples varies types of aromatic compounds also. This also varies from the types of a compounds also. Clear? Next comes what? Benzonoid aromatic compounds. Simple examples kotidaralli nodi. This is a benzene. Okay, this is a benzene. Now this is a non-benzenite compound. This is a non-benzenite compound because we don't have a, means carbons are present in it. It's not like no, but even oxygen is present. Okay, and here aniline we can give the simple example. Next example we can give it naphthalene. So these are the simple examples which we can give it where the carbons are present at shore, but also other elements also present. Other elements are, you know, heteroatoms. Even the heteroatoms are also present, which is being joined. Those all are called as what? Heterocyclic aromatic compounds. Here are the few examples for those. Okay, illella carbon ide. With that, one more element is also present, like oxygen, illi sulfur ide, illi nitrogen ide. Done. So these are the few examples, means these are the organic compounds which can also be classified on the basis of the functional group. Okay, this is also in the basis of the functional groups into the families of a homologous series. Into the families of a homologous series. This you need to be very clear about the concept. Clear? Understood? Yella concept understand aita. Acyclic bada important ide, aromatic compounds bada important ide, and acyclic compounds means what? Acyclic nalli erade irodu. So cyclic nalli ಎರಡು ತರ ಇದೆ. Alicyclic compounds ಒಂದು, aromatic ಒಂದು. ಇಲ್ಲಿ ಕಲ್ತ್ವಲ್ಲ, ಇಲ್ಲಿ ಹೇಳ್ದಲ್ಲ, ಎಲ್ಲಿ ಹೌದು, ಸೈಕ್ಲಿನ್ ನಲ್ಲಿ ಎರಡು ತರ ಇದೆ. ಅಲಿಸೈಕ್ಲಿಕ್ ಒಂದು, ಆರೋಮೆಟಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಒಂದು. ಓಕೆ, ನಾವೀಗ ಆರೋಮೆಟಿಕ್ ಕಂಪೌಂಡ್ಸ್ ನಲ್ಲಿ ಏನೇನು ಕಲಿಯೋದು ಅನ್ನೋದು ಅದನ್ನ ನೋಡ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ನಾವು ಇನ್ ಆರೋಮೆಟಿಕ್ ಕಂಪೌಂಡ್ಸ್ ನಲ್ಲಿ ಈಗ ನೋಡ್ಕೊಂಡ್ವಿ ನಾವು. ಒಂದ್ ಸೆಕೆಂಡ್ ಗೈಸ್, ಇಲ್ಲಿ ನೋಡಿ, ಬೆನ್ಜೋನಾಯ್ಡ್ ಅರೋಮೆಟಿಕ್ ಕಂಪೌಂಡ್ಸ್ ನೋಡಿದ್ವಿ. ಬೆನ್ಜೋನಾಯ್ಡ್ ಅರೋಮೆಟಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಹೇಗಿದೆ ನೋಡಿದ್ವಿ. ನಾನ್ ಬೆನ್ಜೋನಾಯ್ಡ್ ಇಲ್ಲಿದೆ, ನಾನ್ ಬೆನ್ಜೋನಾಯ್ಡ್ ಕಂಪೌಂಡ್ಸ್ ಹೇಗಿದೆ ಅಂತಾನು ನೋಡಿದ್ರಿ. Done. So these are the two types which are present in what? Which are present in the aromatic compounds. Okay, aromatic compounds nalli we have learned two types. We have learned two types. One is benzonoid aromatic compounds and one more is non-benzonoid compounds. Clear? So this is what flowchart will help you people to learn it in the easiest way. ಈಗ ನಿಮಗೆ ಗೊತ್ತಾಯ್ತು ಯಾವ್ದು ಓದಿದ್ರೆ ಯಾವ್ದು ಓದಿಲ್ಲ ಅನ್ನೋದು. Right? Next comes what? Functional group and a homologous series. So what are this functional group? And some questions will be asked also, like identify the functional group in that compound. Okay, ಈ compound ನಲ್ಲಿ functional group ಅನ್ನ find ಮಾಡಿ. So ಅದನ್ನ ನಾವು ಇವತ್ತು find ಮಾಡೋದು. Okay, functional group ಅನ್ನ ಹೇಗೆ find ಮಾಡ್ಕೋಬಹುದು? Now functional group, that is atom or a group of atoms giving specific chemical properties. Specific chemical properties ಅಂದ್ರೆ example OH, CHO, COOH. So these all are the simple functional groups which will be added to the full compound, like structure. Ina benzene ತಗೊಂಡೆಪ್ಪ. Okay, I have taken the benzene right now. ಇದು benzene ನಮಗೆ ಗೊತ್ತಿದೆ. This is one structure. Okay, I am adding one functional group to it. I'm adding one functional group to it. When I added the OH has a functional group, what it will act? It will act like a phenol. It will act like a phenol. That is what I wanted to make you understand. This is actually called as what? Functional group. See, ma'am ge ಅಯ್ಯೋ ಹ್ಯಾಂಡ್ರೈಟಿಂಗ್ ಸರಿ ಆಗ್ತಿಲ್ಲ ನಂದು ಇವತ್ತು. It's okay. So this is how you people need to understand it. Clear? Understood? Next, homologous series, that is group of compounds with the same functional group and a general formula. Clear? These homologous series are actually a group of compounds with the same functional group and general formula, and the successive members differ by CH2 unit. Means it will be little bit differing. You will understand it when you see the more and more examples. Okay, examples solve makkoth hogtiralla avag understand agutte. First is alkanes, alkenes, alkynes, alcohols, halides, acids, amines. These are all the simple examples for the functional groups. And the compounds with 2 or more functional groups are called as polyfunctional compounds. So those all are called as what? Polyfunctional compounds. Means what? You know, poly means what? More. 2 or more. 2 or more ಅಂದ್ರೆ 3ಕ್ಕಿಂತ ಇಲ್ಲಾಂದ್ರೆ 2ಕ್ಕಿಂತ ಜಾಸ್ತಿನೇ ಇದ್ರೆ ಅವಕ್ಕೆಲ್ಲ ಪಾಲಿ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, that is actually called as what? Polyfunctional compounds. Clear? Next, nomenclature of the organic compounds. Millions of organic compounds need systematic naming, and IUPAC system gives the names based on the structure. Okay, this IUPAC system will give the names based on its structure. Okay, based on its structure, it is going to give its names. Like IUPAC ಅಂದ್ರೆ ನೇಮ್ ಏನು, ಈಗ ನನ್ನ ನೇಮ್ ಏನು ಅಂತ ಹೆಂಗೆ ಗೊತ್ತಾಗುತ್ತೆ? ಆಧಾರ್ ಕಾರ್ಡ್ ಇರುತ್ತಲ್ಲ ಅದೇ ಥರ IUPAC ಇಲ್ಲಿ ಇದರದ್ದು ಆಧಾರ್ ಕಾರ್ಡು. ಓಕೆ, ನಮ್ದು ಏನು ಪರ್ಫೆಕ್ಟ್ ನೇಮ್ ಅಲ್ಲ ಅದು IUPAC ಇಂದ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ದಿಸ್ IUPAC will help us to know its ಆಧಾರ್. ಓಕೆ, ಏನಪ್ಪ ನಿಂದ ಆಧಾರ್ ಕಾರ್ಡ್ ಅನ್ನೋದು ನಾವು ಹೋಗಿ ಬೇರೆ ಬೇರೆ ಕಂಪೌಂಡ್ಸ್ ಅನ್ನ ಇವತ್ತು ಕೇಳಬಿಡೋಣ, ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್, earlier compounds were named by origin or properties, like example citric acid and the formic acid. So formic acid, citric acid, these are all the acids. Okay, ಇವೆಲ್ಲ acids ದು ಹೇಗೆ ಫಾರ್ಮ್ ಮಾಡ್ತಿದ್ವಿ ನಾವು? We used to do it like on the basis of what compounds are present named on its origin. Origin ಅಂದ್ರೆ ಏನು? ಇದಕ್ಕೆ ಮೊದಲು ಏನು ಹೆಸರಿಟ್ಟಿದ್ರಲ್ಲ ಅದರಿಂದ ಕರಿತಿದ್ರು. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್, ಈಗ ನನ್ನ ಹೆಸರು ರಿತಿಕಾ ಇದೆಯಪ್ಪ, ಸೊ ನನಗೆ ರಿತ್ಯ ಇವೆಲ್ಲ ಹೆಸರು ಕರೀತಾರೆ. ಇಟ್ಸ್ ಮೈ ಒರಿಜಿನ್. ಓಕೆ, ಲೈಕ್ ನಾವು ವಾಟ್ ಇಸ್ ಮೈ IUPAC ನೇಮ್? My IUPAC name is what is there in my Aadhaar card. Like that only, it is also IUPAC which we are going to learn about in detail. Clear? Next, such old names are called as tribal or common names also. Tribal common names ಅಂದ್ರೆ ನಮ್ದು ಹೆಸರು ಬೇರೆ 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 ತರ ಇರುತ್ತಲ್ಲ, ಹುಟ್ಟಿದ ಹೆಸರಪ್ಪ ಬೇರೆ ಬೇರೆ ಹೆಸರು, ಅವಕ್ಕೆಲ್ಲ ಟ್ರೈಬಲ್ ನೇಮ್ ಅಂತ ಕರೀತಾರೆ, ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್, some common names, example Buckminster Fuller's are still used when IUPAC names are long or complex. When IUPAC names are going to be the long or complex. Next comes common and or tribal names of some organic compounds. Some tribal ಮತ್ತೆ common names ಅನ್ನ ನೋಡ್ಕೊಳ್ಳೋಣ. First one is CH4. That is actually a compound. Common name is what? Methane. Common name is what? CH4. ಏನು common name? CH4 ಏನಂತ ಕರೀತಾರಪ್ಪ? ಮೀಥೇನ್ ಅಂತ ಕರೆದ್ರಪ್ಪ, ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ CH2. that is going to be what? CH3, CH2, CH2, CH2. So what is this name called as? It is called as N-butane. It is called as what? N-butane. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಅದೇ ಥರ ಐಸೋಬ್ಯೂಟೇನ್ ಇದೆ, ನಿಯೋಪೆಂಟೇನ್ ಇದೆ, ಎನ್ ಪ್ರೊಪೈಲ್ ಆಲ್ಕೋಹಾಲ್, ಇವೆಲ್ಲ ಕಾಮನ್ ನೇಮ್ ಅದರದ್ದು. ಕಾಮನ್ ನೇಮ್ ಮೀನ್ಸ್ ವಾಟ್ ಎವ್ರಿ ಒನ್ ಇನ್ ಯೋರ್ ಗಲಿನಲ್ಲಿ, ನಿಮ್ಗೆ ಯಾವ ಗಲಿ ಇರುತ್ತಲ್ಲ ಅದರಲ್ಲಿ ಯಾರು ಕರೀತಾರೆ, ನಿಮ್ಮ ಪೇರೆಂಟ್ಸ್ ಏನು ಕರೀತಾರೆ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಏನು ಹೆಸರಿಟ್ಟಿದ್ದಾರೆ ನಿಮಗೆ, ಅವಕ್ಕೆಲ್ಲ ಕಾಮನ್ ನೇಮ್. ಓಕೆ, ಆಮೇಲೆ ನಮ್ದು IUPAC ನೇಮ್ ಡಿಫ್ರೆಂಟ್ ಇರುತ್ತೆ. IUPAC ನೇಮ್ ಅಂದರೆ ಏನಪ್ಪ? ಆಧಾರ್ ಕಾರ್ಡ್ ನೇಮ್. ಡನ್. ನಾವು HCCH ಅದು ಫಾರ್ಮಾಲಿಹೈಡ್. ಸೊ CH3 CO, that is acetone, CHCl3 chloroform, CH3COH acetic acid, C6H6 benzene, C6H6O CH3 anisole, C6H5NH2 aniline, C6H5COCH3, that is going to be the acetopenone, and last one CH3OCH2CH3, that is ethyl methyl ether. Okay, ethyl methyl ether. Few examples about the structure and means compound and its common name. Clear? This is what you people need to understand. Means common name andre enu, IUPAC name andre enappa. Done. Now next comes IUPAC system of a nomenclature. A system name of an organic compound is generally derived by identifying the parent hydrocarbon and the functional group attached to it. See the example given below. So they have given one simple example here. Check it out. Which are the functional group, which is the parent chain, and which is the functional, which is a branch, and this all things they have mentioned it very clearly so that you can take this example and you can easily write its IUPAC name. Okay, easily can write its IUPAC name. Now, systematic name of an organic compound is generally derived by identifying the parent hydrocarbon and the functional group attached to it. Like example, this is one compound we have done. So now it has one functional group here, has OH. Okay, ಇದಕ್ಕೇನು ಕರೀತಾರಪ್ಪ? This is actually called as a functional group. Done. This is actually called as a functional group. ಇಲ್ಲಿ ಒಂದು functional group ಇದೆ. Okay, next one more is there here. This is actually a branch. This is a branch chain which is present. Here ಇಲ್ಲಿ ಮತ್ತೆ branch ಮಾಡ್ಕೋಬಹುದು. ಈ ಕಾರ್ಬನ್ಗೆ 3 ಹೈಡ್ರೋಜನ್ ಹಾಕಿದ್ರೆ ಬ್ರಾಂಚ್ ಆಗುತ್ತೆ ಮತ್ತೆ. Aita. So next comes the parent chain. This is going to be the parent chain here itself, CH, that's going to get attached to the functional group OH. Clear? So this is how you people can refer it and write it. Okay, you can refer it and write it. Then next comes the hydrocarbons. Hydrocarbons are the compounds with only C and H. Okay, hydrocarbons andre enu? Hydrocarbons name nalline gottagtide. What is that? It is being told as carbon is present and hydrogen is present inside it. Okay, hydrogen matte carbon. Hydro andre hydrogen, hydro andre hydrogen. I'll write it down one second. Hydro andre hydrogen, idandre carbon. Done. Next, saturated hydrocarbons, only CC single bonds called as alkanes and formulary paraffins will be present, and unsaturated hydrocarbons and it contains C double bond C or C triple bond B C. These all are called as alkenes or alkynes. Okay, alkenes ಮತ್ತೆ alkynes ಅನ್ನು ಕರೀತಾರೆ unsaturated hydrocarbons ಗೆ. Saturated hydrocarbons ಗೆ ಬರೀ single bonds ಅಷ್ಟೇ ಇರೋದು. Saturated ಅಂದ್ರೆ single bonds ಅಂತ ತಿಳ್ಕೋಬೇಡಿ. Means what? Now you are very much clear. ಎಲ್ಲೆಲ್ಲೆಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಕಂಪೌಂಡ್ ನಲ್ಲಿ ಸಿಂಗಲ್ ಬಾಂಡ್ಸ್ ಇದ್ರೆ ಅವಕ್ಕೆಲ್ಲ ಸ್ಯಾಚುರೇಟೆಡ್ ಕಂಪೌಂಡ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಇನ್ ಕೇಸ್ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ಡಬಲ್ ಬಾಂಡ್ ಅಂಡ್ ಅ ಟ್ರಿಬಲ್ ಬಾಂಡ್, ದೆನ್ ಡಬಲ್ ಬಾಂಡ್ ಮೀನ್ಸ್ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ as alkenes, triple bond means alkynes. So this means what? These all are going to be included in the unsaturated compounds. Understood? Unsaturated compounds ಮತ್ತೆ saturated compounds. So easy to identify. Okay, ಬಹಳ easy to identify ಮಾಡಲಿಕ್ಕೆ. Next, prefix and suffix modify the parent name to give the actual compound name. Okay, this prefix and suffix which are present, it will modify the parent name. Parent name ಅಂದ್ರೆ ಏನು? ಇದು parent name. Okay, parent chain ಇದು parent, it will modify. Okay, it will modify to give a actual compound name. Actual compound name ಏನಿದೆ ಅಲ್ಲ, it will modify to give us very easiest way. Okay, okay. Next, IUPAC nomenclature of alkanes. Now let us learn about the IUPAC nomenclature of the alkanes. First we are going to learn about straight chain alkanes. Straight chain alkanes andre ಏನು branches ಇರಲ್ಲ, straight ಆಗಿರುತ್ತೆ. Okay, ಏನು branches ಇರಲ್ಲ, continuous ಆಗಿ carbon hydrogen ಜೊತೆ attach ಆಗಿ ಬಿಟ್ಟಿರುತ್ತೆ. It's not having any branches there. Okay, first is what? Name based on chain length and with the suffix. And with the suffix means what? ANE. So you need to end it always with the ANE. Done. Next, prefix indicates the number of the carbon atom except the CH4 to C4H10. This is going to be what? Trivial names. Okay, this prefix indicates how many the number of the carbon atoms are present. Okay, ಎಷ್ಟಪ್ಪ the carbon atoms, number of carbon atoms ಎಷ್ಟಿದೆ. Like here 1 it is there, here again ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಕಾರ್ಬನ್ 1 ಇದೆ, ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಎಷ್ಟಿದೆ 4 ಇದೆ. ಇನ್ ದಟ್ ವೇ ವಿ ಕ್ಯಾನ್ ಟೆಲ್ ಅಬೌಟ್ ದ ಪ್ರಿಫಿಕ್ಸ್. ಸೊ ಇಟ್ ಇಸ್ ಇಂಡಿಕೇಟಿಂಗ್ ಅಬೌಟ್ ದ ಪ್ರಿಫಿಕ್ಸ್. ಕ್ಲಿಯರ್? ಸಫಿಕ್ಸ್ ಅಂದ್ರೆ ಏನು? ಎಂಡ್. ಸಫಿಕ್ಸ್ ಮೀನ್ಸ್ ಎಂಡ್. ಸೊ ಸಫಿಕ್ಸ್ ಅಂದ್ರೆ ಎಂಡ್ ನಲ್ಲಿ ಏನಿದೆ ಅಲ್ಲ ಅದನ್ನ ಬರಿಬೇಕು. ಓಕೆ, ನಾವು ನೆಕ್ಸ್ಟ್ ಕಮ್ ದ ಪ್ರಿಫಿಕ್ಸ್. ದಿಸ್ ಪ್ರಿಫಿಕ್ಸ್ ಇಸ್ ವಾಟ್? ಆಡ್ ದ ಹೌ ಮೆನಿ ಆರ್ ದೇರ್, ಹೌ ಮೆನಿ ನಂಬರ್. ಓಕೆ, ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್. Okay, number of carbon atoms. So now differ by CH2 unit, then the members of the homologous series. In case it is differing from the CH2 unit. Okay, CH2 unit ಇಂದ differ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಅದಕ್ಕೆ ಏನು ಕರೀತಾರೆ? homologous series ಅಂತ ಕರೀತಾರೆ. homologous series ಅಂತ ಕರೀತಾರೆ. Done. Yes. Now, according to that, we are going to see the examples. Okay. Now, these are all the unbranched saturated compounds. Just now, I told you saturated compounds andre ಏನು ನಿಮಗೆ ಬೇಕಂದ್ರೆ ಇನ್ನೊಂದ್ಸಲ ಬರೆದು ಬಿಡ್ತೇನೆ ಆಯ್ತಾ. Let us write it only. Okay. ಇಲ್ಲಿ ಬರ್ಕೊಂಡ್ಬಿಡಿ ನೋಟ್ ಅಂತ. This is a note. Saturated andre ಏನಪ್ಪ? Unsaturated compounds. So all this which are the saturated compounds which are present, all this is going to be included where? Saturated compounds means straight chain. No, else don't want straight chain, don't mention it in that way. Saturated compounds with just let us think it like all are single bonds. Okay, single bonds anta ನೆನಪಿಟ್ಕೋಬಹುದು, or else you can write it in this way also. Wait. Okay, single bonds ಅಂತಾನು ಬರಿಬಹುದು, alkanes ಅಂತಾನು ಬರ್ಕೋಬಹುದು. Okay. Done. ಆಮೇಲೆ unsaturated compounds are all are double and triple bonds, and this might be alkenes and alkynes. Clear? So this is how you people can remember the things about saturated and unsaturated compounds. Understood? Clear? Crystal clear? Crystal clear aita? Yes. Let's move to the next part now, that is table 8.2, that is IUPAC names of some unbranched saturated compounds. Means it is not having any branches. These are all the saturated, means single bonds. Okay, single bonds. Let's just take first one has a methane. Methane is a CH4. Whatever the methane is present right now. Okay, methane, hydrogen, hydrogen, hydrogen. This is hydrogen, 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 iodine. CH4. This is the compound. Clear? Now same like that only. Ethane is there. Ethane is also C2H6. C2H6 andre eno? C2H6 andre ee tara 1 2 3 4 5 6. Done. Illi 1 idu 2 3 4 5 6. So and the carbons are going to be how many? 1 and 2. Clear? Next comes what? Propane. Propane C3H3. Okay. C3H3 nalli. So C3H3 1 2 3. Okay. Done. 1 2 3. So next hydrogens are how many? Hydrogens are only 3. Okay. Hydrogens are only 3. We can write it in this way also. Okay, in this way also it can be written. Done. Next comes what? Oh, sorry. ಆಮೇಲೆ ಬ್ಯೂಟೇನ್ C4H10 ಬರ್ಕೋಬಹುದು. C4H10 ಹೇಗೆ ಬರ್ಕೋಬಹುದು? C4H10. Carbon are how many? 1 2 3 4. Carbons are how many? 1 2 3 4. Hydrogens are how many? 10. 1 2 3 4 5 6 7 8 9 10. Done. 1 2 3 4 5 6 7 8 9 10. Done. Like that only you people can write it. Sorry. Yes. Next comes what? Hexane will come. C6H12. Same this way only you people can draw it. Next the heptane. That is C4H16. They have told C4H16. C4H16. 1 2 3 4. Hydrogens are 4. How many 16 carbons needs to be present actually? 16 means 1 2 3 4 5 6 7 8 9 10 ಬರುತ್ತೆ. ಅದಾದ ತಕ್ಷಣ 1 second guys. ಸೊ ಈ ತರ ಹೈಡ್ರೋಜನ್ಸ್ ಬರುತ್ತೆ. ಇದು 4 ಇದು 4 8 9 10 ಇದೆ. ಬಟ್ ವಿ ನೀಡ್ 6 more carbons. We need 6 more carbons. So we need to add up the things here. We need to add the carbons here. So we can add it in this way. Okay, we can add it in this way. Clear? So in this way you people need to draw the structures. Next comes the branched chain alkanes. Now let us learn the branched chain alkanes. Here the small carbon chains, that is alkyl groups, attached to the parent chain. An alkyl group derived by removing the H from the alkane. It has been derived from where? We are going to remove the H from this compound. Clear? So that is called as methyl. Now named by replacing the ANE with YL. So we are going to remove the H. Then afterwards we are going to remove this also. Means suffix anna remove ಮಾಡಿ ಏನ್ suffix ಹಾಕ್ತೇವೆ YL ಅನ್ನ suffix ಹಾಕ್ತೇವೆ. ಯಾದ್ರಲ್ಲಿ this is going to happen in a branched chain. ಏನ್ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ branched chain ಅಲ್ಲಿ ಈ ತರ ನೇಮಿಂಗ್ ಆಗುತ್ತೆ. Clear everyone? In branched chain, this is the way how it's going to get done. It is going to be getting it done. Clear? Okay. Okay, we have some alkyl groups also. Some alkyl groups like methane is there. That is also a structural formula of CH3, and name of the alkali group is going to be methyl. Means what? We are removing one hydrogen from methane. We are removing one hydrogen and we are going to write it as how? We are going to write it as how? Once again guys, I am doing my easy list. Full thandi hattida, thandi. Okay. So next question is what? Molecular formula of C2H6, that is going to be the ethane. So ethane nalli CH means we are adding up the hydrogens here. After that the name of the alkali group will be what? Ethyl. It will be what? Ethyl. Next C3H8 ide. C3H8, this is actually name of the alkane is. Alkane andre saturated one. No? Saturated actually propane ide. But we are doing the now means unsaturated. Means we are doing it in the branched way now. So branched way nalli agutte CH2, CH2, CH3 agutte. We are adding, by removing the ANE, we are adding the YL. Why? Because we are doing the branched one now. We are doing the branched one. Next comes C4H10, that is going to be the butane. This butane, that is CH2. ANE ide matte YL convert ಮಾಡ್ತಿದ್ದೇವೆ. Same ಅದೇ ತರ C10H22 ನು decane ಇದೆ, that is ANE ಇದೆ matte prefix ಅನ್ನು ತೆಗೆದು we are adding it as, suffix ಅನ್ನು ತೆಗೆದು we are adding it as YL. Clear everyone? So this is about the alkali groups. These are the alkane. We are converting them to alkyl. Clear guys? This is also very important. Do it. Okay. Next comes abbreviation of the alkyl group. Now how the abbreviation of the alkyl group means? Starting what you are going to do it. Now methyl means ME, ethyl means ET, propyl means PR, butyl means BU. Means in this way you are going to add the things. Means ಈಗ alkyl group ನಲ್ಲಿ ಹೇಗೆ naming ಹೇಗೆ ಮಾಡ್ತೇವೆ ನಾವು? In case ಇದು ಅಕಸ್ಮಾತ್ butyl means butyl is been attached, it is going to be BU. We are going to write in the IUPAC as BU. Next comes what? Propyl means we are going to write it as ET. Next comes ME, that is going to be the methyl. Ethyl andre ET, propyl andre PR, butyl andre BU. Clear? Understand ಆಗ್ತಿದೆನಾ ಎಲ್ಲರಿಗೂ? Understanding it everyone? Understanding? ಎಲ್ಲರಿಗೂ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗ್ತಿದೆನಾ? Yes. Let's start. Next is branched alkyls have a tribal names also, like propyl, which is having a N-propyl or isopropyl. Depends how you are going to add the N and iso. We'll see the examples, don't worry. So butyl andre adralinu sec means where it is got attached, where the hydrogen is being got attached, depends on that. In case hydrogen is attached to the third carbon, tetra means it is attached to the fourth carbon, but. Like that you need to mention the things. Now special unit is what? CH3, CH2C, CH3, this is going to be the neopentyl. Okay, it is going to be what? Neopentyl. Clear? Yes. So nomenclature are of branched chain alkanes. Now the rules for the naming them are given below. So how you are going to name it? Now you understood basic things. Basic things andre ಏನಪ್ಪ? Basic things andre concept understanding ಆಯ್ತು ನಿಮ್ಗೆ ಈಗ. Okay? ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಯ್ತು. ಈಗ ನಾವು ಏನು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋದಂದ್ರೆ ಯಾವ ತರ ಇದನ್ನ ನೇಮ್ ಮಾಡ್ಕೋಬಹುದು. ಹೌ ವಿ ಕ್ಯಾನ್ ನೇಮ್ ದೆಮ್ ಮೀನ್ಸ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಕಾನ್ಸೆಪ್ಟ್ ಹೌ ಯು ಕ್ಯಾನ್ ನೇಮ್ ದೆಮ್ ದಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ಇಟ್. ಓಕೆ, ಒನ್ ಬೈ ಒನ್ ರೂಲ್ಸ್ ಅನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ ಸೊ ದಟ್ ಇಟ್ ವಿಲ್ ಬಿ ಈಸಿ ಫಾರ್ ಯೋರ್ ಪೀಪಲ್ ಟು ಕಾನ್ಸೆಪ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಚಲೋದಂಗಿರುತ್ತೆ ಆಯ್ತಾ. Selection of a parent chain, like identify the longest continuous carbon chain. This is the parent or a root chain. Longest one ಯಾವ್ದಿದೆ ಅದನ್ನ ನೀವು ನೋಡ್ಕೋಬೇಕು ಫಸ್ಟ್ ಆಯ್ತಾ. ಸೊ ಇಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಲಾಂಗೆಸ್ಟ್ ಒನ್ ಎಷ್ಟು ಕಾರ್ಬನ್ಸ್ ಇದೆ ಅನ್ನೋದು ಬರ್ಕೊಳ್ಳೋದು. ನೋಡಿ 1 2 3 4 5 6 7 8 9. ಓಕೆ, 9 ಕಾರ್ಬನ್ ಇದೆ, 9 ಕಾರ್ಬನ್ ಇದೆ. ಲಾಂಗೆಸ್ಟ್ ಚೈನ್ ಇಸ್ ದೇರ್, 9 ಇಸ್ ದೇರ್. ಓಕೆ, ನಾವ್ ಯು ಗಾಟ್ ಟು ನೋ ಹೌ ಮೆನಿ ಕಾರ್ಬನ್ಸ್, how many are there. Okay, parent ಅಂತ ನಿಮಗೆ ಅಂದ್ರೆ ಗೊತ್ತಿದೆ, CH3 CH2 the single bond CH3 is actually a parents. Okay, ನಿಮಗೆ ಆಲ್ರೆಡಿ ಪ್ರೀವಿಯಸ್ಲಿ ತೋರಿಸಿದ್ದೇನೆ ಯಾವ್ದು ಪೇರೆಂಟು ಯಾವ್ದು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಅಂತ. ಡೋಂಟ್ ಮಿಸ್ ದಿಸ್ ಇಸ್ ಅ ಬೇಸಿಕ್. ಏನೇನು ಕಲ್ಸಿದೇನಲ್ಲ ಅವೆಲ್ಲ ಬೇಸಿಕ್. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಬರ್ತಿದೆ ಈಗ ಆಯ್ತಾ. ಸೊ ನಾವು ಐಡೆಂಟಿಫೈ ದ ಲಾಂಗೆಸ್ಟ್ ಕಂಟಿನ್ಯೂಸ್ ಕಾರ್ಬನ್ ಚೈನ್ ಡನ್. ನೆಕ್ಸ್ಟ್ ಸ್ಪೇಸ್ ಲೈಕ್ insert the example screen selection here means just well let it 1 second guys. typo iro ಆಗಿ ಸ್ವಲ್ಪ ಇದನ್ನ ಸ್ಕಿಪ್ ಮಾಡೋಣ. ಇಲ್ಲಿ ನಾ ಇನ್ಸರ್ಟ್ ಮಾಡೋದಿತ್ತು ಎಕ್ಸಾಂಪಲ್, ಬಟ್ ತಳಗೆ ಇನ್ಸರ್ಟ್ ಮಾಡಿಬಿಟ್ಟೆ ಅದಕ್ಕೆ. ಓಕೆ, now if multiply chains of a equal length, like choose the chain with the more side chains. Okay, ಯಾವ side chain ಇದೆ, like 2 ಮತ್ತೆ 6 ಗೆ side chain ಆಗಿದೆ. Now next step is what? That is second is numbering of the carbon atoms in the parent chain. So number of the carbon atoms ಎಷ್ಟಿದೆ ಅಲ್ಲ ಅದೆಲ್ಲ ನಂಬರ್ ಮಾಡ್ಕೊಂಡು ಇಟ್ಕೊಂಡ್ಬಿಡೋದು. ಸ್ಟ್ರೇಟ್ ಚೈನ್ ಅಲ್ಲಿ ಇಲ್ಲಿ ತನಕ ಇದೆ, 9 ತನಕ ಇದೆ, 9 ತನಕ ನಾವು ನೇಮ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ವಿ ಆಯ್ತಾ. ನೆಕ್ಸ್ಟ್ ನಂಬರ್ ಫ್ರಮ್ ದ ಎಂಡ್ ಕ್ಲೋಸರ್ ಟು ದ ಫಸ್ಟ್ ಬ್ರಾಂಚ್ gives the lowest locates to the substituents. Means what? ನಿಯರೆಸ್ಟ್ ಒನ್ ಯಾವ್ದಿದೆ ಬ್ರಾಂಚ್ ನಲ್ಲಿ ಫಸ್ಟ್ ಇರೋದು ಇಲ್ಲಿ. ಓಕೆ, ಈ ಇದರಲ್ಲಿ ಯಾವ್ದು ಬ್ರಾಂಚ್ ಇದೆ ದೂರ ಇರೋದು ಇದು, ರೈಟ್. ಸೊ ಫ್ರಮ್ ದೇರ್ ವಿ ವಿಲ್ ಸ್ಟಾರ್ಟ್. From here we are going to start from there. Clear? This is how you need to number the things. Means it will give the lowest locates to the substituents. Means whatever the number of the end closet is there for the first branch chain. For the first branch chain. Next step is naming the substituents and the parent alkane. Like alkyl groups attached as a branches are prefixed to parent alkane name. Okay. And this position of the substituents indicated by the number. Yelli attach agide. Like example I will tell you, it is got attached to the 2. And 2 anta ನೀವು ಮೆನ್ಷನ್ ಮಾಡಬೇಕು ಆಯ್ತಾ. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ಇಟ್ ಇಫ್ ಡಿಫರೆಂಟ್ ಅಲ್ಕೈಲ್ ಗ್ರೂಪ್ಸ್ ಆರ್ ದೇರ್ ಲಿಸ್ಟ್ ಇನ್ ಆಲ್ಫಾಬೆಟಿಕಲ್ ಆರ್ಡರ್. ಮೀನ್ಸ್ ಆಲ್ಫಾಬೆಟಿಕಲ್ ಆರ್ಡರ್ ನಲ್ಲಿ ಲಿಸ್ಟ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ಬೇಕು ನಾವು. ಓಕೆ, ಒಮ್ಮೆ ನಿಮ್ಗೊಂದು ಎಕ್ಸಾಂಪಲ್ ತೋರಿಸ್ತೇನೆ. Okay, don't worry. So now next comes the identical substituents, like number of the separated by the commas. Use the prefix, like example whether it is a di, whether it is a tri. Like example, ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಸಿಂಪಲ್ ಒನ್. ಸೊ ಇಲ್ಲಿ ಏನಿದೆ ಅಲ್ಲ 2 4 ಡೈಮೀಥೈಲ್ ಇದೆ. ಓಕೆ, ನಾವು ಫಸ್ಟ್ ಕಾರ್ಬನ್ಸ್ ಅನ್ನ ನೇಮಿಂಗ್ ಮಾಡ್ಕೊಂಡ್ವಿ 1 2 3 4 5. ಯಾವ್ದು ಬ್ರಾಂಚ್ ನಿಯರೆಸ್ಟ್ ಇದೆ ಅದರಿಂದ ನೇಮಿಂಗ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ವಿ 1 2 3 4 5. Okay, I'll stand here and tell. ಸೊ ಇಲ್ಲಿ 1 2 3 4 5 ಅಂತ ಬರ್ದ್ಬಿಟ್ವಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ವಾಟ್ ಇದೆ, ಎಲ್ಲಿಂದ ಅಟ್ಯಾಚ್ ಇದೆ. 1 ಕಾರ್ಬನ್ ಇಸ್ ಅಟ್ಯಾಚ್ ಟು 2 ಹಾಕಿದ್ದು, 4 ಗೆ ಇನ್ನೊಂದು ಬ್ರಾಂಚ್ ಅಟ್ಯಾಚ್ ಇದೆ 4 ಬರ್ದ್ವಿ. 2, 4 ಮೀನ್ಸ್ ಎಲ್ಲೆಲ್ಲಿ ಬ್ರಾಂಚ್ ಆಗಿದೆ ಅಲ್ಲ ಆ ನಂಬರ್ಸ್ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ಸೊ ಓನ್ಲಿ ವಿ ಶುಡ್ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಇಸ್ ವಾಟ್ ಟು ನಂಬರ್ ದ ಕಾನ್ಸೆಪ್ಟ್. ಓಕೆ, ನಂಬರಿಂಗ್ ಮಾಡಿಬಿಟ್ರೆ ಈಸಿ ಆಗುತ್ತೆ ನಿಮಗೆ ಹಾಕ್ಲಿಕ್ಕೆ. ಸೊ ದಿಸ್ ಇಸ್ 1 2 3 ಸಾರಿ 2 ಒಂದು ಅಟ್ಯಾಚ್ ಇದೆ 2 ಬರ್ದ್ವಿ, 4 ಅಟ್ಯಾಚ್ ಇದೆ 4 ಬರ್ದ್ವಿ. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ದ ಡೈ ನೈಟ್ರೋ ಮೀನ್ಸ್ ಡೈ ಮೀಥೈಲ್. ಮೀಥೈಲ್ ಅಂದ್ರೆ CH3 ಇದೆ, ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ ಎಲ್ಲಿಂದ ಅಟ್ಯಾಚ್ ಆಗಿದೆ ಅನ್ನೋದು. CH3 ಇದೆ, ಡೈ 2 ಡೈ ಮೀಥೈಲ್. Pentane. Pentane means what? Pentane means 5 are there. Carbons are almost 5. That is going to be the pentane. Clear everyone? That is how you people are going to repeat the groups. Now next comes one more time same example. I'll explain it again. Nam first ಏನು ಮಾಡೋದು ನಂಬರಿಂಗ್ ಹಾಕಿದ್ದು 1 2 3 4 5 ನಂಬರಿಂಗ್ ಆಯಿತು. ನಂಬರಿಂಗ್ ಆದ ತಕ್ಷಣ ಈಗ ಎಲ್ಲೆಲ್ಲಿ ಬ್ರಾಂಚಸ್ ಇದೆ ಆ ಕಾರ್ಬನ್ಸ್ಗೆ ಎಲ್ಲೆಲ್ಲಿ ಬ್ರಾಂಚಸ್ ಇದೆ ಅಲ್ಲ ಅದನ್ನು ಬರ್ಕೊಳ್ಳೋದು. ನೆಕ್ಸ್ಟ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಫಸ್ಟ್ ಇಸ್ ದೇರ್ 2 2ಗೆ 2 ಬ್ರಾಂಚಸ್ ಇದೆ ಆಕ್ಚುಲಿ, ಇಲ್ಲೊಂದು ಸೊ 2 ಬರ್ದ್ವಿ. ಆಮೇಲೆ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ವಿತ್ ಬ್ರಾಂಚಸ್ ವಿತ್ 4 ಹಾಕಿದ್ವಿ. ದೆನ್ ಟ್ರೈ, ವೈ ಇಸ್ ಇಟ್ ಟ್ರೈ ಆಕ್ಚುಲಿ? ಬಿಕಾಸ್ ವಿ ಹ್ಯಾವ್ ಓನ್ಲಿ 3 CH3s. ಡನ್. ಸೊ ಟ್ರೈ ವಿ ಹ್ಯಾವ್ ಆಡೆಡ್ methyl pentane. Done. 5 are the pentane. Clear? This is how you people need to understand the concepts and name it. First you people are going to number the carbon atoms. Once you number the carbon atoms, that is done, you will start doing with the carbons. Like example, L branch start agide, whether it is at 2, whether it is at 4, that you are going to check it properly and then do it. Done. Next, equivalent substituents. Like if substituents are in equivalent position, lower the number of the goes to 1 and first in the alphabetical order. Okay, first what you will do, equivalent substituents andre substituents yavyavadalla equivalent position alli ideno illo, yav lower number ide which will go to the first and which alphabetic order it's going to go, that also you need to check it. Okay. Then next comes the named branched alkyl groups. So how the named branched alkyl groups will be done? Now whatever the carbon is being attached to the parent chain, numbered has 1 in the branch. Okay, yavda parent chain attached ide, alli antu 1 ide. Okay, 1 in the attached ide, so we are going to mention that has a 1 here. Then it has been attached to the 3, that 3 branch, that is CH3, that you are going to mention it without miss. Okay, name of the branched group placed in the parentness, and the prefix is a iso or neo counted in a name like sec and tet or not counted. Okay, so ಯಾವ್ಯಾವ ಕೌಂಟ್ ಆಗುತ್ತೆ? ಬರೇ ಐಸೋ ಮತ್ತೆ ನಿಯೋ ಅಷ್ಟೇ ಕೌಂಟ್ ಆಗೋದು. ಓಕೆ, ಐಸೋ ಮತ್ತು ನಿಯೋ ಅಷ್ಟೇ ಕೌಂಟ್ ಆಗೋದು. ಆಮೇಲೆ ಸೆಕ್ ಮತ್ತು ಟೆಟ್ ವಿಲ್ ನಾಟ್ ಬಿ ಕೌಂಟೆಡ್. ಸೆಸ್ ಮತ್ತೆ ಕೌಂಟು ಅವೆರಡು ಕೌಂಟ್ ಆಗಲ್ಲ. ಕ್ಲಿಯರಾ? ಅಂಡರ್ಸ್ಟುಡ್ ಇಟ್? ಅದು ತಿಳಿತಾ ಇಲ್ಲಿ ತನಕ? Let's move to the next part then. Okay, next ಬರೋದೀಗ so few examples also they have given. Concentrate properly here. So that how ಹೇಗೆ ಮಾಡ್ಕೋಬಹುದು ಇದೆ, ಏನೇನು ಕಲ್ತ್ವಲ್ಲ ರೂಲ್ಸ್ ಅನ್ನ ಹೇಗೆ ಮಾಡ್ಕೋಬಹುದು ಈಗ. ಸೊ ಇಲ್ಲಿ ನೋಡಿ ಚೆಕ್ ಮಾಡಿ, CH3 CH2 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 CH CH2 CH CH2 CH3 ಅಂತ ಇದೆ. ಓಕೆ, ನಾವೀಗ ಫಸ್ಟ್ ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು? ಇಲ್ಲಿಂದ ನೇಮಿಂಗ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ವಿಯಪ್ಪ. 1 2 3 4 ಡನ್. ನೆಕ್ಸ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಾರ್ಟ್ ಇಟ್ ಫ್ರಮ್ ಅಗೇನ್ ವೇರ್ 5 6 7 8 9 10. Why? Because there is having a different branches there. Okay, and it is having a different branches. According to that we have 2 names for that. Okay, ಎರಡು ತರ ನೇಮ್ ಇದೆ. I'm so sorry guys, one second. ಆಯ್ತಾ? ಸಾರಿ. ಓಕೆ, ಎರಡು ತರ ನೇಮ್ ಇದೆ. ಫಸ್ಟ್ ಒನ್ ಇಸ್ 5,2 ethyl butyl and 3,3 dimethyl decane ಇದೆ, and not the 5,2,2 dimethyl and 3 ethyl decane ಮತ್ತೆ ಇದೆ. Means what? They are having a 2 names. Okay. ಒಂದು ನಿಮಿಷ. Yes, so this is how you people can name it. Okay, now one more option is 5,6-butyl ಮತ್ತೆ one more 4-isobutotitrile. So this is also simple example which we can give it. So ಇಲ್ಲಿ ಇದೆ 5,2,2 dimethyl propyl no. So ಇದು example ಕೊಡಬಹುದು. So these are the 3 examples which are very important for you people to understand it. Okay, all the examples are important, must do ಇವೆಲ್ಲ. Clear? Next, cyclic compounds. Now you people got to know what is the meaning of a saturated one and unsaturated one. Now we are going to learn about the cyclic compounds. Okay, once we are done with the cyclic compounds, I'll give you people 10 minutes break. Okay, now cyclic compounds are saturated monocyclic compounds which prefix is always going to be in the form of what? Cyclo to parent alkane name. So ಯಾವ parent alkane name ಜೊತೆ ಇದೆ ಅಲ್ಲ ಅದಕ್ಕೆಲ್ಲ cyclo ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ಲೈಕ್ ಪೇರೆಂಟ್ ಎಕ್ಸಾಂಪಲ್ ಅಂದ್ರೆ ಈಗ ಇದು ಪೆಂಟೇನ್ ಇದೆ. ದಿಸ್ ಇಸ್ ಆಕ್ಚುಲಿ ಅ ಪೆಂಟೇನ್. Right, for this pentane, before that we need to go add the cyclo. It means what? Cyclo is going to be what? Prefix. Clear? Cyclo is going to be the prefix and pentane is going to be the parent alkane name. That is going to be what? Parent alkane name. Next, apply the same rules for the numbering and the substituents. Means all remaining things, whatever it is there, it will be same exactly how we have learnt about the IUPAC itself. Naming of IUPAC and rules kaltvalla. Same adhe tara irutte. Enu changes iralla. Only the changes will be what? There will be only changes that before any parent atom, we are going to write it as cyclo before that. Okay. Elladrallu cyclo anta mention ಮಾಡಬೇಕು because before the parent atom. Okay. Like example, here we can check it out here. Alphabetical order of the numbering is going to be starting from here. Okay. 1, 2, 3, 4, 5, 6 anta mention ಮಾಡಿದ್ವಪ್ಪ. Okay. Here what happens? There one methyl means it has been attached here 1 and 3 propyl. Here it has been attached here propyl. Cyclohexane. Hexane kinta madlu cyclo anta mention ಮಾಡಬೇಕು. This is going to be the prefix. This is going to be the parent atom. Done. This is how you people need to mention about the cyclo also. Same ಅದೇ ತರ numbering ನು same ಮಾಡ್ತಾರಾ, parent atom ನು same ಇರುತ್ತೆ, ಎಲ್ಲ same ಇರುತ್ತೆ. ಅದೇನಪ್ಪ ಅವು closed form ನಲ್ಲಿ ಇರಲಿಲ್ಲ, ಇವೆಲ್ಲ closed form ನಲ್ಲಿ ಇದೆ. So closed form ಇದೆ, ಅದಕ್ಕೆ ನಾವು cyclo ಅಂತ ಕರಿತೇವೆ. Cyclo ಅಂತ ಎಲ್ಲದಕ್ಕಿಂತ parent atom ಕಿಂತ ಮೊದಲು ನಾವು mention ಮಾಡಬೇಕು. ಆಯ್ತಾ? So this is very easy to understand. Cyclos ಅಂತೂ ನೀವು ಈಸಿಯಾಗಿ IUPAC ಅನ್ನ ಬರಿಬಹುದು. ಆಯ್ತಾ? So 1, 2, 3 again named it. Here what is there at the first? That is going to be 3 ethyl. This is 3 ethyl. 1 diethyl. 1 means ಎರಡದೆ ಅಲ್ಲ ಅದಕ್ಕೆ. So 1 dimethyl and it is going to be cyclohexane again. As I told you people, this is a prefix and this hexane is going to act like a parent atom. Done. Next comes what? It is also named in the form of, not in the form of 1 ethyl because it is not having any ethyl here, or 3 and 3 dimethyl. We should not mention it in this way. This is the proper name how you can mention the concept. Clear? Clear everyone? Next. Problem also they have given few problems are there. First is what? Structures and the IUPAC names of some hydrocarbons are given below. Explain why the names given in the parent list are incorrect. Okay. So they have asked that why it is actually incorrect and how actually we can name it. Okay. How actually we can name it and how actually we can parent ಅನ್ನ ನಾ ಏನು ಹೇಳಿದೆ ಸೈಕ್ಲೋನಲ್ಲಿ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಬಿಡಿ. ಸೈಕ್ಲೋ ಯಾವಾಗಲೂ ಪೇರೆಂಟ್ ಆಟಮ್ಗಿಂತ ಮೊದಲು ಬರೀಬೇಕು. ಆಯ್ತಾ? ಸೊ ಉಳಿದದ್ದೇನಿದೆ ಅಲ್ಲ ಅದೆಲ್ಲ ಬರೀತೇವೆ ನಾವು. ಎಲ್ಲಿ ಅಟ್ಯಾಚ್ ಇದೆ, ಯಾವ ಬ್ರಾಂಚ್ಡ್ ಇದೆ, ಎಲ್ಲಿ ಅಟ್ಯಾಚ್ ಆಗಿದೆ ಆ ಬ್ರಾಂಚ್ಡ್ ಚೇನು, ಅವನ್ನೆಲ್ಲ ಸ್ಟಾರ್ಟಿಂಗ್ ಬರ್ಕೊಳ್ಳೋದು. ಅದೆಲ್ಲ ಸ್ಟಾರ್ಟಿಂಗ್ ಬರ್ಕೊಂಡು ಆದ ತಕ್ಷಣ ಸೈಕ್ಲೋ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು ಮತ್ತು ಪೇರೆಂಟ್ ಆಟಮ್ನ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ಮೀನ್ಸ್ ವಾಟ್? ಇಫ್ ಇಟ್ ಇಸ್ ಅ ಬೆನ್ಝೀನ್ ವಿಲ್ ಮೆನ್ಷನ್ ಇಟ್ as benzene, cyclobenzene. If it is hexane we'll mention it as cyclohexane. If it is a butane it is going to be mentioned as cyclobutane. Like this you people need to mention it. Simple and very easy. So idr ella yavadaದ್ರು questions ಕೇಳಿದ್ರೆ ಈಸಿಯಾಗಿ ಆನ್ಸರ್ ಮಾಡ್ಕೋಬಹುದು ನೀವು. ಆಯ್ತಾ? So first is what? CH3CH. It is been branched. So ಇಲ್ಲಿ ಎಷ್ಟು ಬ್ರಾಂಚ್ಡ್ ಇದೆ? 1 2 3 ಬ್ರಾಂಚ್ಡ್ ಇದೆ ಇಲ್ಲಿ. ಆಯ್ತಾ? ಸೊ ಈಗ ಹೇಗೆ ನೆನಪಿಟ್ಕೋಬೇಕು ಅದನ್ನ? 1 2 3 4 5 6 7 8. Done. So ಎರಡಲ್ಲಿ ಅಟ್ಯಾಚ್ ಇದೆ 2. Okay. 1 2 3 5 6 7 8. ಆಯ್ತಾ? ನಂಬರಿಂಗ್ ಮಾಡ್ಕೊಂಡ್ವಾ? ನಂಬರಿಂಗ್ ಆದ ತಕ್ಷಣ ಎಲ್ಲೆಲ್ಲಿ ಕಾರ್ಬನ್ ಅಟ್ಯಾಚ್ಡ್ ಇದೆ? 1 2ಕ್ಕೂ 5ಕ್ಕೆ ಇದು ಅಟ್ಯಾಚ್ಡ್ ಮತ್ತೆ 6ಗೆ ಅಟ್ಯಾಚ್ಡ್ ಇದೆ. ರೈಟನಾ? ರಿಟರ್ನ್. ಡನ್. ನೆಕ್ಸ್ಟ್ ಟ್ರೈಮೀಥೈಲ್. 3 methyl compounds ಇದೆ, 3 methyl ಬರ್ದ್ವಿ. Done. Then it is going to be what? Cyclotane. It is going to be what? Sorry, one second. Ethylostane. Okay, this is also a simple example. Yes. Done. Understood? Clear? Yes, it's correct only. I thought something mistake is there. It's correct. Okay. Next comes one more problem. CH3, CH2, CH, CH2, CH, CH2, CH3. Okay. Illi 1, 2, 3, 4, 5, 6, 7. Okay. Yellel attached ಇದೆ. Third one attached ಇದೆ. 3 ethyl. So, ಮತ್ತೆ ಇನ್ನೊಂದು attached ಇರೋದು fifth ಗೆ. Fifth ಗೆ ಬರೆದ್ವಿ 5 methyl. Done. Then is going to be what? Pentane. This is how you people need to mention the things. Clear everyone? Clear? Yes. Next comes the nomenclature of the organic compounds with the functional group. Okay. Before that, I'll give you people 10 minutes break. You will be having a 10 minutes of break. Make sure you'll be back by 10 minutes. Even I will have some water. I will get hydrated and come. Clear? Done? It's went down. You're gone.
No, it's not gone.
Okay. So everyone understood till here, right? ಇಲ್ಲಿ ತನಕ ಎಲ್ಲರಿಗೂ ತಿಳಿತಾ? ಸೊ ಫ್ರೆಶ್ ಆಗಿ ಬಂದ್ರೆ ಎಲ್ಲರೂ? Everyone got freshed. So now I'm audible, visible, everything is clear. Yes. Start ಮಾಡೋಣ? Next topic ಅನಾ? Yes. So nomenclature of the organic compounds with the functional group. So ಈಗಿನ ತನಕ ಏನೇನು ಕಲ್ತ್ವಿ ನಾವು? We have learned about all the details about the nomenclature. We studied about the things like example ಹೇಗಪ್ಪ ನೇಮಿಂಗ್ ಮಾಡೋದು, ಸೈಕ್ಲೋ ಎಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು, ಎಲ್ಲಿ ಸೈಕ್ಲೋ ಮೆನ್ಷನ್ ಮಾಡಬಾರ್ದು, ಬ್ರಾಂಚೆಡ್ ಚೈನ್ಸ್ ಹೇಗೆ ನಾವು ಮಾಡಬೇಕು, ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಏನು, ನಂಬರಿಂಗ್ ಆಫ್ ದ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್. All things are clear to you people, right? So let's start with the new concept. It's a not new concept. Let's continue with the class after a break now. So nomenclature of the organic compounds with the functional groups. Okay, with the functional groups, how you are going to mention those things. Okay, functional group is like atoms or a group of atoms which is responsible for the chemical reactivity. Clear? Next, the compounds with the same functional group shows the similar reactions, like example OH in CH3OH, CH3CH2OH in CH3, and example full example it is CHOH. Okay, ಇಲ್ಲಿ CH3 2 ಇಲ್ಲಿ ಒಂದೇ ಕಂಪೌಂಡ್ ಬರೆದು ಬಿಡ್ತೀನಿ ಇಲ್ಲಿ ಒಂದು ನಿಮಿಷ. Is one compound, okay? CH3 to CHOH, okay? Next, functional groups allow classification of organic compounds into the different classes. Clear? Next comes what? Naming steps. How you are going to name the things now. So identify the functional group determines the suffix. Okay, ಯಾವ್ದು ಐಡೆಂಟಿಫಿಕೇಶನ್ ಮಾಡ್ತಾರೆ. OH ಇಲ್ಲಾಂದ್ರೆ ಎಕ್ಸಾಂಪಲ್ NO BRO COOH. ಸೊ ಇವೆಲ್ಲ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ಸ್ ಆಯ್ತಾ. ಸೊ ಇವೆಲ್ಲ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ಸ್ ಏನಿದೆ ಅಲ್ಲ, that all things you are going to determine it has a suffix. You are going to determine it all has a suffix. Clear? One minute guys. That's on the AC. Okay, next comes what? Next comes select the longest chain containing the functional group. Means ಯಾವ್ದು ಲಾಂಗೆಸ್ಟ್ ಚೈನ್ ಇದೆ ಅಲ್ಲ ಅದನ್ನ ಮೊದಲು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಓಕೆ, ಬಿಕಾಸ್ ವೈ ನೀಡ್ ಟು ಇಸ್ ವೆನ್ ಮೆನ್ಷನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಇಸ್ ಬಿಕಾಸ್ ಅದರಲ್ಲಿ ನೀವು ಏನಾದ್ರು ಲಾಂಗೆಸ್ಟ್ ಚೈನ್ ಕಂಟೈನಿಂಗ್ ದ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಅನ್ನ ಕಾಂಟ್ಯಾಕ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಈಸಿ ಆಗುತ್ತೆ ನಿಮಗೆ ಆ ಕ್ಲಿಯರಿಟಿ ಸಿಗ್ಲಿಕ್ಕೆ. ಓಕೆ, ಬರೀಲಿಕ್ಕೆ ಅದನ್ನ ನಂಬರ್ ಆಫ್ ದ ಚೈನ್ ಟು ಗಿವ್ ದ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಲೋವೆಸ್ಟ್ ಪಾಸಿಬಲ್ ನಂಬರ್. ಸೊ ಯಾವ್ದು ಲೋವೆಸ್ಟ್ ಪಾಸಿಬಲ್ ನಂಬರ್ ಇದೆ ಅಲ್ಲ ಅದರಲ್ಲಿ ನಂಬರ್ ಆಫ್ ದ ಚೈನ್ ವಿಲ್ ಗಿವ್ ದ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್. ಓಕೆ, ಲೋವೆಸ್ಟ್ ಪಾಸಿಬಲ್ ನಂಬರ್ ಅನ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕು. ನೇಮ್ ದ ಕಂಪೌಂಡ್ ಯೂಸಿಂಗ್ ದ ಅಪ್ರೋಪ್ರಿಯೇಟ್ ಸಫಿಕ್ಸ್. Like example in the table number 8.4. So here is the table number 8.4. According to this examples, you are going to apply this rules. Okay, these rules are apply ಮಾಡ್ಕೊಂಡು ಇದನ್ನ solve ಮಾಡ್ಕೊಳ್ಳೋಣ. Okay, this is there in your NCERT book itself. So make sure you people will be. ನಾನು ಎಲ್ಲಿಂದ ಬೇರೆ ಕಡೆಯಿಂದ ಏನು ತಗೋತಿಲ್ಲ ನಿಮಗೆ. ಐ ಆಮ್ ಎಕ್ಸ್ಪ್ಲೇನಿಂಗ್ ಯು ದ ಸೇಮ್ ಥಿಂಗ್ ವಿಚ್ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ನೋ ಇಟ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಫಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ರೆ ಕ್ಲಾಸ್ ಆಫ್ ದ ಕಂಪೌಂಡ್ ಇಸ್ ಅಲ್ಕೇನ್ಸ್. ಕ್ಲಾಸ್ ಆಫ್ ದ ಕಂಪೌಂಡ್ ಇಸ್ alkanes ತಗೊಂಡ್ವಿ. ಡನ್. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಏನಿತ್ತು ಸ್ಟ್ರಕ್ಚರ್ ನಲ್ಲಿ ಏನು ಇರಲಿಲ್ಲ. ಸೊ IUPAC ಗ್ರೂಪ್ ಏನಿತ್ತು ಪ್ರಿಫರ್ ಇನ್ನೇನು ಇರಲಿಲ್ಲ. IUPAC ಗ್ರೂಪ್ ಸಫಿಕ್ಸ್ ಏನಿತ್ತು ANE. ದಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ANE ಹಿಯರ್. ಯು ಕ್ಯಾನ್ ಚೆಕ್ ಅಲ್ಕೇನ್ಸ್ ಅಂದ್ರೆ ANE. ಓಕೆ, ಸೊ ಅಲ್ಕೇನ್ಸ್ ಅಂದ್ರೆ ANE. ಡನ್. ನೆಕ್ಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಏನು ತಗೋಬಹುದು? ಬ್ಯೂಟೇನ್. ದಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ CH3 CH2 to CH3 ಮೀನ್ಸ್ ಸ್ಯಾಚುರೇಟೆಡ್. ಓಕೆ, ಸ್ಯಾಚುರೇಟೆಡ್. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? ಅಲ್ಕೀನ್. ಸಫಿಕ್ಸ್ ಏನಿದೆ ENE ಇದೆ. ಓಕೆ, ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಏನಿದೆ ಇಲ್ಲಿ? ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ C ಸಿಂಗಲ್ ಬಾಂಡ್ C ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? ದ IUPAC ಗ್ರೂಪ್ ಸಫಿಕ್ಸ್ ಏನು? ENE. ಕ್ಲಿಯರಾ? ಸೊ ಎಕ್ಸಾಂಪಲ್ಸ್ ಏನು ತಗೋಬಹುದು? ದೀಸ್ ಆರ್ ದ ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ವಿಚ್ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಇಟ್. But1ene. ENE is a suffix. Clear? Theta. Yes. Next comes alkynes. There the suffix is going to be YNE. YNE is a suffix here. So the functional group of the structure will be C triple bond C. So what will be the option here? Answer will be, means example, CH triple bond C CH2 CH3. CH triple bond CH CCH2 CH3. I know you should not write it in this way. You can write it in this way also. ಹೀಗೂ ಬರಿಬಹುದು ಅದನ್ನ. Triple bond C, CH2, CH3. Okay, best example. Yes. Next in barate arenes. Here also the functional group is nothing. IUPAC name is nothing. IUPAC group suffix is going to be the benzene. Clear? So this is a simple example which we can give it. Next comes what? Halides. So in this halides we are going to do functional group as EX. X is going to be F. X is going to be F, Cl, Br and I. Hello, that is IUPAC group is going to be the hello, and the IUPAC group suffix is going to be nothing. And here the example is going to be the 1-bromobutane. How much it will be? 1-bromobutane. IUPAC group prefix andre hello yakide andre we are going to mention whether it is going to be which compound, okay, which halide we have given is. We have used the halides here, so we are going to mention it as hello here, okay. Next, the alcohols functional group is OH. So OH andre ಏನು ತಿಳ್ಕೋಬೇಕು, it is having alcohol. Done. So next IUPAC prefix ಏನು ಬರುತ್ತೆ? hydroxy, okay. ಎಲ್ಲದರಲ್ಲೂ hydroxy ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿರಬೇಕು, okay, ಎಲ್ಲದರಲ್ಲೂ ಮೆನ್ಷನ್ ಮಾಡಿರಬೇಕು. ಆಮೇಲೆ suffix ಏನಾಗುತ್ತೆ? OL. Next comes the butane O2OL, butane 2OL. Clear? Next, same with the ketones, nitriles, ethers, carboxylic acids, carboxylate ions also is present. Clear? Understood? Okay, let's move to the next part, that is carboxylic acids, carboxylate ions, esters, acyl halides, amines, amides, nitro compounds and sulfonic acids. Clear? This much you people understand. These are the few examples. So this box so bala important to ee box na nodkondre nimage idea tilutte L prefix use ಮಾಡಬಹುದು, L suffix use ಮಾಡ್ಕೋಬಹುದು ಅನ್ನೋದು easy ಆಗಿ understand ಆಗುತ್ತೆ, ಆಯ್ತಾ. Next comes what? Polyfunctional compounds. So polyfunctional compounds are what? Choose principal functional group based on the priority order. So according to the priority order you are going to fix it. Like COOH is greater than the SO3H, then the greater than the SOR, then the greater than the COCl. Next comes the CONH2, then CN, CHO, CO, OH, NH2, CC and C triple bond C. So this is going to be the principal functional based on the priority order. So these are the priority orders which you people need to remember it, okay. Priority order nana ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ, ಆಯ್ತಾ. So this is what is the best option you people can do it. Next, other groups are going to be what? R, C6H6, halogens, NO2OR. These are all prefix. Example ತಗೋಬಹುದು ಇಲ್ಲಿ ನೋಡಿ, ಒಂದು ಕಂಪೌಂಡ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಈ ಕಂಪೌಂಡ್ ನಲ್ಲಿ how much actually how we can mention it, ಬ್ರಾಂಚ್ ಎಷ್ಟಿದೆ? 7 ನಲ್ಲಿ ಬ್ರಾಂಚ್ ಇದೆ ತಿಳ್ಕೊಳ್ಳಿ, ಬ್ರಾಂಚ್ ಆಗಿದೆ. ಸೊ ಹೈಡ್ರೋಆಕ್ಸಿ ಇದೆ. ಹೈಡ್ರೋಆಕ್ಸಿ ಅಂದ್ರೆ ಏನಪ್ಪ? ಹೈಡ್ರೋಆಕ್ಸಿ ಅಂದ್ರೆ ಏನು? ಇಲ್ಲಿದೆ. Where is our hydro? Yes, this is hydroxy. Okay, OL ಇದೆ. ಅದೇ ತರ ಇಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡ್ಕೋಬೇಕು. ಎಲ್ಲೋಯ್ತಪ್ಪ ಇದು? Yes, here. 2ON and keto preferred over the alcohol. Clear? This is the way. Means what? This actually I taken the help of what? The box. That's what I'm telling you. The box is very important. A box and a full perfect ಮಾಡ್ಕೊಳ್ಳಿ, ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ ಕಾನ್ಸೆಪ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗು, ಆಯ್ತಾ. The concept will be understood. Next, multiple same functional group, like use di, tri, etc. before the suffix. Like how much, what is the di andre 2, tri andre 3, and then suffix agi use ಮಾಡ್ಕೋಬೇಕು. If in case whether it is having a CH3 tri, CH2 di, like that you people need to use the things. Like example also they have given it here, CH2OH, CH2OH. This is the example of ethane where 1,2-diol ಅಂತ example ಅನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ. 1,2-diol ಅಂತ example ಕೊಟ್ಟಿದ್ದಾರೆ. Clear ಎಲ್ಲರಿಗೂ? ಆಲ್ಕೋಹಾಲ್ ಅದು ಅದ್ರ ಸಲಾಗಿ OL ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ. Now next, the multiple double or triple bonds, like drop A and E in parent name. So always you need to mention is A and E in the parent name if it is necessary to mention here. Like example, CH2 double bond CH, CH double bond CH2. Here buta is there. How many are there? 5 are there. So you are going to mention it as buta. See, 1, 2, 3, 4. Sorry, 4 are there. So you need to mention it as but. Next, afterwards, you are going to mention as 1, 3, diene, E-N-E. Clear? So, this is how you are going to mention the things. Next comes nomenclature of the substituted benzene compounds. The substituted benzene, that is substitute placed on a prefix to benzene. And the space insert example of the, sorry, okay, I need to insert the example here. I'll just rub this thing. I should mention here, but I have mentioned it down itself. No problem. Okay. Now, distributed benzene, that is number of the ring to give the substituents lowest possible sessions. Like example, 1,3-dibromobenzene. That is going to be what? 1,5-dibromobenzene. It's going to be what? Not a 1,5-dibenzene. It's going to be 1,3-dibromobenzene. Clear? That helps what? Distribution of them. Okay, let's understand it detail now. Like now, trival system is there. What is the trival system right now? So that is ortho means O. Okay, that's going to be 1 or 2. Clear? Meta means what? It means it is attachment for the benzene. If in case you think like this, 1, 2, 3, 5, 6. Done. So ortho means what? 1, 2 is there. How you are going to mention here? This is going to be the ortho. Like that you need to think it. Meta means what? 1 and 3. 1 to 3. This is meta. Okay. Ortho. Meta. Done. Next comes the para. Para is 1 and 4. Here is going to be the para. So always remember, in any of the organisms, ಇವಾಗ ನೀವು GOC ಕಲ್ಕೊಂತ ಹೋಗ್ತಾರಲ್ಲ ಅದಕ್ಕೆಲ್ಲ ಯಾವಾಗ ಪ್ಯಾರಾ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿದಾರ ಅವೆಲ್ಲ is actually called as what? Minor compounds. Sorry, major compounds it is. ಮ್ಯಾಮೇ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತಿದಾರೆ ನೋಡಿ. ಪ್ಯಾರಾ ಇದ್ದಲ್ಲಿ ಏನೇನು ಇರುತ್ತಲ್ಲ ಅವೆಲ್ಲ ಮೇಜರ್ ಕಂಪೌಂಡ್ಸ್ ಆಯ್ತಾ. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? ಎಕ್ಸಾಂಪಲ್ 1,3-dibromobenzene. that is going to be the meta-dibromobenzene. means what? 3 is there. Don't mention 1, 3 mention ಮಾಡಬೇಡಿ. 1, 3 ತೆಗೆದು ಬಿಡೋದು, ಅದಕ್ಕೆ ಮೆಟಾ ಅಂತ ಹಾಕಿ ಬಿಡೋದು, because the 3 ನಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗಿದೆ, right? So the branch is at the 3. So we are going to mention it as meta here. Clear? Now in case 1, 4 is there. 1, 4 we are going to mention it as meta. This is meta. This 4 ko it is attached. No, so we are going to mention it as para. Clear? So in a case it is being got attached to the ortho, means 1, 2 ಇದೆ. So in case it 1, 2 attachment ಇದ್ರೆ direct ಆಗಿ ortho ಅಂತ ಬರೆದು ಬಿಡಿ. Right? Ortho ಅಂತ ಬರೆದು ಬಿಡಿ. Simple. Ortho ಅಂದ್ರೆ 2, para ಅಂದ್ರೆ 4, 3 ಅಂದ್ರೆ meta. Done. Ortho, para, meta. Sorry. Ortho, meta, para. Means OMP. Okay. OMP. So we can mention it OMP. ಯಾವುದಾದ್ರೂ ಹೆಸರು ನೆನಪಿಟ್ಕೋಬಹುದು ನೀವು ಇದರಿಂದ. This is called as ortho, meta and then the para. ಓಂ ಅಂತ ನೆನಪಿಟ್ಕೋಬಹುದು. ಓಂ ಪಿ. ಓಕೆ, ಓಂ ಪಿ ಇಲ್ಲಾರೆ ಓಂ ಪ್ರಸಾದ್ ಅಂತ ನೆನಪಿಟ್ಕೋಬಹುದು. ಓಂ ಪ್ರಸಾದ್ ಇಂದ ಈಸಿ ಆಗುತ್ತೆ. ಓ ಅಂದ್ರೆ ಆರ್ಥೋ ಬರುತ್ತೆ, ಮೆಟಾ ಅಂದ್ರೆ ಎಂ ಅಂದ್ರೆ ಮೆಟಾ ಬರುತ್ತೆ, ಪಿ ಅಂದ್ರೆ ಪ್ಯಾರಾ ಅಂತ ಬರುತ್ತೆ. ತೀತಾ. Next, benzene has a substituent now called penyl C6H5PH. When attached to an alkane or functional group, this structural isomerism, same molecular formula but different connectivity of the atoms. The connectivity will be little bit different. In this only we have a detailed structure also which we are going to learn. Detailed structure annu alkalgino. Okay, detailed structure annu nodona. Like chain isomerism andre different carbon skeletons will be present. This is the different types of carbon skeletons which is having it. Means what? Carbon is connected in a different way. Chain form nalli irutte but different way nalli join agirutte. Clear? So this is the simple examples about pentane, about the isopentane and the neopentane. Clear? Next, Position isomerism, same skeleton like substituent or functional group at a different positions. So functional group mattidu different positional irutte. See, this is the functional group actually ours, right? How it has been attached, you can just check it. Okay, hege attach agide nodi illi. Ade means what? It will be having a different positions. So this is a functional group. It has been attached in the what? Different functional group, different position. Okay, it's attached in the different position. Done now. Next comes the functional group isomerism, where the same formula, different functional groups. Like example C3H6O, where the aldehydes and ketones are present. Aldehydes and ketones are present. You can just observe here only. Propano ide, amele propanol ide. Propano ide, matte propanol ide. Clear? So, ee tara neevu concepts ana understand ಮಾಡ್ಕೊಂತ ಹೋಗಬೇಕು ಆಯ್ತಾ. Next, the metamerism, there is different alkyl groups on either side of the functional group. Like example C4H10O, that is also called as methoxypropane. Methoxypropane. Simple, this is a flow chart for the isomerism. Flow chart for the isomerism. So, इतर प्रकार नीवु कलियोदु इवत्तु. Okay, we are going to learn this right now with this concept. Okay, now ಈಗ isomerism ತಗೊಂಡಿದೆ. ಈ isomerism two types ನಲ್ಲಿ ಇರುತ್ತೆ. ಒಂದಿರೋದು structural isomerism, ಇನ್ನೊಂದಿರೋದು stereomerism. Okay, ಒಂದಿರೋದು structural, ಇನ್ನೊಂದು stereomerism. Now ಈಗ structural isomerism ನಲ್ಲಿ ಏನು ಕಲಿತಿದ್ದೇವೆ? Structural isomerism ನಲ್ಲಿ chain isomerism. Yes, understanding full understanding ಇದೆನಾ ಇವತ್ತು? Yes. So, ಇಲ್ಲಿ structural isomerism ನಲ್ಲಿ chain isomer ಬಂದಿದೆ, position isomerism ಮತ್ತೆ functional group isomerism ಮತ್ತೆ meta isomerism, right? Now we have learnt already about the chain isomerism. We learnt about the position isomerism. ಯಾವ ತರ position different ಆಗಬಹುದು functional group ದು. Okay, chain isomerism ಕಲ್ತ್ವಿ, example ನೋಡಿದ್ವಿ. Functional group isomerism just ನೋಡಿದ್ವಿ. Metamerism ಅಂತೂ ಇಲ್ಲೇ ಮೇಲ್ಗಡೆ ಇದೆ ನೋಡಿದ್ವಿ, ಚೆಕ್ ಮಾಡಿದ್ವಿ ಆಯ್ತಾ. So this is all actually called as what? About the structural isomerism. Now we are going to learn about the stereomerism. In the stereomerism, we will be learning two types, which are that geometrical isomerism ಮತ್ತೆ optical isomerism. Clear? So ಈಗ stereo isomerism ಅಲ್ಲಿ ಇವೆರಡು completely understand ಮಾಡ್ಕೊಳ್ಳೋಣ ಆಯ್ತಾ. Let's move to the stereo isomerism. So before that, I'll help you people to make you understand what you have learnt also. See the position isomerism. So ಇಲ್ಲಿ position isomerism. So the chain isomerism ನಲ್ಲಿ different carbon skeletons ಇರುತ್ತೆ. So this is having a different carbon skeletons. ಇದು pentane ಅಂದ್ರೆ ಈ ತರ ಬರುತ್ತೆ, isopentane ಅಂದ್ರೆ ಈ ತರ ಬರುತ್ತೆ, neopentane ಅಂದ್ರೆ ಈ ತರ ಬರುತ್ತೆ. Means structures are different. Okay, that's what they have told it here. Different carbon skeletons will be present in the chain isomerism. Next, the position isomerism ನಲ್ಲಿ ಏನು ಕಲ್ತ್ವಿ ನಾವು? Here same skeleton will be same. Means ಏನೇ skeleton ಇದೆ ಇದ್ರದ್ದು ಅವೆಲ್ಲ ಸೇಮ್ ಇರುತ್ತೆ. But substituent or the functional group at the different position. Okay, ಏನ್ ಚೇಂಜಸ್ ಇರುತ್ತೆ? ಬರೀ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಏನಿರುತ್ತಲ್ಲ, ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಡಿಫರೆಂಟ್ ಪೊಸಿಷನ್ ನಲ್ಲಿ ಇರುತ್ತೆ. ಅವಕ್ಕೆಲ್ಲ ಏನ್ ಕರೀತಾರೆ? ಪೊಸಿಷನ್ ಐಸೋಮರಿಸಮ್. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? Functional group isomerism. There the same formula, different functional groups will be present. Formula ಅಂತೂ full same ಇರುತ್ತೆ. ಪ್ರೊಪೆಯಾನೋ, ಪ್ರೊಪೆನಾಲು ಎಲ್ಲ ಸೇಮ್ ಇರುತ್ತೆ. ಬಟ್ ಏನಾಗುತ್ತೆ? ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಚೇಂಜ್ ಹಾಕೊಂತ ಹೋಗುತ್ತೆ. Functional groups will be changed. Like example, they have given it has aldehydes and the ketones. Done everyone? Clear with all this three: chain, position and the functional group isomerism. And the metamerism is what? Different alkyl groups on either side of the functional group. So either side of the functional group nalli different type of an alkyl group will be present. Alkyl group different irutte at the side of the functional group. This much you people understand. It will be easy to completely understand about the structural isomerism. Okay, so isomerism definition kaltvi at takshana we have learnt about the structural isomerism. In structural isomerism we learnt about the chain isomerism, position isomerism, we have learnt functional group isomerism and the metamerism. Clear? Let's move to the stereoisomerism. In that stereoisomerism, first we are going to learn about the geometrical isomerism. That is geometrical isomerism. Let's start. Stereoisomerism, there is same connectivity but different spatial arrangement atoms. So different spatial arrangement atoms will be present. Okay. See, it is having a same connectivity. Connectivity same irutte. See, ಈಗ ಏನು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ಬೋದು ಅಂದರೆ ನಾನು ಈಗ ಒಂದು ಫ್ಯಾಮಿಲಿ ಇದೆ. ಓಕೆ, ವಿ ಹ್ಯಾವ್ ಅ ಬಿಗ್ ಫ್ಯಾಮಿಲಿ, ಹ್ಯೂಜ್ ಫ್ಯಾಮಿಲಿ ಇದೆ. ಸೊ ಈ ಹ್ಯೂಜ್ ಫ್ಯಾಮಿಲಿನಲ್ಲಿ ಯಾವ ಥರ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ ಕಾನ್ಸೆಪ್ಟ್ಸನ್ನು ಈಗ, ಸೊ ನಂದು ರಿಲೇಷನ್ ಏನಿದೆ ಅಲ್ಲ, ನಾವು ಅಪ್ಪನ ಕಡೆಯಿಂದ ಎಲ್ಲೋ ದೂರಿನ ರಿಲೇಷನ್ಶಿಪ್ ಇದೆ. ಮೀನ್ಸ್ ವಾಟ್, ಐ ಹ್ಯಾವ್ ಅ ಕನೆಕ್ಟಿವಿಟಿ. ವಿ ಬೋತ್ ಹ್ಯಾವ್ ಅ ಕನೆಕ್ಟಿವಿಟಿ. ಓಕೆ, ಬಟ್ arrangements of the atoms is different. Clear? So we have a connectivity but the different spatial arrangements of the atoms will be there. Different spatial arrangements means what? Arrangement is different. The relation which is going till that person, that is different. Clear? But we have a connectivity. Same connectivity. Nam appaninda connectivity ಆಗ್ತಿದೆ. Okay, that relation is getting from my dad's side. But the connectivity is completely different. Clear? Now, two main types are present in us. That's what I told you, geometrical, and one is optical also. So, in the geometrical, okay, in the geometrical, you're going to learn about in the cis and trans. So, geometrical andre enen pitkobeku, cis matte trans anta nene pitkoli. Okay, optical andre enu? Optical means entemerisms. Okay, entemerisms. Okay, done. Now next comes fundamental concepts of that. That is, first one is an organic reaction, that is substrate plus the attacking reagent is going to form the intermediate or products plus the byproducts. Products plus the byproducts. Clear? Now substrate, what will be that? The molecule you focus on often supplies the carbon for the new bond. To form the new bond, often it will supply what? Carbon. To form the new bond, always it will supply the carbon. Clear? Next, what? Reaction description includes the electron movement, energetics, intermediates, and even the rates. So whatever the reaction descriptions means, ಏನೇನು reaction ಆಗ್ತಿದೆ ಅಲ್ಲ, ಅದ್ರಲ್ಲಿ ಏನೇನೇನೇನು include ಆಗುತ್ತೆ, that will be included the energetics, intermediates, and even the rates. Clear? Next comes carbocations from the heterolysis. Carbocations from the heterolysis. Let me see. So carbocation is actually equal to the carbon with plus the charge and the sixtest, that is going to be the electron deficiency, and is being classified as a primary has a 1 naught and secondary has this and tertiary has this, which is depending on the number of the C group attached, to it. Next comes the stability order, that is CH3 plus, which is going to be first has a primary, secondary, and then tertiary. This is a tertiary most stable, and the carbocations are sp2 hybridized, and it is going to be the trigonal planar. It's going to be what? Trigonal planar. Then now alkyl groups stabilizes the carbocations with inductive effect and the hyperconjugation. So whenever this alkali groups are there, that is going to stabilize the carbocations. It will get stabilized at the carbocations with what? Inductive effect and the hyperconjugation. Inductive effect mattu hyperconjugation tara. Okay. Next comes what? This is how the shape of the methyl carbocation is going to be. Okay. This shape ಇದು NCERT ಇದು. So ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ. This is also very important. So here what happens, shape of this methyl carbocation which is present, okay, shape of this which is present, this hydrolytical cleavage can also be given as spices in which carbon gets the shared pair of electrons. Example, when the group Z attached to the carbon, it leaves without electron pair. So ಯಾವಾಗ ಇದು ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಿದೆ ಅಲ್ಲ, without the electron pair only it will be transferred. Okay, ಅದಕ್ಕೆ ಆಮೇಲೆ the methyl anion which is present is formed such a carbon species which is carrying the negative charge on the carbon atom is called as carbonium ion. So whatever the species which has been converted means what, I am giving one electron to someone else, means what, I am giving the charge, negative charge ಇರುತ್ತೆ, ಅವಕ್ಕೆಲ್ಲ ಏನ್ ಕರೀತಾರೆ, ಕಾರ್ಬೋ ಆನಯಾನ್. ಕ್ಲಿಯರ್, ಕಾರ್ಬೋ ಆನಯಾನ್ ಅಂತ ಕರೀತಾರೆ. ಮೀನ್ಸ್ ವಾಟ್, ಯು ನೋ ಆಲ್ರೆಡಿ, ನಂಗೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಕಾರ್ಬನ್ ನಾ ತಗೋತಿದ್ದೇನೆ. ಓಕೆ, ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಇಟ್, ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಕಾರ್ಬೋಕ್ಯಾಟಯಾನ್. ನಾನು ಕೊಡ್ತಿದ್ದೇನೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂತ ಕಾರ್ಬೋ ಆನಯಾನ್. ಸಿಂಪಲ್. ಓಕೆ, ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡಿ. Next comes here what, one second guys, where I stopped. Carbon in carboanion is generally sp3 hybrids and its structure is associated with the hash shown in the figure. This is how the shape of the methyl carbonium ion is going to be. Clear? This carbonium ions are also unstable and reactive species. It's unstable means what, anytime it can give the electron to someone else also. Okay, and the organic reactions which process through the heterolytic bond cleavage are called as what, ionic or heteropolar. Ionic or heteropolar. Clear? And just the polar reaction. Clear? Now in homolytical cleavage, one of the electrons of the shared pair in the covalent bond means what, which is very, means it's not strong as of ionic bond. Okay, and with each of the bonded atoms, thus in the homolytical cleavage the movement of a single electron takes place instead of an electron pair. Okay, ಅದರ ಸಲುವಾಗಿ homolytic ನಲ್ಲಿ ಬರೀ single electron will be moved. Heterolytic ನಲ್ಲಿ single pair ಅಂದ್ರೆ ಡಬಲ್ ಕಪಲ್ಸ್ ಇರುತ್ತೆ, one boy one girl ಕಪಲ್ಸ್ ಅಂತಾರಲ್ಲ ಅದು. ಆಯ್ತಾ? So the single electron movement is shown by half headed, that is going to be the fish hook. Half head ಅಂದ್ರೆ ಈ ತರ ತೋರಿಸ್ತಾರೆ. Okay, this is called as half head. Means full arrow mark we are not going to put it, we are just going to put it half. Next, curved arrow such cleavage results in the formation of the neutral species, atoms or groups which contains an unpaired electrons. These species are called as what? Free radicals. ಯಾವ್ದೆಲ್ಲ unpaired electrons ಇರುತ್ತೆ ಅವಕ್ಕೆಲ್ಲ free radicals ಅಂತ ಕರೀತಾರೆ. Done. Next, like carbocations and anions, free radicals are also very reactive. So ಯಾವ ತರ ಈಗ carbocation ಮತ್ತೆ carbo anion ಹೇಗೆ ರಿಯಾಕ್ಟ್ ಮಾಡ್ತಿತ್ತಲ್ಲ, ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೊಡೋದು ತಗೊಳ್ಳೋದು, ಅದೇ ತರ ಫ್ರೀ ರೆಡಿಕಲ್ಸ್ ಸ್ಟ್ರಾಂಗ್ ಇದೆ. ಓಕೆ, ಫ್ರೀ ರೆಡಿಕಲ್ಸ್ ಆರ್ ಆಲ್ಸೋ ವೆರಿ ಸ್ಟ್ರಾಂಗ್. ಕ್ಲಿಯರ್? and are also very reactive, and homolytical cleavage can be shown as. So how the homolytical will be shown? Half head. LL half head adala, those all are homolytical compounds. Okay, half head all are going to be homolytical compounds. This is how it's going to be. Heating or by lighting, it's given the electron, half it went here, half it went here. Alkyl free radical. Done. Next, alkyl radicals are classified as primary, secondary or tertiary, and alkyl radical stability increases as we proceed from primary to tertiary. Okay, as we are going to proceed from where? Primary to secondary. Okay, primary to secondary. Now here you can just observe here, methyl is a free radical which is the less, then afterwards comes the ethyl has a free radical, next the isopropyl has a free radical, next the tetrabutyl has a free radical. Clear? Now this is the concept which is very important, which you need to understand it. Okay, ಫಸ್ಟ್ ಯಾವ್ದು ಬರುತ್ತೆ, ಯಾವ್ದು ಸೆಕೆಂಡು, ಮೀನ್ಸ್ ಯಾವ್ದು ಗ್ರೇಟರು, ಯಾವ್ದು ಲೋವೆಸ್ಟು, ಅದನ್ನೆಲ್ಲ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕು ಸರಿಯಾಗಿ. ಓಕೆ, organic reactions which proceed by homolytical fission are called as free radical, or it is also called as non-polar reaction. So whatever the organic reactions are there, okay, which will proceed, whatever the organic reactions are there, if that organic reaction is proceeding with homolytical, okay, it's proceeding with the homolytical fission, okay, then those all are things are actually called as what? Free radicals or free radicals ಅನ್ನೋನು ಕರಿಬಹುದು, ಇಲ್ಲ ಅಂದ್ರೆ ಇದಕ್ಕೂ ನಾನ್ ಪೋಲಾರ್ ಅಂತಾನೂ ಕರಿಬಹುದು. ಓಕೆ, ನಾನ್ ಪೋಲಾರ್ ಅಂತಾನೂ ಕರಿಬಹುದು. Done. Next, substrate and the reagent. This is also very important, substrate and the reagent. Then we have electron movement in the organic reaction, then the electron displacement effects in the covalent bonds. Okay, let's start with the substrate and the reagent. So whatever the ions are there, those are all generally not formed in the reaction of organic compounds. Now molecules such as participate in the reaction, it is convenient to name one reagent as substrate and the other has a reagent. Yes, we can mention one has a substrate also, one has a reagent also. Like which is a substrate? Whenever the one reaction is happening, okay, I have taken water, we have taken a salt in it, we have prepared a NaCl solution with the water. Okay, now we have prepared that solution. After preparing that solution, what is going to be the substrate and what is going to the reagent, that we are going to mention them. Okay, means what, it will help us to understand the reaction in a better way. Okay, now and has a substrate and the other one has a reagent. In general, a molecule whose carbon is been involved in the new bond formation is called as substrate. So whatever in general, how you are going to mention it? If the molecules whose carbon is been involved in the new bond formation, those all are actually called as what? Substrate. Okay, substrate yadu karitare? Wherever the carbon is being included in the formation of new bond aglike carbon involvement madide, those all are called as substrate. Done. Next comes what? And the other one is called as a reagent. Which one is remaining? No, that is called as a reagent. Now when carbon-carbon bond is being formed, the choose of the naming the reactants as a substrate and the reagent is going to be the arbitrary, and it depends on the molecules under the observation. So it depends on the molecules of that observation. Simple example kotidarili. Okay, CH2 double bond CH2, ಈಗ carbon involvement ಆಗ್ತಿದೆ double bond ಆಗ್ಲಿಕ್ಕೆ, means new bond is getting formed. Okay, so what will be the CH2 double bond CH2? That is going to act like a substrate. It's going to act like a substrate. Now next comes what? Now which is the reagent? ಈ substrate ನಾವು find ಮಾಡಿದ್ವಿ, ಏನು ಉಳಿದಿದೆ ಅಲ್ಲ ಅದಕ್ಕೆ reagent ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ಈಗ Br2 ರಿಯಾಕ್ಟ್ ಆಗ್ತಿದೆ, ಅದಕ್ಕೆ reagent ಅಂತ ಮೆನ್ಷನ್ ಮಾಡೋದು, and this will be the product. Okay, this will be the product. Clear? Next comes what? One more example they have given here. Substrate which is going to act like a benzene here, and reagent CH3Cl, product ಆಮೇಲೆ form ಆಗುತ್ತೆ. Now this substrate and the reagent identification is also very, very important. Means you will have an idea that which is actually acting, which is actually forming a new bond, and in that new bond which the carbon which is involved, that is actually called a substrate. Okay, next, nucleophiles and the electrophoresis. Now reagents attack the reactive sites on the substrate. So the reactive site may be electron deficient portion of the molecule, like a positive reactive site. Example, an atom with incomplete electron shell or the positive end of the dipole is in the molecule. If the attachment species is electron rich, it is attracts to its sites. If attacking species electron deficient, then the reactive site for it, that part of the substrate molecule which can supply the electrons, like example pi electrons in a double bond. So now what is the meaning of a nucleophiles and the electrophiles? Now whenever the reactant is attached to the reactive site of the substrate, reactive site of the substrate ನಲ್ಲಿ ಅಕಸ್ಮಾತ್ ಅಟ್ಯಾಚ್ ಆಗ್ತಿದೆ, ಏನು ಅಟ್ಯಾಚ್ ಆಗ್ತಿದೆ? ರಿಯೇಜೆಂಟ್ಸ್ ಅಟ್ಯಾಚ್ ಆಗ್ತಿದೆ. ಈಗ ಇಲ್ಲಿ Br2 ಇಲ್ಲಿ ಸಬ್ಸ್ಟ್ರೇಟ್ ಜೊತೆ ಅಟ್ಯಾಚ್ ಆಗಿದೆ, ರೈಟ್? CH2Br ಸಿಂಗಲ್ ಬಾಂಡ್ CH2Br ಅಂತ ಆಗ್ತಿದೆ, ರೈಟ್? ಮೀನ್ಸ್ ವಾಟ್? ರಿಯೇಜೆಂಟ್ ಇಸ್ ಗೆಟಿಂಗ್ ಅಟ್ಯಾಚ್ಡ್ ಟು ದ ಸಬ್ಸ್ಟ್ರೇಟ್. But whenever the reagent is getting attached to the substrate, if in case the substrate is having a less electron, means it's electron deficient, sometimes it is electron gain also, but it is in case electron deficient ideyappa portion, okay, position, then the molecules are going to be what? Positive reactive site nalli hogi react agutte. Means electrons are not completed, means it's not completed, it's octet, then it's going to be told as what? Deficient portion. Clear? Next comes example, an atom with an incomplete electron shell or a positive end of the dipole in the molecule. So that is going to be what? If in case if the attaching species in the electron rich, it attacks these sites. If attacking species is the electron deficient, then the reactive site for it, that part of the substituent molecule, can be supply the electron. It can start supplying the electron so slowly, okay, because deficient ಇದೆ ಅಲ್ಲ, electron ಬೇಕಿದೆ, so ಅದನ್ನ substitute ಕೊಡುತ್ತೆ, reagent substitute ಗೆ ಕೊಡುತ್ತೆ. Simple. Clear? Then a reagent that brings an electron pair to the reactive site is called as nucleophile. ನಾನೀಗ ಹೇಳಿದೆ ಓಕೆ, ನಾನೀಗ ಏನು ಹೇಳಿದೆ ಜಸ್ಟ್ ನಾವು ಒಂದು ಸೆಕೆಂಡ, ನಾನು ಏನು ಹೇಳಿದೆ, ಈ ಇಲೆಕ್ಟ್ರಾನ್ ಕೊಡುತ್ತಪ್ಪ, ರಿಯೇಜೆಂಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡುತ್ತೆ ಇಫ್ ಇನ್ ಕೇಸ್ ಇಟ್ ಇಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆಫಿಷಿಯಂಟ್. ನಾವು ದಟ್ ರಿಯೇಜೆಂಟ್ ದಟ್ ಬ್ರಿಂಗ್ಸ್ ಆನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ ಟು ದ ರಿಯಾಕ್ಟಿವ್ ಸೈಟ್. ಸೊ ಈಗ ರಿಯಾಕ್ಟಿವ್ ಎಲ್ಲ ಆಗ್ತಿದೆ ಅಲ್ಲ, ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಯೇಜೆಂಟ್ ಕೊಡ್ತಿದೆ, ವಿಚ್ ವೇರ್ ದ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಆ್ಯಂಡ್ ರಿಯಾಕ್ಟೆಂಟ್ ಈಸ್ ಬೋತ್. ಓಕೆ, ಸಬ್ಸ್ಟ್ರೇಟ್ ಮತ್ತು ರಿಯೇಜೆಂಟು, ಸಬ್ಸ್ಟ್ರೇಟ್ ಮತ್ತು ರಿಯೇಜೆಂಟ್ ಎರಡು ಎಲ್ಲಿ ಆಗ್ತಿದೆ ಅಲ್ಲ ಕಾಂಬಿನೇಷನು, ಮೀನ್ಸ್ ವೆನ್ ದೇ ಆರ್ ಮೀಟಿಂಗ್ ಈಚ್ ಅದರ್ ಇನ್ ದಟ್ ಸೈಟ್, ಇಫ್ ಇನ್ ಕೇಸ್ ಇನ್ ದಟ್ ಸೈಟ್ ವಾಟ್ ಎವರ್ ದ ಥಿಂಗ್ಸ್ ಆರ್ ಹ್ಯಾಪನಿಂಗ್ ಇನ್ ದಟ್ ಸೈಟ್ ವಿಚ್ ಎವರ್ ದ ಇಲೆಕ್ಟ್ರಾನ್ ಹ್ಯಾಸ್ ಬೀನ್ ಗಿವಿಂಗ್, ಡೆಫಿಷಿಯಂಟ್ ಅಂತೂ ಇದೆ, ಇಲೆಕ್ಟ್ರಾನ್ ಯಾರೋ ತಂದು ಕೊಡ್ತಿದ್ದಾರೆ, ಆ ಕೊಡು ಸೈಟ್ಗೆ ಯಾರು ತರ್ತಾರೆ ಸೈಟ್ಗೆ, who will bring that site, who will bring, that is nucleophile. Okay, nucleophile is the work where the, if in case substrate is having a electron deficient, then the nucleophile will do the work of bringing the electron to that site so that both the mutations will happen and then the product will be formed. Simple, right? Then it is called now nucleus seeking, and the reaction is called as a nucleophilic, and the reagent that takes away the electron pair from the reactive site is called as electrophile. Means what? If in case electrons are more, okay, it's not deficient, it's actually having a more electrons. So now ಈಗ ಜಾಸ್ತಿ electrons bad ಆಗಿದೆಯಪ್ಪ, ಈಗ substrate ಮತ್ತೆ reagent mute ಆಗ್ಲಿಕ್ಕೆ or mix together or react ಆಗ್ಲಿಕ್ಕೆ electrons ನಮಗೆ ಜಾಸ್ತಿ ಆಗಿಬಿಟ್ಟಿದೆ. I don't want that electron. So electrons ಯಾವ್ದು ತಗೊಂಡು ಹೋಗುತ್ತೆ, which will take, electrophile will take. Okay, electrophile is a thing where the electrons will be removed from that site. Nucleophile is adding the electrons in the site, and electrophile is removing the electrons from that site. Simple to understand. ತಿಳಿತಾ ಎಲ್ಲರಿಗೂ? ಇನ್ನೊಂದ್ಸಲ ರಿಪೀಟ್ ಮಾಡ್ತೇನೆ. ಎಲೆಕ್ಟ್ರೋಫೈಲ್ಸ್ ಅಂದ್ರೆ ಏನು, ಎಲೆಕ್ಟ್ರಾನ್ ಜಾಸ್ತಿ ಆಗಿರುತ್ತೆ, ಅದನ್ನು ತಗೊಂಡು ಹೋಗಿ ಬೇರೆದವ್ರ ಕಡೆ ಕೊಡ್ತಾರೆ. ಓಕೆ, ಇಟ್ ವಿಲ್ ರಿಮೂವ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ನ್ಯೂಕ್ಲಿಯೋಫೈಲಿಕ್ ಅಂದರೆ ಏನು, ನ್ಯೂಕ್ಲಿಯೋಫೈಲಿಕ್ನಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬೇಕಿದೆ ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಹ್ಯಾವ್ ಬಿಕಮ್ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆಫಿಷಿಯಂಟ್. ಕ್ಲಿಯರ್? ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆಫಿಷಿಯಂಟ್ ಇದೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬೇರೆ ಕಡೆಯಿಂದ ತೊಗೊಂಬಂದು ಕೊಡುತ್ತೆ. ಸಿಂಪಲ್. ದೆನ್ ನೆಕ್ಸ್ಟ್, polar reactions occur between the nucleophilics and electroplaces. So whenever the polar reactions are happening, that polar reactions are going to occur between the nucleophilic and electroplaces. So between irutte on ಸ್ವಲ್ಪ. Okay, we will be having a between thing also. Now nucleophilus attacks the electron deficient centers like electrophilic centers, and the electrophilus attack the electron rich centers like nucleophilic centers, and the curved arrows show the electron pair movement from the nucleophilic to the electrophilic, and the nucleophilics are going to be like examples HO, CN, R3, CNH3, CH2 and all. Electrophiles are going to be CH3, CO, double bond O, R3, CX, etc. These are all the electrophiles. This also you people can remember. Then in alkali halides, carbon becomes partially positive due to the polar CX bonds. So whatever the alkyl halides are present, there the carbon will become partially positive. Okay, partially it will become positive and to the polar CX bonds, to become a polar CX bonds. Okay, next comes the electron movement in the organic reaction. Electron movement in the organic reactions. Then so before that, I'll just give you people the 5 minutes break. I'll be back in 5 minutes. Okay, let's start then. Okay, let's start with the electron movement in the organic reactions. Here the movement of electrons in the organic reaction can be shown by curved arrows notation. So it also shows that how the changes in the bonding occur due to the electronic redistribution during the reaction. Okay, now to show the change in the position of the pair of the electron, curved arrow starts from the point from where an electron pair is being shifted and it ends at the location to which the pair of the electron may move. Okay, now presentation of shifting of an electron pair is given below. How the shifting is being done. Okay, now you think here double bond is there, done. So here how the shifting is been done, single bond. Clear? Now means what? See, I'll mention it here. So ಇಲ್ಲಿ double bond ಇದೆ ಆಯ್ತಾ. So one single bond ಇಲ್ಲಿ ಹೋಗ್ತಿದೆ. Means what? One single bond is meant here. We have mentioned it. Same ಅದೇ ತರ ಇಲ್ಲಿನೂ. So ಇಲ್ಲಿ ಎಷ್ಟು ಹೋಗಿದೆ? Double bonds ಹೋಗಿದೆ. ಅದೇ ತರ last one ಆಯ್ತಾ. Next comes what? Sorry, we didn't finish this, no? Okay. Movement of the single electron is indicated by a single barred fish hawks. That is going to be the half-headed curved arrows. An example, it transfers from the hydroxide ion giving the ethanol, and in the dissociation of the chloromethane, and the movement of that electron using the curved arrow can also be dispatched as follows. So this is how it's going to be done. Like half, it is means what? It is getting half-hitched, half-headed. ಓಕೆ, ಇಲ್ಲಿ ಎರಡು ಕಡೆ ಹೋಗ್ತಿದೆ ಅನ್ನೋದು ಆಯ್ತಾ. ಇದೇನು ಫುಲ್ ಬಾಂಡ್ ಹೋಗ್ತಿದೆ. ಸೇಮ್ ಹಿಯರ್ ಆಲ್ಸೋ. Like that you people need to mention it. Clear? How the where the half head is being used and how the full head is being used in the reaction transfer. Means bond ಏನು ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಿದೆ ಅಲ್ಲ, ಅವಾಗ ಯಾವ್ಯಾವ ಆರೋ ಮಾರ್ಕ್ಸ್ ಯೂಸ್ ಮಾಡಬೇಕಲ್ಲ, ಅದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. ಸೊ ದಟ್ ಮೀನ್ಸ್ ರಿಯಾಕ್ಷನ್ ಏನಾಗ್ತಿದೆ ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ ಅದರಿಂದ ಆಯ್ತಾ. Next comes electron displacement effects in the covalent bonds. Now, electron displacement occurs in the organic molecules due to the atoms or a substituent groups, and it can occur in the ground state or when the attacking reagent approaches. So, it will happen once sometimes the ground state or else when an attacking reagent is also been approaching. Avaganu agbodu. Yavaga occur agutte in the ground state nu occur agbodu. Matte yavaga attacking the reagent agiruttala means yavaga reagent ಅಟ್ಯಾಕ್ ಆಗ್ತಿರ್ತಾರ ಅವಾಗನು ಆಗಬಹುದು. ಕ್ಲಿಯರಾ? ನೆಕ್ಸ್ಟ್, ಕಾಸಸ್ ಅ ಪೋಲರೈಸೇಷನ್ ಆಫ್ ದ ಕೋವಲೆಂಟ್ bonds within the molecule and the permanent effects like inductive effect and the resonance effect. Next, the temporary effect like electromeric, there is polarizability effect seen only during the reagent attack. It's seen only in the reagent attack. Only in the reagent attack. ಓಕೆ, ಕ್ಲಿಯರ್? ಸೊ ಯಾವಾಗ ರಿಯೇಜೆಂಟ್ ಅಟ್ಯಾಕ್ ಆಗಿರುತ್ತಲ್ಲ ಅವಾಗಷ್ಟೇ ಆಗೋದು. ಅಂಡರ್ಸ್ಟುಡ್? ಅವಾಗಷ್ಟೇ ಆಗೋದು. ಕ್ಲಿಯರ್? Next is inductive effect occurs due to the unequal sharing of electrons in a bond between the atoms of a different electronegativity. Now what happens here? Creates a polar covalent bond with the partial charges like example positive or negative charges. Okay, example ಏನು ತಗೋಬಹುದು? CH3 CH2 Cl ಇದೆ. Thus where here CCl bond is actually a polar one and the carbon becomes the positive and the chlorine becomes the negative. Means what? Carbon is giving the electron to the chlorine. Clear? Next, the positive charge is transmitted along the carbon chain. This is called as inductive effect. Now how the transfer is happening? According to that, it is called as an inductive effect. Means what? It's giving the electron from the positive to the negative. Means what? Carbon is giving the electron to the chlorine. Like that. Okay. Now that is inductive effect. The effect weakens with the distance and becomes the negligible after 3 bonds. So once the 3 bond is happening, more bond are takshana, power will be less. Okay. Power will be less. Like giving electron and taking electron, for that also we need a power. Okay. It's not like I'm doing something work for you people, then I don't need an energy. We need an energy to do some or the other work. Right. Same ಅದೇ ತರ ಈಗ 3 bonds ಇದೆ ಅಂದ್ರೆ ಈಗ 2 bond ಮಾಡ್ತಿರ್ತೀವಲ್ಲ, ಆ 2 bond ಆಗುತ್ತ ಮುಂದೆನೆ most of the energy will be used. Okay, most of the energy for transferring the electrons to become two bonds is more. Already ಜಾಸ್ತಿ ತಗೊಂಡಿರುತ್ತೆ. ಮೂರನೇ ಬಾಂಡ್ ಬರೋಷ್ಟರಲ್ಲಿ ಅದ್ರ ಶಕ್ತಿನೇ ಹೋಗ್ಬಿಟ್ಟಿರುತ್ತೆ ಆಯ್ತಾ. ಇಟ್ಸ್ ನಾಟ್ ಲೈಕ್ ಕಂಪ್ಲೀಟ್ಲಿ, ಬಟ್ ಶಕ್ತಿ ಕಡಿಮೆ ಇರುತ್ತೆ ಆಯ್ತಾ. Now groups are classified into the electron withdrawing. Next comes the electron donating. Now electron means donated has an I effect, that is inductive effect. I effect and the inductive effect too, where the electron withdrawing is going to happen, and plus I effect means electron donating is going to happen. Then next comes what? Resonance structure. So how we are going to understand about the resonance structure now. So in resonance structure, how it is possible? Means what the bond transformation is happening in the resonance structure. So ಈಗಿಂತ ನಾ ಏನು ಕಲ್ತ್ವಲ್ಲ ಅದರಲ್ಲಿ ಒಂದು ಸ್ಟೆಪ್ ಎರಡು ಸ್ಟೆಪ್ ಇರುತ್ತೆ, ಬಟ್ ಇದರಲ್ಲಿ ಒಂದು ಸ್ಟೆಪ್ ನಲ್ಲಿ ಏನು ಮುಗಿಯಲ್ಲ. ರೆಸೊನೆನ್ಸ್ ಅಂದ್ರೆ ಏನು, ಎಲ್ಲಿಂದ ಯಾವ ಬಾಂಡ್ ಹೇಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಿದೆ, ಯಾವ ಪೊಸಿಷನ್ ಶಿಫ್ಟ್ ಆಗ್ತಿದೆ ಬಾಂಡು, ಅವನ್ನೆಲ್ಲ ರೆಸೊನೆನ್ಸ್ ಸ್ಟ್ರಕ್ಚರ್ ಪ್ರಕಾರ ತೋರಿಸ್ತೇವೆ ಆಯ್ತಾ. Now let us learn it in detail. Like there are many organic molecules whose behavior cannot be explained by a single, where is that? Single Lewis structure. An example is that of a benzene. It's a cyclic structure containing the alternating CC single bonds and C double bond C double bond bonds, which shows an inadequate for the explaining its benzene. Okay, inadequate for explaining its benzene. Now that characteristic properties whichever is there, as per the above representation, benzene should exhibit two different bond lengths. Okay, it should exhibit actually two different bond lengths. Now that different two lengths bond lengths which is there, which is due to the CC single bond and C double bond. Okay, example ishalla example ಮಾಡ್ಕೊತೆ. ಇಲ್ಲಿ ಒಂದು ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೇನೆ ನೋಡಿ. ಈಗ ಮೆನ್ಷನ್ ಮಾಡಿದರೆ 1 2 3 4 5 6 ಇಲ್ಲಿ ಒಂದು ಬೆಂಜಿನ್ ರಿಂಗ್ ಗೆ ನಂಬರಿಂಗ್ ಹಾಕಿದ್ದೀನಿ ಆಯ್ತಾ. Now what is happening here, how the shifting is happening, see ಇಲ್ಲಿ ನಂಬರಿಂಗ್ ಏನಾಗಿದೆ, ಸೇಮ್ ನಂಬರಿಂಗ್ ಏನೇ ಇರೋದು, but bonds are actually in a different positions. Means what, this has been shifted to here, then afterwards to here. sorry so ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಆಗಿದೆ ಬಾಂಡ್, ಆಮೇಲೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಆಗಿದೆ. That is what they have written it here. Clear? Understanding how the shifting is being done? Okay. So therefore, according to the resonance theory, the actual structure of the benzene cannot be adequately represented by any of the structures. Rather, it has been hybrid of a two structures, like 1 and 2 are called as a resonance structures. So this is actually going to be the resonance structures. Concentrate properly. Okay. Now we get another example where it has been provided by the nitromethane. Okay. Example nitromethane. Ili CH3NO2 ತಗೊಂಡಿದ್ದೇವೆ, ಇಲ್ಲಿ CH3NO2, this is a structure. Okay, ಏನಾಗಿದೆ ಇಲ್ಲಿ, nitrogen is having a double bond with the oxygen. Now how we are going to write the resonance for this? How you are going to write, this double bond is going to get transferred to the oxygen. Done. So this is going to be coming here. That is what done. So ಇದೇನು ಆಕ್ಸಿಜನ್ ಇದೆ ಅಲ್ಲ ಕೊಟ್ಟಿದೆ, it's simple, that's it. ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ದೆ ಅಲ್ಲ ಅದೇ ತರ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಇದು. Okay, ಇದೇ ತರ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಇದು. Next, however, it is known that two NO bonds of a nitromethane are the same length, that is intermediate between the NO single bond and a N double bond O, and the actual structure of the nitromethane is therefore a resonance hybrid of the two canonical forms, that is 1 and 2. Means idu 1 and 2 du canonical forms idu. Okay, now this energy actually is the structures of the molecules that is lower that of the any of the canonical structures. So for that purpose only, whatever the difference energy is there in between those things, okay, whatever the energy is there between those actual structures and the lowest energy resonance structures is called as what? Resonance stabilization energy, or it is also called as simply resonance energy. Okay, simply resonance energy or resonance stabilization energy means what? Now just now whatever the reaction ಇದೆ ಆಗಿದೆ ಅಲ್ಲ, ಈ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತ ಮುಂದೆ ಯಾವ ಎನರ್ಜಿ ಇದೆ, ಯಾವುದು ಜಾಸ್ತಿ ಇದೆ, ಯಾವುದು ಕಡಿಮೆ ಇದೆ, ಏನು ಎನರ್ಜಿ ಶಿಫ್ಟಿಂಗ್ ಆಗ್ತಿದೆ ಅಲ್ಲ, ಅದರಲ್ಲಿ ಅವಕ್ಕೆಲ್ಲ ಏನು ಕರೀತಾರೆ? ರೆಸೊನೆನ್ಸ್ ಸ್ಟೆಬಿಲೈಸೇಷನ್ ಎನರ್ಜಿ ಅಂತ ಕರೀತಾರೆ. ಡನ್. Next comes rules for writing the resonance structure. ನಾವು ಈಗ resonance structure ಅಂತ ಏನಂತ ಗೊತ್ತಾಯ್ತು. ಈಗ ಏನು ರೂಲ್ಸ್ ಮತ್ತೆ ಹೇಗೆ ಬರಿಬೇಕು ಅದನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. I told you, but I will tell it in detail now how to do it. Nuclear position remains the same. Nuclear position ಏನು ಚೇಂಜ್ ಆಗಲ್ಲ. ಮೀನ್ಸ್ ಏನೇನು ನ್ಯೂಕ್ಲಿಯರ್ ಇದೆ ಅಲ್ಲ ಅದು ಏನು ಚೇಂಜ್, just bonds will be changed. Okay. Next, number of the unpaired electrons stays the same. So ಯಾವ್ಯಾವ unpaired electron, in case nitrogen is having an unpaired electron, no problem, we'll going to keep it like that. ಕಾರ್ಬನ್ ಇದೆ, ಹಂಗೆ ಇರುತ್ತೆ, ಏನು ಚೇಂಜಸ್ ಮಾಡಲ್ಲ ಅದರಲ್ಲಿ. ನೆಕ್ಸ್ಟ್ ಸ್ಟ್ರಕ್ಚರ್ ವಿತ್ ದ ಮೋರ್ ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಇಸ್ ಮೋರ್ ಸ್ಟೇಬಲ್. ಓಕೆ, ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಜಾಸ್ತಿ ಇದ್ರೆ ಸ್ಟೇಬಲ್ ಭಾಳ ಇರುತ್ತೆ. ಇಟ್ಸ್ ಲಕ್ಕಿ ಟು ಅಸ್ ಇಫ್ ಯು ಗೆಟ್ ದ ಕೋವಲೆಂಟ್ ಬಾಂಡಿಂಗ್ ಮೋರ್. Then atoms should have a complex octets, like example H has a duplet. Less charge separation, there is more stability. So less charge separation idre more stability irutte namage when the resonance has been forming. Clear? Now negative charge on more electronegative atoms and positive charge on the more electropositive atom is actually a more stable. Yavag more stable irutte, yavaga negative charges are having a more electronegative and positive charges are having more electronegative positive. Okay, so idre more stable anta now consider ಮಾಡ್ಕೋಬಹುದು whenever the resonance structure we are writing it. Okay, now greater the charge delocalization, higher will be the stability. Okay, ಯಾವಾಗ greater charge delocalization ಆಗಿರುತ್ತೆ ಅದರಲ್ಲಿ ಜಾಸ್ತಿ stability ಇರುತ್ತೆ, means it will be having a high stabilities. Okay, so resonance effect. Okay, now in a resonance effect we have almost, one second guys, okay, we have almost two types of resonance effect. Which are these two types of resonance effect? First one is going to be what? First one is going to be the positive resonance effect, that is going to be the plus R effect, and the negative resonance effect that will be having a negative sign effect. Clear? Okay, understood? So let's learn it in detail about the positive and the negative. Okay, okay, ಇಲ್ಲಿ ಫಸ್ಟ್ ಒನ್ ಯಾವ್ದಿದೆ? ಫಸ್ಟ್ ಒನ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ವಾಟ್? ಪಾಸಿಟಿವ್ ರೆಸೊನೆನ್ಸ್ ಎಫೆಕ್ಟ್. ಇದಾದ್ರು ಈ ಪಾಸಿಟಿವ್ ರೆಸೊನೆನ್ಸ್ ಎಫೆಕ್ಟ್ ಪ್ಲಸ್ ಆರ್ ಎಫೆಕ್ಟ್ ಅಂತಾನು ಕರಿಬಹುದು. ಆಯ್ತಾ? ಇನ್ ದಿಸ್ ಎಫೆಕ್ಟ್ ದ ಟ್ರಾನ್ಸ್ಫರ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ಅವೇ ಫ್ರಮ್ ದ ಆಟಮ್. ಸೊ ಯಾವಾಗಲೂ ಟ್ರಾನ್ಸ್ಫರ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಿರುತ್ತೆ? ಅವೇ ಫ್ರಮ್ ದ ಆಟಮ್. ಪ್ಲಸ್ ಆರ್ ಎಫೆಕ್ಟ್ ಆದ್ರೆ ಅವೇ ಫ್ರಮ್ ದ atom. Clear? And the substituent group attached to the conjugated system, this electron displacement makes the certain positions in the molecule of high electron densities, and this effect is going to be aniline in the hash shown. Okay, so this is how the effects is gonna be. Okay, how it's been done, you can just check it out how the transfer is gonna happen. Okay, ಈಗ ನೀವು will understand ಮಾಡ್ಕೊಳ್ಳಿ ಪಾಸಿಟಿವ್ ಸೈನ್ ನಲ್ಲಿ ಅವೇ ಹೇಗಿರುತ್ತೆ ಅನ್ನೋದು. ಓಕೆ, I told you people what positive ನಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ ಅಂತ ಹೇಳಿದೆ ನಾನು. atom of the substituent will be away, right? ಇಲ್ಲಿ ನೋಡಿ. Okay, this is the compound NH2 ಏನೋ compound ಇದೆ. Okay, this is giving transfer to this bond. Okay, ಅದಕ್ಕೆ ಇಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಆಗುತ್ತೆ. Done. So ಇಲ್ಲಿಂದ ಇಲ್ಲಾಗುತ್ತೆ. Done. So this will be what? Here it will be formed. ಇಲ್ಲಿದೆ ಇದು. Okay, this is actually here. How where it is going? It's getting transferred here. Okay, how the transfer is happening, just check it out. Okay, ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಹೋಗ್ತಿದೆ. ಓಕೆ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಹೋಯ್ತು. ನೆಕ್ಸ್ಟ್ ಆಮೇಲೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಹೋದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? ಇದು ಹೋಗಿರುತ್ತಲ್ಲ, ಇದು ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ತಂದಿರ್ತಾರ. ಡನ್. How the resonance is happening? Clear? Now, what is the meaning of a negative resonance effect? This effect is observed when the transfer of the electron is towards the atom. ಇಲ್ಲಿ ಇರುತ್ತೆ ನೆಗೆಟಿವ್ ಯಾವಾಗಿರುತ್ತೆ? If it is happening towards the atom. Positive ಅಂದ್ರೆ away from the atom, negative ಅಂದ್ರೆ towards the atom. Okay, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? Concentrate properly. Here benzene is present. ಇಲ್ಲಿ ನೋಡಿ, ಬರ್ತಿದೆ, towards ಇದೆ. It's towards. Arrow marks you can just check it out outside. Okay, away it's happening towards the atom. Clear? Same again. Okay, how the structures are being formed. Now the atoms are substituted groups which represent plus R or minus R electron displacement effects are as follows. Now if in case plus R effect is there, the halogen there is OH, OR, OCOR, NH2, NHR, NR2, NHCOR, and minus R effect ellirutte jasti OCOH, CH, OC double bond, OCN and NO2. These are minus R effect. Means few examples to make you understand, because ella full kalitene andre yarigu agalla. I agree. So these are some examples for plus R effect and the minus R effect, which you people can learn it. Next comes what? Electromeric effect, that is going to be the E effect. Okay, electromeric effect, which is going to be the E effect. What you are going to learn here, it is a temporary effect. The organic compounds which are having the multiple bonds, a double or a triple bond, which will show this effect in the presence of an attacking reagent only in the attacking reagent only, and It is defined as a complete transfer of shared pair of electrons, that is pi electron, to one of the atoms which is joined by a multiple bond on the demand of the attacking reagent. Now this effect is going to be annulled as soon as the attacking reagent has been removed. Okay, and from the domain of this reaction, it is represented by a E, and shifting of the electron is shown in the form of a curved arrow. So this is how the shifting of the curved arrow is happening. What happens in the positive? Adral ಏನು ಕಲ್ತ್ವಿ? ಪಾಸಿಟಿವ್ ಮತ್ತೆ ಪ್ಲಸ್ ಆರ್ ಎಫೆಕ್ಟ್ ಮತ್ತೆ ಮೈನಸ್ ಆರ್ ಕಲ್ತ್ವಿ, ರೈಟ್, ರೆಸೊನೆನ್ಸ್ ನಲ್ಲಿ. ಈಗ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಫೆರಿಕ್ ಎಫೆಕ್ಟ್ ನಲ್ಲಿ ಏನ್ ಕಲಿತಿದ್ದೇವೆ? ಪಾಸಿಟಿವ್ ಎಲೆಕ್ಟ್ರೋಫೆರಿಕ್ ನಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಹಿಯರ್ ಇನ್ ದ ಎಫೆಕ್ಟ್, pi electrons which are present, all multiple bonds are transferred to that of the atom which is reagent gets attached. When the reagents get attached, same way. This is attacking reagent. Here how the attacking reagent has been getting attached. So see here, attacking reagent has been attached. ತಿಳಿತಾ? ಅವೆಲ್ಲ ಏನಾಗುತ್ತೆ? ಪಾಸಿಟಿವ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಎಫೆಕ್ಟ್ ನಲ್ಲಿ. ಓಕೆ, ಪಾಸಿಟಿವ್ ಎಲೆಕ್ಟ್ರೋಮೆರಿಕ್ ಎಫೆಕ್ಟ್ ನಲ್ಲಿ. ಈಗ ನೆಗೆಟಿವ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಎಫೆಕ್ಟ್ ನಲ್ಲಿ ಏನಾಗುತ್ತೆ? ದಟ್ ಇಸ್ ಮೈನಸ್ ಇ ಎಫೆಕ್ಟ್. ಇನ್ ದಿಸ್ ಎಫೆಕ್ಟ್, ದ pi electrons of the multiple bond are transferred to that atom to which the attacking reagent does not get attached. And for example, these are the simple example attacking reagent ನಲ್ಲಿ. These are the simple attacking reagent which people can see it. Okay. Then which when indicate an electromeric effect operate is a positive directions, and the electromeric effect is pedometric. Okay, next comes the hyperconjugation. Next comes what? Hyperconjugation. Okay, let's try to finish it. A stabilizing interaction in the molecule, it involves the delocalization of a CH electrons from an alkali group, and it happens when the alkali group is attached to an atom with an empty p orbital or double bond, and CH electrons overlap with the adjacent p orbital or a pi bond. Okay, adjacent p orbital, or else in the pi bond it will go and get adjusted. Okay, and then it provides the extra stability to the molecule. It provides the extra stability to the molecule also. Example anu kottidare, and it is also a permanent effect. So hyperconjugation permanent effect ide. Clear? So this is how the orbital diagram showing hyperconjugation in the ethyl cation. So this is going to be the empty 2p orbital of carbon. This is empty p orbital. Okay. Next is what happening is hyperconjugation is in between these two. Okay. Here empty ide. ತಿಳಿತಾ? ಇಲ್ಲಿ sp3 ಇದೆ, H1s ಇದೆ ಬಾಂಡು. ಸೊ ಇಲ್ಲಿ CH ಬಾಂಡ್ ನಲ್ಲಿ ಈ ಎರಡು ಹೈಡ್ರೋಜನ್ಸ್ ಏನಿದೆ ಅಲ್ಲ, ಎರಡು ಕಾರ್ಬನ್ದು, ಇಲ್ಲಿ ಹೈಪರ್ ಕಾಂಜುಗೇಷನ್ ಈ ತರ ಆಗುತ್ತೆ. And this hyper conjugation is going to be the permanent one. Okay, and here what happens? The carbon, this hydrogen, this is at the front end, this is at the back end. Clear? Understood how the hyper conjugation is happening in between the empty orbitals? Yes. Next, this type of overlap stabilizes the carbocation because electron density from an adjacent sigma bonds helps in dispersing the positive charges. So in general, greater the number of alkyl groups attached to the positively charged carbon atom, the greater is the hyperconjugation. So when will be the greater hyperconjugation? When there will be a number of alkyl groups attached positively. Number of alkyl groups attached positively. Then only it's going to have a greater hyperconjugation. Clear? Next, these are also simple examples they have given it here. Okay, let's move to the last part, that is types of organic reaction and a mechanism. So hyperconjugation is very simple. I have explained it properly. Make sure you people will practice those, means understand madkoli, examples nodukondu aita, examples nodukondu understand madkoli. Next comes the types of organic reaction and the mechanism. First is going to be the organic reaction. This organic reactions are classified into the substituent reactions, addition reaction, elimination reaction, and reagent reaction. Very important. Okay, Let's learn it one by one. Now, methods of the purification of organic compounds are going to be this all things. First is going to be based on the nature and the compound and the impurity. First will be sublimation. You have learnt already, but we are going to practice it again. Next comes the crystallization. Distillation kaltirbodu new, differential extraction and the chromatography. In chromatography also we have different types. Okay. Now, this purity checked by the sharp melting and the boiling point. This all things will be checked by the melting and the boiling point. So, this melting and boiling point also you people will do it. I think you might not do it. Might be your teacher will do it and show you. Okay. Now, first comes the sublimation. What is actually happening in the sublimation? The solid which is in the vapor without passing through the liquid. Okay. Solid vapor without passing through the liquid. Use it to separate the sublimation compounds from the non-sublimation impurities. Solid in the direct agi gas ki convert agutte. Clear? And what is the meaning of a crystallization? Here, the purification of a solid compounds are happening where based on the solubility difference in the suitable solvent. Means yav solvent adak prefer aguttalla adar prakarane reaction agodu. Aita? So, steps which will be involved: dissolve impure compounds in the hot solvent. So, yav impure compounds idella vella hot means you are going to serve it in the hot solvent. Okay, yav impurities idella hot solvent nalli hakidvi. Done. Next is concentrate solution to the near saturation. So, concentrate the solution. You need to concentrate it nearer to the solution. Then afterwards cool the solution. That is going to, because we have concentrated, then it will be hot because it will be releasing. Endothermic process ಆಗ್ತಿರುತ್ತೆ. Okay. Next what we are going to do? Sorry, exothermic process ಆಗ್ತಿರುತ್ತೆ. So, cool solution alli pure crystals will be formed. So, cool solution ಆದ ತಕ್ಷಣ means ಯಾವಾಗ cool ಆಕೊಂತ ಹೋಗುತ್ತಲ್ಲ crystallization form ಆಕೊಂತ ಹೋಗುತ್ತೆ. Okay. Crystallization form ಆಕೊಂತ ಹೋಗುತ್ತೆ. Then the filter crystals, that is mother liquor, contains the impurities. Okay. ಏನೇನು filter crystals ಏನಿರುತ್ತಲ್ಲ filter ಮಾಡಿರ್ತೀವಲ್ಲ ಅದರಲ್ಲಿ ಆ impurities ಎಲ್ಲ settle ಆಗಿರುತ್ತೆ and the pure compounds will be separated it out. Clear? So, this remove the colored impurities with the activated charcoal. So, activated charcoal in the colored impurities anna takkobodu easily. Colored impurities anna takkobodu easily. Clear? Then repeat the crystallization if impurities have similar solubilities. So, ಸ್ವಲ್ಪ ಇದ್ರೆ ಅದನ್ನೇ repeat ಮಾಡ್ಕೊಂತ ಹೋಗಬಹುದು so that we will get the purest one. Done? So, next comes the distillation. So, in distillation, how the process is happening? Separates ಹೇಗಾಗುತ್ತೆ. Volatile liquids forms the non-volatile impurities and the liquids with sufficient boiling points will show the differences. Okay, now what is the meaning of a simple distillation? In simple distillation, vaporizes lower the boiling liquid first and then it condensed and collected. Okay, simple distillation ನಲ್ಲಿ vaporize ಆಗುತ್ತೆ lower boiling point ಇಂದ. Means ಸೊಕಾಸ heat ಮಾಡಿ ಅದನ್ನ slowly heat ಮಾಡ್ಕೊಂತ ಕಂಡೆನ್ಸ್ ಮಾಡಿ ಇದನ್ನ ಕಲೆಕ್ಟ್ ಮಾಡ್ತಾರೆ ಇಂಪ್ಯೂರಿಟೀಸ್ ಅನ್ನ. ಆಯ್ತಾ? ಫ್ರಾಕ್ಷನಲ್ ಡಿಸ್ಟಿಲೇಷನ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಫ್ರಾಕ್ಷನ್ ನಲ್ಲಿ ಯೂಸ್ಡ್ ಇಫ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ಸ್ ಆರ್ ಕ್ಲೋಸ್. ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ಸ್ ಆರ್ ಲಿಟಲ್ ಬಿಟ್ ಕ್ಲೋಸರ್, ಅವಾಗ ಯೂಸ್ ಮಾಡ್ಕೋಬಹುದು. ವೇರ್ ದ ಫ್ರಾಕ್ಷನೇಟಿಂಗ್ ಕಾಲಮ್ ವಿತ್ ದ ಥಿಯೋರಿಟಿಕಲ್ ಪ್ಲೇಟ್ಸ್ separates the liquid by repeated condensation vaporization. By the repeated condensation vaporization, these things will be done. Clear? This is how it has been done. Simple distillation where the vapors of and substances formed are condensed and the liquid is collected in the conical flask. See, concentrate properly how it's been connected. Okay, example nodi. Idu conical is a flask. RB flask. Ee RB flask thermometer connect ಮಾಡಿರುತ್ತೆ because we are going to, according to the boiling point, we are going to do it. No. So, ಆಯ್ತಾ? ಆಮೇಲೆ ಇಲ್ಲಿ sink, correct sink ಕನ್ನಡ ಆಗಿರುತ್ತೆ where the if in case excess gases will be there, no, from there it can be removed. Why? Because if you are not removing the pressure there, pressure remove ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ apparatus might break. Okay. Then afterwards, this is a condenser where it is being maintained. Then the water inlet where you are going to pass it, and the liquid substance, I mean whatever the impurities which we have removed, the impurities that will be staying as a condenser and will be removed in the liquid substance. Clear? Next comes the distillation under the reduced pressure. So, we are going to apply a temperature, but we are going to pressure, we are going to reduce it. So, ಯಾವ ತರ pressure reduce ಮಾಡಬಹುದು? So, purities, high boiling point of decomposable liquids boils at a lower temperature under the reduced pressure. Under what? Under the reduced pressure. Clear? Next comes the steam distillation. In steam distillation, it separates the steam volatile and immersible compounds. It boils the mixture where P total, that is B compound plus the water is going to be the done. Okay, compound ಎಷ್ಟಿದೆ, water ಎಷ್ಟಿದೆ, means ಯಾವಾಗ separate ಮಾಡ್ತೇವಲ್ಲ ಏನು ಉಳಿದಿರುತ್ತೆ compound ನಲ್ಲಿ, means water plus the compound, that together is going to tell the P total. Okay, so this is how it's happening. Okay, fractional distillation ಹೇಗೆ ಆಗ್ತಿದೆ ನೋಡಿ, ಇಲ್ಲಿ fractionating column with the packing will be done here, then liquid to be distilled, ಯಾವ್ದು liquid distill ಆಗೋದಿದೆಯಲ್ಲ ಅದು ನಾವು ಹಾಕಬೇಕು ಅದರಲ್ಲಿ. This is the oil bath, how it has been, means this thing apparatus has been dipped in the oil bath here. So how the sink is gone, condenser is being connected, adapter is being connected, this is a water inlet which is present, and this is going to be the distilled liquid. So these things are little bit important to you people, means ಕೇಳಿದ್ರೆ ಕೇಳಬಹುದು ಇದರಿಂದ, but it's not that important. ಯಾವ್ಯಾವ ನಾವು ಈಗ ಕಲ್ತ್ವಲ್ಲ ಈಗಿನ ತನಕ ಅವೆಲ್ಲ ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ನೀಟ್ ಪ್ರೊಸ್ಪೆಕ್ಟಿವ್ ವೈಸ್. ಸೊ ಇವೆಲ್ಲ ಇಟ್ಸ್ ಲೈಕ್ ಅ ಸಮ್ ಲೈಕ್ ಹ್ಯಾವ್ ಅ ಎಕ್ಸ್ಟ್ರಾ ನಾಲೆಜ್ ಅಬೌಟ್ ದ ಕೆಮಿಸ್ಟ್ರಿ, ದಟ್ ಹೌ ದ ಡಿಸ್ಟಿಲೇಷನ್, sublimations are things are happening, but they might ask one question from these also. Okay, next, differential extraction, where the organic compounds in the aqueous medium shaken with the organic solvent, and the solvent and the water will immersible, that is it will form the two layers will be formed there. Okay, next comes what, this organic layers will be separated with the separatory funnel. So it will be separated with what, separatory funnel. With the separatory funnel it will be separated different way. Okay, next the compound has been recovered with the distillation or a evaporation. It will be converted from the distillation, or it will be done with the evaporation also. Some things we can do it by evaporation process also, because it's easy, time, it's a little bit time consuming, but it's easy, no waste of money. Okay, next comes the chromatography. So in this chromatography, it's actually helping us to separate the mixtures impurity compounds by the testing the purity. Okay, now first we have a types in that. First one is adsorption chromatography or a column or TLC, and second comes the partition chromatography. In this we are going to learn about the paper chromatography also. Okay, I'll show you the images also. Okay, first we'll learn about the column chromatography. Here the mixture is passing through the abundant column. Okay, ಏನ್ mixture ಇದೆಯಲ್ಲ, impurity ಇದೆಯಲ್ಲ, ಅದನ್ನ abundant column ಇಂದ pass ಮಾಡ್ತಾರೆ. Like here column chromatography ನೋಡಿ, so abundant liquid column ಇಂದ pass ಮಾಡ್ತಾರೆ. Done. Next what happens here, compounds are separated by a absorption. So compounds are going to be absorbed by a separation. Concentrate here, the solvent is here, mixture of the compounds are here. Okay, A, B, C, the mixture is the compounds do, ಈಗ ಇದು separate ಆಗುತ್ತೆ. Okay, we are separating this thing now. Okay, with the column. Now absorbent, there is stationary phase is present, and the glass hole is present here. You can concentrate how it's been separated first. Okay, we are going to mix it properly, then how it's been separated. Next what happens, you can just observe how it's been separated at the third one. Okay, different stages of the separation of a components. Okay, ಹೇಗೆ separation ಆಗ್ತಿದೆ ನೋಡಿ. So in first ಏನಿದೆ, ಇಲ್ಲಿ solvent ಹಾಕಿದ್ದೇವೆ, we have added the glass hole also, absorbent ಇದೆ, stationary phase ಇದೆ. So when you people will keep it for a longer time, in this way it is second step will be happening. After some time this will be happening. According to that, ಇಲ್ಲಿ opening valve ಇದೆ ಅಲ್ಲ, ಈ opening valve ದಿಂದ open ಮಾಡ್ಕೊಂತ ಹೋಗುತ್ತೆ, ಇದರಿಂದ ಹೋಗುತ್ತೆ. We will stop it here. First 2 3 4 5 means easily it will be separated. Next, thin chromatography. Here what happens, the adsorbents coated on the glass plate, the mixture spots, then elucate moves are happening, and the compounds will start separating. This is how the mixture, one second, yes, how it's been happening. So that is going to be the retardation factor, where the distance is moved by the system, sorry, by the substances divided by distance moved by the solvent. So how we are going to take the RF factor? Here RF factor is going to be how distance moved by the system. Okay, means system ಯಾವ ಆಗ್ತಿರುತ್ತಲ್ಲ ಆ distance ಏನು ಮೂವ್ ಆಗಿದೆ ಅದು divided by distance moved by the solvent. Solvent ಹೆಂಗ್ ಡಿವೈಡ್ ಮಾಡ್ತಿದೆಯಲ್ಲ ಅದನ್ನು, ಆಯ್ತಾ? Next, so spots detected by the UV or iodine or a hydrate spray, and paper chromatography next comes. So here the paper contains the water and stationary phase, where what happens is solvent will be rises. Okay, solvent will start rising it up, and it separates the compounds by the partitioning. It will be separating by the partitioning. Okay, this is how it's been done. Thin layer chromatography, that is chromatography being developed in the form of this. This is the solvent sample dot eniде adu. So adsorbent coated on the glass plate. It's been all coated. This is a glass plate. Okay, glass plate mele now compound hakideve. Okay, then this is a jar and this is a baseline. Done. So this is how it's been done. Paper chromatography. Okay, two different shapes ಇದೆ paper chromatography ನಲ್ಲಿ. This is chromatography paper, jar, spot, solvent. How it's been moving. Just observe here how it's been moving. Next comes the qualitative analysis of the organic compounds. Qualitative analysis of the organic compounds. Okay, once that is done, we are done with few things. Okay. So in this qualitative analysis of the organic compounds, detection of the carbon and the hydrogen, where heat compound with the CuO is done, and that that is going to get converted into the CO2, that is lime water turbidity, and H2O, that is anhydrous CuSO4, turns the blue. Means it will get turned into the blue in color. Okay, it will get turned into the blue in color. Next, detection of a N, S halogens and P by the Lessingen's test. This is also important. I think ivella nimage practicals nalli important agutte. Okay, so I'm going to be fast here. Okay, this is not important much, but have a knowledge about it. Fuse compounds with the sodium ionic form, and the sodium fusion extract tested as follows. If in case it's a nitrogen, sulfur, halogens and phosphorus. Okay, nitrogen idre FeSO4 plus H2SO4 is gonna be forming what? Blue in color, Persian blue in color. Sulfur idre enagutte lead acetate PBS black PPT, or in case sodium nitrophorus idre violet in color irutte. ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಹೆಲೋಜನ್ಸ್ ಇದ್ರೆ ಏನಿರುತ್ತೆ? HgNO3 ಇರುತ್ತೆ, ಅವಾಗ AgX PPT ಅನ್ನ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. ಫಾಸ್ಫರಸ್ ಇದ್ರೆ oxidized with the Na2O2, where H3PO4, that is ammonium molybdate, that is also going to be the yellow PPT. So idra mele questions kelidre kelbodu. Most probably they are not asked for the NEET. Okay, next, qualitative analysis of the organic compounds of a carbon and hydrogen. Same, it's repeated, sorry. Okay, this is a nitrogen process. It is nitrogen process idella Dumpson method, where it is heated up with the CuO and N2, which is being collected, and then the Kagensels method is there, H2SO4, where the NH4 and NaOH, that is a base, NH3 is being observed in the H2SO4, and the titration is happening, that percentage is happening there. Not application for the nitro or ozo compounds or a ring N. So this thing is not applied for the nitro-ozo compounds also. Clear? So this is a process how it's actually looking. Done? Now comes the halogens, that is also called as Saris method. Heat compound with the fusing HNO3 and AgNO3, AgX PPT, that is, I told you people which type of yellow color has been formed. What yellow PPT has been formed. Okay, see here, you can just observe. Yellow PPT has been formed. Done? Okay. Yes, halogen ನಲ್ಲಿ carriers method ಇದೆ. Heat compound with fusing HNO3 and AgNO3, AgX PPT is being formed. It's waved off like mass of the halogen in the M1G of the AgX is going to be calculated on the basis of atomic mass of S and M1G and molecular mass of Ag and Ex. Okay, X ಯಾವುದು ಇರಬಹುದು, ನೀವು ಯಾವ್ದು ಎಲಿಮೆಂಟ್ ತಗೋತಿರಲ್ಲ, ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದಟ್. ಓಕೆ, ಸೇಮ್ ಅದೇ ತರ ಪರ್ಸೆಂಟೇಜ್ ಆಫ್ ದ ಹೆಲೋಜನ್ ಹೇಗೆ ಫೈಂಡ್ ಮಾಡ್ಕೋಬಹುದು, ಸೇಮ್ ಅದೇ ತರ ಅಟೋಮಿಕ್ ಮಾಸ್ ಆಫ್ ದ X M1G divided by molecular mass of the AgX. Next, this is how the carriers method is going to happen, where the halogen containing the organic compounds is heated with the fusing nitric acid in the presence of silver nitrate. Okay, this is the organic compound. ಇಲ್ಲಿ ಏನು ಫಾರ್ಮ್ ಇದೆ, ಸ್ಕೈ ಬ್ಲೂ ಕಲರ್ ಏನಿದೆ AgNO3 ಇದೆ, and this is a ferning HNO3. Clear? So this ferning HNO3 ಅಂದ್ರೆ ಇದು ಯಾವಾಗ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ ನಾವು ಡಿಪ್ ಮಾಡ್ತೇವಲ್ಲ ಅದ್ರಾಗ ferning HNO3 ಆಗುತ್ತೆ. ಕ್ಲಿಯರಾ? Yes. Next comes the sulfur here. Sulfur is also same way, guys. Sulfur is also same way. Oxygen, by difference method, oxygen is often determined indirectly, and the formula is going to be percentage 100 minus percentage C plus percentage S, percentage nitrogen, sulfur, halogen plus percentage phosphorus. ಏನೇನು percentage ಆಗಿರುತ್ತಲ್ಲ ಎಲ್ಲ total percentage oxygen ನಲ್ಲಿ find ಮಾಡಬೇಕು, ಆಯ್ತಾ? So this assumes all the other elements have been accurately, it has been determined. Once we find it, we are going to just add it by the percentage oxygen. Clear? Next comes the direct estimation method. Here the stepwise procedure is there for the decomposition of the compound, then the oxidation of a CO and the measurement of the oxygen is there. So this is also direct estimation method, easy ಇದೆ stepwise. First decomposition ಆಗುತ್ತೆ, ಅದಾದ ತಕ್ಷಣ oxidation of carbon dioxide is going to happen, then afterwards the carbon monoxide is going to happen, means we are going to pass the CO by over a iodine pentoxide. So CO ಅನ್ನ pass ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೇವೆ iodine pentoxide ಮೇಲೆ. Okay, then the measurement of the oxygen is going to happen. Measurement of the oxygen is how it is going to happen. Here the percentage oxygen, that is mass of the oxygen in the CO2, is divided by mass of the compound into 100. Clear? In this way you can do it. Done? Yes. Let's see 2-3 questions. It's already late, I guess, but also we'll see 2-3 questions. Okay, try it everyone. Which of the following has the maximum number of molecules? 4GN2, 2GH2, 16GNO2, 16GO2. Come on, try this everyone. I'll give you 20 seconds here. 20 seconds ಕೊಡ್ತೇನೆ, try ಮಾಡಿ. Twenty seconds, try ಮಾಡಿ. Which will be the correct answer here? Which option will be the correct? 2GH2 will be the correct. Why? So option 1 ನಲ್ಲಿ 7 grams of N2 ಇದೆ. So ಅದಕ್ಕೆ ಎಷ್ಟು moles ಆಗುತ್ತೆ? 0.0607 ಆಗುತ್ತೆ. Right? 0.607 ಆಗುತ್ತೆ. Second ಕ್ಕೆ 1 mole ಆಗುತ್ತೆ. So it means what? 1 mole is the greatest one. Right? ಇದಕ್ಕೆ 0.0006 ಆಗುತ್ತಪ್ಪ. Your 1 mole is happening. So the option 2 will be the correct answer. Clear? Next question, try. Calculate the number of the moles of the oxygen in 1 liter of air. In 1 liter of air containing the 21% of oxygen by volume under the standard condition. So they have given few options also. Try it out. They have given few options also. Try it out. 20 seconds again. So the number of the moles of oxygen, approximately how much it will become? So you need to take moles of a O2 is equal to volume of the O2 divided by molar volume of the STP. How much it will be the answer? 0.21 divided by 22.4 ಆಗುತ್ತಲ್ಲ, right? 0.21 So in calculate ಮಾಡಿದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ? Come on, try to do it. I'll see in my calculator right now. ಎಷ್ಟಾಗುತ್ತೆ ಚೆಕ್ ಮಾಡಿ. 2 to 4 ಇದು. Okay. 2 to 4 correct. You people are correct. Tell me which will be the O2. Volume of the O2 divided by molar volume of the STP. Volume of the O2 standard temperature pressure. Okay, ಎಷ್ಟಾಗುತ್ತೆ ಡಿವೈಡ್ ಮಾಡಿದ ತಕ್ಷಣ? 0.0093. Okay, correct. 0.0093. Thank God we got the answer. Option A will 1 will be the correct answer. Done. So I'll give you people few questions as a homework. So few questions I have given you as a homework now. So you need to solve it everyone 2-3 questions solve ಮಾಡಿ ಚೆನ್ನಾಗಿ ಕುಂತು. ಸೊ ಇಫ್ ಯು ಪೀಪಲ್ ಆರ್ ನಾಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ದ ಪ್ರಾಬ್ಲಮ್ಸ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ಥಿಯರಿ ಅಂತ ಫುಲ್ ಪರ್ಫೆಕ್ಟ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದೇನೆ. ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ಆಲ್ಮೋಸ್ಟ್ 3 hours ಟು ಫಿನಿಶ್ ದ ಥಿಯರಿ ಓನ್ಲಿ. ವಿ ಹ್ಯಾವ್ ಫಿನಿಶ್ ದ ಥಿಯರಿ ಲಕಿಲಿ. ಸೊ ಈಗ ಥಿಯರಿ ಅಂತೂ ಫುಲ್ ಪರ್ಫೆಕ್ಟ್ ಆಯಿತು. ಇನ್ನು ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನ ನಿಮಗೆ ಬೇಕಂದ್ರೆ ಸಪ್ರೇಟ್ ಆಗಿ ಸೆಷನ್ ಮಾಡ್ತೇನೆ. ನೀಟ್ ಆನ್ ದಿಸ್ ಚಾಪ್ಟರ್ ಓನ್ಲಿ. ನೀಟ್ ಆಲ್ PYQs we will sit and solve. But before that you need to be perfect with the theory chapter. So make sure that you will be perfect with this chapter, so that next time when I'm going to come live, that time we are going to do full PYQs of NEET. Clear? Till then, see you everyone. All the best for your NEET preparations. Do well. Don't waste your time. Yes, bye. So don't waste your time. Make yourself motivated. Be hydrated every time, and make sure you people will learn it properly. Till then, see you everyone.